Okay, listen carefully. Now we are going to start climatology. Okay. Now, yeah, this is our sun. Okay, sun. It is having higher energy. Higher energy implies shorter wavelength. Why? Because E equal to hc by lambda. That is why the incoming solar radiation it is short wave in nature. Why? It is because it is emitted from sun. The terrestrial radiation it is long wave. Why? Because it is emitted from earth. So this is simple logic that everyone know. Why incoming solar radiation is short wave and why terrestrial radiation is long wave. Okay. If wavelength is more, then energy of the body which is emitting must have been lower. Right. That is why wavelength is high. Right. And also you need to know different kind of waves that sunlight has. We have radio to gamma. I memorized it with a trick. Okay. We are having radio and radio whenever you are starting it of course microwaves will be emitted. Okay, and then when the microwaves are emitted, TV became red, and after that redishness we see some visibleness, and then using that remote which is having UVX gamma buttons, we are going to press that. Okay, now next again, that is my pictographic memory. Now let's start it. Radio, micro, IR, visible, UV, X, gamma. UV, X, gamma. Okay. Out of all of them, this box is important. The middle box. IR it is having more wavelength compared to UV. Implies energy of IR it is lesser than energy of UV. Okay. Remember that this whatever I said you this that is for wavelength. It is not for energy. So always remember that we spoke for lambda. Okay. This pictographic memory is for lambda. And since we are starting with radio, it is having higher wavelength. Okay. And next, as we have already discussed, shortwave solar radiation it is transparent to greenhouse gas. Greenhouse gases will say welcome to earth when the solar radiation is coming, but when terrestrial long wave radiation is going back, greenhouse gases will say there is a long way to go back. So they are long in nature and there is a long way to go back. They behave like opaque. Okay, so that is the reason. But why terrestrial radiation greenhouse gases are behaving opaque? The reason being is simple. Most of the terrestrial radiation they are going to have UV rays. UV rays they are having shorter wavelength. Sorry, not UV rays. The UV rays they are having shorter wavelength. So not UV rays. They are having IR rays. Most of the terrestrial radiations are having IR rays because they are having longer wavelength. Longer wavelength implies lesser energy. So most of the terrestrial radiation is going to constitute by which rays? IR waves. Okay, and most of the incoming rays they are going to be UV. Do you listen that ozone layer is getting depleted because of incoming UV rays from the sunlight? Yeah, most of the incoming rays are due to UV rays, and most of the outgoing rays they are due to IR waves. Okay, and these greenhouse gases they are behaving opaque to IR rays. Why? Because the reason is simple. Now solar radiation they are having UV rays mainly, and UV rays they are having shorter wavelength. Okay, shorter wavelength they can easily pass. Therefore, they are behaving transparent. But what about IR waves? If they are IR waves, then they are having longer wavelength because IR waves, obviously, they are having longer wavelength. So they are going to be trapped by these greenhouse gases. Okay, that's the logic. Okay, IR waves, they get trapped by the greenhouse gases, but UV rays, they escape very easily. Even if there is some minute UV rays which is being reflected by the earth, then of course that will be passed by the greenhouse gas easily. अरे ओजोन लेयर ही खुद नहीं रोक पा रही है यूवी रेस को, इसलिए होल बन गया. तो क्या ग्रीनहाउस गैस रोकेगी इसको? No, they can easily pass. UV rays, they can easily pass through this greenhouse gas. Okay, that's one logic. And next, you need to know what are the different greenhouse gases and how are they different from air quality index. Air quality index, it is having 8 pollutants. Okay, so I first initially tried to memorize air quality index pollutants, and then I thought, okay, these are not greenhouse gas. For example, I remembered with AQI with this trick, son of cop. So S stands for sulfur dioxide, N stands for nitrogen dioxide and ammonia, S stands for sulfur dioxide, and O stands for ozone, and CO for carbon monoxide, and P, the remaining three, PB, that is lead, PM10 and PM2.5. So these are the 8 pollutants under AQI, which I used this mnemonic to memorize. And then we have greenhouse gases. So whatever are there in AQI, I just copy pasted here, and I said that they are not greenhouse gases. And there is one more gas, nitric oxide. That is also not a greenhouse gas. We have carbon dioxide, methane, nitrous oxide, and water vapor, which everyone knows that they are greenhouse gas. Carbon dioxide, if anyone don't know, then I will laugh at them. Honestly, it is a greenhouse gas. And methane, it is in buzz. It is in buzz. Why? Because after burning, stubble burning is in the news. So after burning that, methane is being released drastically. So that is also one reason why methane is in the news, and it is also greenhouse gas. So both of them are greenhouse gas, and everyone knows that this water vapor is also a greenhouse gas. Nitrous oxide, that is also a greenhouse gas. And then we have fluorocarbons, HFC, perfluorocarbon, sulfur, tetrafluoride, etc. They are also greenhouse gases. Okay, I am saying that sulfur dioxide is not a greenhouse gas, but it can act as indirect greenhouse gas, not a direct greenhouse gas. Indirect implies it can react with some other reactants, and finally it can promote aerosols. And aerosols they act as greenhouse gases. Okay, that can happen. Okay, and nitrogen dioxide, it is not a greenhouse gas, but it can lead to promotion of nitrous oxide, which is N2O. Similarly, ammonia can also generate nitrous oxide. So they might not be greenhouse, but somehow or the other they can generate greenhouse gas. Okay, so when the examiner is asking indirectly contribute to greenhouse gas, all of the options are almost going to be correct. Okay, so these are the main greenhouse gas that everyone must know. And this ozone, which is common in AQI and GHG. So ozone, tropospheric ozone is also a greenhouse gas. Okay, as I already said, IR waves, they are mostly opaque to greenhouse gas, but UV, it can easily pass through greenhouse gas. Okay, but Earth do not much emit UV. Now let us discuss the story of hydrofluorocarbon. I think I have said you right. Hydrofluorocarbon, it is a greenhouse gas. So from where are they released? They are released mainly from air conditioners and fridge. Okay. What happened was earlier we were using chlorofluorocarbons, but it was leading to a lot of ozone depletion. Why? The reason is being simple. Chlorofluorocarbon, it is having chlorine radical, and it is contributing to further reactions. Okay, that is why we decided that we need to curb this chlorofluorocarbons. And later we bought this hydrochlorofluorocarbons. चलो अब हमने अब hydrogen add कर लिया, तब तो ozone depletion कम होना चाहिए. So it actually reduced ozone depletion, but not that much. And then later they came up with hydrofluorocarbons, which completely removed the chlorine radical. Okay, so hydrofluorocarbon are currently being used in the refrigerators, ACs, air conditioners, etc. But you know what? The problem they have observed is hydrofluorocarbon. It is having a global warming potential, higher global warming potential. Okay, it ranks number one in higher global warming potential. So despite being despite contributing less to ozone depletion, it is having higher global warming potential. So therefore, in the Kigali Amendment to the Montreal Protocol in 2016, which was adopted but later enacted in 2019, they finally decided to reduce this hydrofluorocarbon, and hydrofluorocarbon they replaced it with chlorofluorocarbon. Seriously, that is again ozone depleting. How can they replace? No, they did not replace actually. They are thinking which can be the best replacement, and they have seen this, but this is not a feasible option as we can see. It can again deplete ozone. Currently, now it is in the safe level, I think. And again, at the least global warming potential, as you can see, it is for hydrochlorofluorocarbons. So we must come to a medium stage. Okay, that's the story of hydrofluorocarbon. Okay. So under this Montreal Protocol, India has three commitments mainly. So first, we will put 3 years, 2028, slowly phasing out 2028, 2038, and then we have 2047. Okay, these 3 years. So basically, India said that we will put a freeze year 2028, and after this year, companies they cannot exceed the 2024 to 2026 baseline. पता है इसका मतलब क्या निकलता है? So companies basically they are saying that okay, we will do a lot of production so that we can increase the limit, and finally once 2026 get over, the barricade is already high, so within that limit only we will be producing. So companies might use this loophole. Okay, government is saying this way will put as our baseline, and after crossing this 2026, we are going to not further use. I mean 2028 is the freeze year. Freeze year implies if, for example, if a company want to cross this baseline production, then they require clearances from the government. That's all. So that is the freeze year. So government is saying that we will stop our production from 2028. So 2028 will be the freeze year, and our baseline will be 2024 to 2026. Okay. And between 26 to 28, they might slowly take time to transition to reach this 2028. Okay, transition में ही 2 साल और लग जाएगा. And then we have 2038. So India adopted this ICAP, India Cooling Action Plan. India Cooling Action Plan, ICAP. So what does ICAP imply? It implies 20 to 25% reduction by 2038. 20 to 25% reduction by 2038. Okay, that is ICAP, India Cooling Action Plan. And next after that we have in 2047. What is that? 85% by 2047. India said that we will reduce our production by 85% by 2047. Okay, 85% reduction by 2047. Sorry, 85% reduction of hydrofluorocarbons by 2047. Are 47. See, I am 2000 born, so technically 85% reduction by 2047. It's a lot. So 2047 it's a large time, right? That is why the standard, I mean the limit is also high. 2047 तक 85% का reduction होना चाहिए. So this is the story of Montreal Protocol. So tell me, what is the difference between a natural global warming effect and a human enhanced greenhouse effect? So this is greenhouse effect, right? Greenhouse, हमने सुना होगा greenhouse. It's like a box. So there is a natural and there is human enhanced. So there are two ways. See, that main difference is that natural and human enhanced. So greenhouse effect, it is lesser in natural and more in the human enhanced. That means let's imagine sunrays reaching to the earth. Okay, so you know greenhouse gases, they are transparent to incoming radiation, so they are going to come, but they are opaque to outgoing terrestrial radiation. So certain rays they can be blocked, but certain rays they will again go back to the space. So the amount that is going back to the space, it is higher. It is higher for natural effect. Okay, more energy is released back. For example, water vapor. Water vapor, it is a natural greenhouse gas. So water vapor, it is allowing the passing of the terrestrial radiation, right? So water vapor, it is not stopping much. Now we are having human enhanced greenhouse gases like carbon dioxide. So again the same scenario, when sunlight is coming into the earth, there is outgoing terrestrial radiation. So carbon dioxide, it traps the outgoing terrestrial radiation. That's the reason why a lot of energy is being trapped here, because this light, it cannot go back. Why? Because greenhouse gas is trapping that high heat energy which is in the form of terrestrial radiation. Therefore lesser energy will be released back to space, because energy is being trapped here only. So less energy is released back to space. Therefore greenhouse effect, it is higher in the human enhanced methods than in the natural methods. So that's about the greenhouse effect. So what are the side effects of UV rays? They can come to the earth. I mean the ozone layer, it can try to stop, but yeah, they will come to the earth, and finally they can even go back from the earth, because the greenhouse gas, they are not going to stop them much. Even if they are able to stop, it is very minute. Okay, they are having shorter wavelength and they can easily go back, but it's not the same with IR. When they come to the earth, they are trapped when they go back. Okay, that's the difference. And then that is why we call UV as harmful. I mean UV, it can go back easily, but UV coming to earth itself is harmful for us. Why? The reason being, it is harmful. Why it is harmful? Because it can generate skin cancer, cataracts, crop yields can be reduced, and it can damage marine life, and yeah, it can also damage certain synthetic biopolymers. Okay, that it can also affect the biogeochemical cycles also. That is why we say UV rays, they are harmful. Okay, now if you see the structure of atmosphere, we are having a different levels. Okay, troposphere, stratosphere, mesosphere, thermosphere, ionosphere, and whatnot. Okay, we are having all those, but now currently I'm not discussing them. I am discussing where and all we can find these greenhouse gases. Okay, ozone, tropospheric ozone, it is found below 50 kilometers only, somewhere about 10 kilometers and somewhere below 50 kilometers. Okay, so basically 10 to 50, how much did you add? 40, right? The same amount 40 you need to add, and now you will get 90. So between 50 to 90 kilometers or below 90 kilometers, you can find carbon dioxide and water vapor. Okay, and from 90 kilometers to 120 kilometers, you can find oxygen. Sorry, you can find oxygen. तो ऑक्सीजन बहुत ऊपर मिलेगा, ओजोन नीचे मिलेगा. ये क्या देख रहे हैं हम? ओजोन विच नीड्स टू बी इन द स्ट्रेटोस्फीयर, हम इसको नीचे देख रहे हैं, ट्रोपोस्फेरिक ओजोन, एंड ऑक्सीजन विच वी नीड टू ब्रीथ, दैट इज अबव 90 किलोमीटर. It is below 120 and above 90, so it's in the top. Okay, the greenhouse gases, they are not allowing them to meet. So what are those greenhouse gases? Carbon dioxide and water vapor. Okay, so these are the four that I memorized. So these levels they will be asked in the exam. So in between what levels is the oxygen found? So that will be asked. So at least, yeah, at least try to remember this 10 and 50 and think that okay, I added 40, I need to add 40 and it will become 90. So 90 है तो चलो 120. Try to remember. Okay, and next. In the atmosphere we have different gases, right? The topmost gas is the nitrogen. Okay, that constitutes 78%. These are the major gases. Okay, nitrogen, it contributes 78%, and next we have oxygen, which is 21%, and argon 0.9%. Nitrogen, oxygen, they are the highest, so everyone know these percentages from childhood. But argon, it is the third highest, that is 0.9%. And next we get to see water vapor, which varies from 0.001 to 4%, even 4%. Yeah, it can vary. And then carbon dioxide we have 0.04%. So yeah, हम oxygen ही ज़्यादा पी रहे हैं, that is 21%. Okay, and we have dust. Dust is also there in the atmosphere. Dust includes sea salt, pollen, ash, smoke soot, fine soil, etc. They are all dust. Now let us see hygroscopic nuclei. What is hygroscopic nuclei? Hygroscopic nuclei is nothing but dust particles. These particles they have the affinity to attract the water molecules. That is called hygroscopic nuclei. And where are they mostly found? They are found in the subtropical high pressure belt and the temperate low pressure belt. Subtropical is somewhere in the 30 degree north or 30 degrees south, whatever. And then tropical subtropical high pressure belt and temperate low pressure belt. There you are having what? There you are having dust particles. Okay, these are the areas where dust is high. So what are the four layers that you even know? Equatorial low pressure belt, subtropical high pressure belt, temperate low pressure belt, and polar high pressure belt. Okay. So near the equatorial low and polar high, there you are not having any dust particles. Because equatorial na, it is low pressure area and lot of gas. I mean that troposphere itself it extends up to lot. I mean how much we will see later, but yeah, it extends to a lot of height. Therefore, the dust particles are usually not near the equatorial, but near the subtropic high and tropical low, there are significant dust particles. Okay, that is something you need to know. Now this is the main topic structure of atmosphere. So everyone know troposphere, stratosphere, meso, thermo, exo. But the height no one memorizes. Okay. We have 10 kilometer, 50 kilometer, 80, 400. So how I memorized? 10, 50. There also it is 10, 50. So easy to be memorized. And then मैं 80 को याद करूंगी, 90 को नहीं. Okay, here it is 80. If it is structure, it is 80. आर्ट वाला structure अच्छा है ना. So if it is structure, it is 80. The structure looks good. So therefore, it is for structure of atmosphere, you will remember 80. For oxygen, where greenhouse gases are present, there you are going to remember 90. Okay. So 10, 50, 80, 400. Okay. 10, 50, 80, and 400. And that's all. So less than 10 it is troposphere, and 10 to 50 it is stratosphere. More than 50 and less than 80 it is mesosphere, and 80 to 400 it is thermosphere, and more than 400 it is exosphere. 400 के बाद exosphere आएगा. Now you need to understand that ionosphere it is present in between mesosphere and thermosphere somewhere here. So when they ask majorly where, then I will say that ionosphere it is in the thermosphere. Okay, I mean it is present in between them, but the major it is in thermosphere. Okay, that is the reason why temperature it increases with height in the ionosphere and stratosphere also. Stratosphere the reason is being ozone. Because ozone layer, I think it absorbs a lot of UV radiation, right? That is the reason why with the increase in height, the temperature will increase in the stratosphere, and due to ions, the temperature increases with the height. Okay, yeah. Rest of all, there is no temperature inversion. I mean, with increasing height, the temperature it drops. Okay, that is in the troposphere and mesosphere. And then I am drawing these lines, right? These lines they are called pauses. For example, above mesosphere, we see mesopause. So when you ask me where is mesopause, it is at 80 kilometers. Okay. And tell me what is the use of ionosphere? Is there any main use? See, let's take a radio tower and let's take one more radio tower. Okay. Basically, this radio tower it is emitting signal to the ionosphere, and this ionosphere it will reflect back to the another radio tower. Okay. That is how the signals are being transmitted, and that's why ionosphere it is a very helpful layer for our radio tower signal transmission. That's one more thing. So everything feels easy now. Just remember that in the exam hall, 10 को 5 के साथ multiply करेंगे, 80 को 5 के साथ multiply करेंगे, बाकी सब हो जाएगा. Okay, that's all. And next let us see how this occurs. I mean how the temperature distribution occurs. Okay, troposphere, stratosphere, mesosphere, thermosphere, and exosphere. Now let us see. So this is 20 and this is somewhere between -100 and -80, right? So what happens is that in the troposphere, you know one thing, one logic. What is the logic? With height, the temperature drops. Therefore, you are going above. Now the graph must go to the x-axis, but again you need to go top. So which direction it will go? This direction, right? So yeah, this direction you went. And then here the temperature it has stopped at -80, and then again with height the temperature is again increasing. You need to go top side, and again you need to go to the right side because temperature is increasing with height. Therefore the vector this will be in this direction. So yeah, the graph again moves in this direction, and again at -20 you have stopped, and you have realized that now you enter into mesosphere and temperature must drop. Okay, and so temperature it again went to the left side, and then it stopped at -90, and again you realize you enter into thermosphere. Here there is ionosphere, therefore my temperature will increase. Again I need to go to the right. So that's how the graph will continue. Okay, and the layers you remember where is stratopause, mesopause, etc. Multiply with 5, and 80 multiply with 5. Okay, that's all. And you know the troposphere I'm saying 10 10 always, but it's not always 10. Near the equator it extends up to 18 kilometers, 18 1 8 near equator, and near the poles it is 8 kilometer. Okay, so average करेंगे तो 13 kilometer is going to be there. Again, we are saying that with increase in height, the temperature is dropping. How much degree Celsius it is dropping? Approximately 1 degree Celsius per 165 meters. Remember one thing, okay? They sometimes convert into kilometers and they say 0.165 kilometers. Remember only one thing. I'm remembering it in meters. So minus 1 degree Celsius drop for 165 meters, you go above. That is lapse rate, okay? Minus 1 degree Celsius per 165 meters above. Now there might be a question, water vapor is highest at where? Is it near equator or near poles? See, water vapor equator के पास ही ज़्यादा होगी. That's obvious thing. Okay. I think it is somewhere around 4% water vapor. Okay, ये बहुत highest है and that is 4%. I mean, 4% को ही हम बहुत highest बोलते हैं. Some options they might be saying 25%, etc. Such kind of MCQs might also come. That is roughly around 4%. 4% of what? 4% of total volume of air. Okay. There are some questions they ask that okay, water vapor it is highest at equator and roughly 25% बोलेंगे तो वो गलत होगा. It is only 4% of the total volume, but still it is highest at the equator. Okay. Now next let us see solar radiation, which is 8th chapter of NCERT. And there is incoming solar radiation which we call as insolation. Okay, insolation कितना है हमारी अर्थ कितना रिसीव करती है per centimeter square minute? It receives 1.94 calorie per square centimeter minute. That is insolation. 1.94 approximately 2 calories per square centimeter minute. Okay, and this is the top layer. Now let us come to this. Right, we have already discussed insolation, which is 2 calorie per centimeter square. And when you see this top layer of atmosphere, okay, and when you take this square centimeter in a minute, how much of sunlight it is receiving, how much insolation, it is approximately 1.94 or 2 calories. Okay, now if you see sun, the farthest position from the sun is different from closest position. Okay, closest position it is called perihelion, and farthest it is nothing but apart. Apart it is called aphelion. Okay, apart. July is a month of lovers breakup. That's how I remember. So July 4, 4 lovers are breaking apart. That's how I memorized July. July apart. So July 4. Somehow I think I've seen a movie. That's why. Okay. Anyways, so apart that is July 4th, and nearer it is perihelion. Okay, and then when you see the Earth rotation, when Earth is apart, when Earth is far away from the sun, then Earth moves slower. Now, I know this formula F equal to G m1 m2 by r square, and I know this mv square by r. That's how I'm going to equal centripetal force with gravitational force. Now, if the distance is far, if they are apart, r is going to be large, then force is going to be reduced. If force is going to be reduced, then this value v, this is also going to be reduced. Okay, that is also going to be reduced. Force g m1 m2 by r. So this r is less, f will be larger, and therefore velocity will be larger. And next, it is far again. Therefore, since the length is high, force will be low, and if the force is low, then velocity it is going to be lower. Okay, therefore velocity of earth it is low when it is at aphelion, when it is apart from sun, and velocity it is fast when it is closest to the sun. Okay, that is perihelion. So January 3 and July 4, perihelion and aphelion. Aphelion is July 4 and perihelion is January 3. Okay, remember that the insolation during the aphelion it is lesser than the insolation during perihelion. Why? See, aphelion that means you are apart, you are far away from earth. Of course, the insolation it is going to be lower, and similarly at the perihelion insolation you are nearer, therefore insolation will be higher. But anyways, throughout the earth, if you see, it varies based upon the land and sea distribution and the atmospheric circulation. The insolation can vary. Okay. So these are the areas where you can see varying of insolation. For example, rotation of Earth on its axis. As Earth rotates around its axis, what is going to happen? The insolation it is going to be on the one side only. On the other side, there is not going to be any insolation. Right? Only one half receives the sunlight. So rotation it is 23 hours 56 minutes, and it receives only on the one side. So that's how rotation of Earth affects insolation. And next, let us see angle of inclination of sun rays. So you know, right? Earth it is tilted. For example, if you take this our Earth axis, Earth will rotate like that. Okay, that tilt if you see, that is 66 and off. That is the angle between the Earth axis and plane of orbit around the sun. It is 66 and off degree. Okay. And when you see the vertical area, it is lesser than the slant area. I mean, the slant, if you take slant wise, there you will see more distribution compared to direct fall. For example, let's say this ray is directly falling. If it is directly falling, then the entire insolation it is pointed at a single point. But if the rays are slant, then of course the distribution will be larger. Okay, if a distribution is larger, then per area, per unit area, if you see, it will reduce. Therefore, that is what I was trying to say. If area is slanted, then energy it will be reduced. Therefore, near the subtropics, you get to see maximum insolation due to the tilt, and it decreases towards the poles. Okay, that is angle of inclination of sun rays. And next, you have length of the day. Okay, you see summer. Summer it is having longer days. Why? Because it is experiencing the lighter half summer. So basically, Earth is this side. So during summers, we experience longer days and longer insolations. So a lot of insolation we see in the summer. So the length of the day also depends. And next, transparency of the atmosphere. If atmosphere is clean and if there are no clouds, of course, insolation is going to rise. And then we have configuration of land and ocean. Yes, it depends upon the distribution. Like if the water is closer to land, then land it heats faster because it is having lesser specific heat, and water it heats slower because it is having more specific heat and it can absorb a lot of energy. Since water is having 4.2 joules, I mean larger specific heat compared to land. Land is having only 0.8 joule per gram degree Celsius. That is why specific heat of water it is higher than land, and that is why it heats slower. So it depends whether the insolation is falling on the ocean or whether it is falling on the land. If it falls on the water, then I cannot really say its a temperature is higher. Why? Because it has a more capacity to absorb, so it will not get heated easily. So it depends whether it is falling on land or on the ocean. Okay, that's it. And let us see different belts like equatorial low, subtropical high, temperate low, and polar high. So tell me, where is the maximum insolation that you can see? It is near the subtropical high pressure belt. And where exactly in the subtropical high pressure belt? It is near the subtropical desert. There is a maximum insolation because desert area में clouds नहीं है, बादल नहीं है, बारिश नहीं है, and the drop it is ditto vertical, and there are no slant trace. Okay, therefore subtropical deserts they are receiving the maximum insolation approximately 320 watt per meter square. Okay, that is the energy that they are receiving. Polar high pressure belt approximately 70 watt per meter square. Okay. And you need to know three things: conduction, convection, and advection. Convection is vertical transfer of heat, and advection is horizontal transfer of heat. That's all. And conduction it is through contact. एक सरफेस दूसरी सरफेस के साथ कांटेक्ट करेगी, कंडक्ट करेगी, ऐसे ऐसे हीट का ट्रांसफर होगी. ओके, यू कैन नॉट नेसेसरली से इट इज वर्टिकल हॉरिजॉन्टल, मोर लाइक इट इज कॉन्टैक्ट बेस्ड. ओके, दैट्स ऑल. फॉर एग्जांपल यू नो अ हीटेड लैंड गॉट हीटेड, सो देयर इज अ लो प्रेशर लैंड, तो ये बहुत हॉट हो गया है ना, so what is going to happen, there is going to be transfer of heat through how the heat is going to be transferred through conduction. Okay. So tell me the examples of convection, vertical transfer of heat. So maybe some air currents that I cannot recall. That might be vertical transfer of heat. What about horizontal? When I can see easterlies and westerlies, right? So they are horizontal transfer of heat, easterlies, westerlies, and local winds. They are all horizontal transfer of heat. Okay. Maybe these winds are helping for advection. That's all. And next, let us see what are local winds. See, due to advection, there can be some local winds. Okay. Example, low winds. They are warm local winds, and they are seasonal winds, and they occur only during the summer. Okay. And greenhouse gases, they don't observe the incoming insolation, which you already know, and they only observe the outgoing terrestrial radiation. Okay. And using this technique in US and UK, we started adopting greenhouse plants. So basically what they're going to do is that they're going to set up these artificial lights, and plants are going to be there. And so what's going to happen here, the plants are going to receive sunlight. तो एक आर्टिफिशियल स्ट्रक्चर ये लोग क्रिएट करेंगे, इसमें प्लांट्स ग्रो करेंगे. चलो, उसके बाद क्या होगा? ऑब्वियसली देयर माइट बी सम ग्रीन हाउस गैसेस. प्लांट्स ड्यूरिंग द नाइट टाइम दे रिलीज कार्बन डाइऑक्साइड, राइट? सो द ग्रीन हाउस गैसेस एंड वाटर वेपर एक्सेट्रा, दे आर गोइंग टू बी देयर. So what's going to happen? These greenhouse gases, they absorb radiation. They absorb the heat during the night time mainly. I mean, they absorb the heat and they keep the room warm. So वार्मिंग इंक्रीज हो जाएगी, ग्रीन हाउस का वार्मिंग इंक्रीज हो जाएगी. उससे क्या होगा कि ये गर्मी रहेगा. बट व्हाट्स द पर्पस? सी, आउटसाइड इट इज वेरी कूल. हियर you cannot grow those crops. You can only grow these crops in the warm sunny temperature. That is the requirement. I mean, that is the reason why you choose to grow certain plants in the greenhouse. So US UK they adopt these greenhouse plants. Okay. And next we have what? Advection. Advection I already said na ki advection is horizontal transfer of heat. I mean, maybe you know, Hadley cell, Ferrel cell, polar cell, they are all advection. And when you see vertical transfer of heat, let's say there is a low pressure and that's why heat is getting transferred, that is convection. Okay. Conduction is also, I think, vertical transfer almost, I mean, in the most of the cases. Let us try to understand heat budget of our planet Earth. Okay, we have short wave solar radiation and long wave terrestrial earth radiation. Okay, so what's the difference between them? Now let us see 100% solar energy. Let us think that 100% solar energy is being received by the top atmospheric layer. Okay, out of 100% solar energy that Earth is receiving, 35% it is reflected. Okay, let us say 35% it is reflected by the atmosphere. That 35% it is called albedo, 0.35. So atmosphere is having 0.35 का albedo, and then 14% it is being absorbed by the atmosphere. तो बचा कितना है? Earth के पास कितना आएगा? 35 plus 14 मिला के 49. So Earth absorbs 51%. Okay, that is shortwave solar radiation. And again we have long wave terrestrial radiation. Now you know that Earth absorbed 51%. That 51% it must be emitted back again. So अब 51% वापस emit हो जाएगी. इसमें 34% ना it is absorbed by the atmosphere. And if you do 51 minus 34, it is 17. That 17% it is radiated back to space. Okay, and that is vertical transfer of heat, which is convection. So now basically you need to remember certain facts. That is the Earth it is receiving 100% solar radiation, but atmosphere it is having 0.35 albedo. So remember, first thing you need to remember is 0.35 albedo of atmosphere. So 35% it is reflected, and then 35% reflected, 14% it is absorbed by the atmosphere. This is 7 table, right? 7 5 is 35 and 7 2 is 14. So 0.35 is the albedo and 14% it is absorbed by the atmosphere. तो Earth के पास कुल मिला के 49% गया. 49% गया तो 51% बचा जो अर्थ ऑब्जर्व करेगी. अब जो अर्थ ने ऑब्जर्व किया इसको एमिट भी तो करना है. 50% ऑलमोस्ट 50%. सो 100% आया, लेकिन उसमें 50% तक ही अर्थ ने ऑब्जर्व किया, 51% तक ही अर्थ ऑब्जर्व किया, 41% एटमॉस्फेयर ने ऑब्जर्व कर लिया, या फिर 35% रिफ्लेक्ट हो गया. ओके, दैट्स हाउ यू नीड टू मेमोराइज. एंड नेक्स्ट, लॉन्ग वेव. Now Earth, since it absorbed 51%, the Earth, I mean the atmosphere above the Earth, that will absorb 34%. पहले इनकमिंग में एटमॉस्फेयर 14% absorb कर लिया, एंड देन आउटगोइंग में फिर से 34% absorb कर लिया एटमॉस्फेयर. ओके, तो कितना जाएगा बाहर? 17%. So that 17% will go to space. Simple. Long wave earth radiation is very simple. 51% it came to the earth na. Out of that 51, 34 it is absorbed by atmosphere, and only 17 it radiated back to space. This is a easy number to memorize at least. So if a question comes, total heat absorbed by the atmosphere, that is going to be how much? That is going to be 14 plus 34. That is approximately 48. So 48% it is going to be absorbed by 14 plus 34, because 14 here and 34 here. Therefore total heat absorbed will be 14 plus 34, 48. Now if they ask you total heat radiated from earth to space, तो अर्थ से स्पेस के पास कितना गया? दैट इज इनिशियली आई थॉट ओके 35 रिफ्लेक्टेड, एंड स्पेस से कितना गया? यहाँ पे 17 है ना, तो वो 17 भी. आई यूज्ड टू डू 35 प्लस 17. नो, यू नीड टू डू 48 प्लस 17. ओके, व्हाई? बिकॉज सी, अब अर्थ ने जितना एटमॉस्फेयर ऑब्जर्व किया, आई मीन एटमॉस्फेयर ने जितना सनलाइट ऑब्जर्व किया, वो पूरा स्पेस में ही जाना चाहिए ना. So 14 plus 34, it is going to give 48. That 48 plus the 17, that will be the amount reflected back to space. So basically, now revising the facts, 100% solar energy and 0.35 albedo of the atmosphere, and this is the 0.35 albedo of the atmosphere, and then that means 35% it is reflected, and again 14%, 7 table, 14% it is absorbed by the atmosphere. So earth के पास बचा कितना 51. If you subtract 100 minus 35 minus 14, and then convectional, since earth absorbed 51, 34 will be absorbed by the atmosphere and 17 will be radiated back to space. Now I will make a diagram. Okay, now this is the diagram, right? Yeah, now we are seeing short wave. तो earth atmosphere का albedo कितना 0.35, so 35% it is reflected. तो आया कितना something 100 minus 35. इसमें atmosphere ने कितना ऑब्जर्व किया 7 table, that is 14%. तो earth के पास कितना आया 51%. Okay, that is short wave clear. अब earth के पास कितना है 51%. now long wave terrestrial. तो इसमें से atmosphere फिर से कितना ऑब्जर्व करेगी 34%. तो बाहर कितना जाएगा 51 minus 34 जाएगा. 51 minus 34 is 17. तो वो radiated back to space. Now if I ask you total percentage of heat that is radiated back to space, that will be total absorbed, that is 14 plus 34, कुल मिला के 48, 14 plus 34 minus 14 plus 34 plus 17, that is the total heat that is radiated back to space. Okay, that these are the numbers that you need to know. Now next, you need to also make a observation that total insolation is equal to the total outgoing. I mean, see, earth is receiving insolation of 65 and it is also emitting a 65. I'll show you again insolation. So 100 minus 35 कितना 65. So that one I'm calling it as insolation, and that is 65%. And outgoing में again insolation, outgoing terrestrial radiation. Now outgoing, how can I say, this is 17. Okay, लेकिन स्पेस में सिर्फ 17 नहीं जा रही है, स्पेस में और क्या क्या जा रही है 14 प्लस 34 प्लस 17 है ना, so that is 65. That 65 is going, so now we are able to match insolation to outgoing, that is this albedo is 0.35 but insolation is 65%, that we are able to match with the total outgoing radiation back to space, 34 plus 14 plus 17. Okay, that is all that you need to know. And next, now let us see the variation in heat budget. Now if you see this planet earth, now I am taking this equator, okay, and this is 90 degree north and this is 90 degree south. We have a variation in heat budget. I mean, see, you know, right, the surplus, it is between 40 degree north and 40 degree south. Why? Because it receives lot of insolation. So global heat balance, if you see, the equator area and the tropical areas, they are receiving a lot of insolation. That is why they are having heat surplus, and the polar areas, they are suffering from heat deficit, which is very easy to be memorized. And between 40 degree north to 40 degree south, somewhere you will see heat surplus. Okay, this you can plot in this direction also. Let's take this as our 90 degree north, that is poles, and let us point this equator in the middle, and this is 90 degree south. Okay, from 40 degree north to 40 degree south, as we can see, it suffers from what? It suffers from surplus. That is heat surplus due to a lot of insolation. And here you can see 90 degree to 40 degree, there will be heat deficit. Okay, and this is the energy measured in watt per meter square. Okay, but this global heat balance, it will not always be stayed, because to counter this global heat balance, we have some atmospheric circulation and oceanic mechanisms. So despite having a higher heat, the oceanic mechanisms and atmospheric circulation, they help to balance the heat in overall. Okay, because we need to cover this surplus to the deficit and deficit to the surplus, etc. That is the reason why we have atmospheric and oceanic mechanisms, and 80% of the countering mechanisms are atmospheric mechanisms and 20% are through ocean currents, oceanic mechanisms. Okay, and next let us see the factors that are controlling the temperature. Latitude, yes, lower latitudes they have higher temperature, and then altitude. Okay, as you go above the, as you go to the mountain, as the height increases, the temperature it will decrease. Okay, and as you go above, what is the lapse rate? Minus 1 degree Celsius per 165 meters, right? Did it become 6.5 degree Celsius per kilometer? Maybe it is also correct. What did we see? 1 degree Celsius. How much for 165 meter? Now you need to check for 1 kilometer, that is 1000 meters. Okay, what are you going to do? Cross multiplication, 1000 by 165. कितना होगा ये? Might be somewhere around 6.5 only. That is why they said 6.5 degrees Celsius per kilometer. Okay, this is also correct. Remember anything, minus 1 degree Celsius per 165 meters, or 6.5 degrees Celsius drop as you go 1 kilometer. Okay, that is roughly, I calculated it is somewhere around 6.06 something. Anyways, so that is latitude and this is altitude. And next we have distance from the sea. As you go towards the sea, I mean, let's say our land is near the ocean. So if it is near the ocean, then what's going to happen? Land breeze and sea breeze might be there, and that can also affect temperature, right? Okay, and next we have air mass circulation. We have warm air and cold air. So if warm air currents are moving in that region, then it will experience high temperature. And next we have oceanic currents. Warm oceanic currents bring warm temperature. So these are some of the factors controlling the temperature. Okay, and next you know isotherm, right? Lines joining places with equal temperature on map. Okay, that they are called isotherms. They are parallel to latitudes. That's all. Generally, they are parallel to latitude, but it cannot always be the case, because you are just drawing lines which are connecting equal temperatures. So, for example, if you see in the month of January, they deviate towards the north in the ocean. How? I'll tell you. Listen. Okay, in the January, in the northern hemisphere and also in the southern hemisphere, you can generally observe that they are deviating towards the north. Why? Because see, here you are going to observe warm equatorial oceanic currents. Okay, now what's going to happen? They are going to drift towards the northern Atlantic Ocean. Okay, so this is hot and this is cooler. Northern side is cool. Okay, now you need to connect. So during January, what's going to basically happen is that land, it cools faster than the ocean, because oceans are having specific heat. बहुत ज़्यादा होगी specific heat ocean का. That is why lands they cooler faster than ocean. Okay, of course ocean का specific heat ज़्यादा है, इसी वजह से oceans ना हर चीज़ में देरी करेगी. So they are slow in everything. In January, for example, the land must cool. It will cool faster only. But oceans, it will take a lot of time to get cool. So that's the reason. Okay, basically यहाँ पे warm oceanic currents होगी ना, ये तो cool है. तो इसका मतलब क्या निकलता है कि isotherms को तो ऊपर ही जाना चाहिए, तो वो ऊपर जाएगी. Okay, in the southern hemisphere also, if you observe this region, it is hot. But you know, in the month of January, only the upper half you can see that it is winter, but the below half it is summer. Therefore if it is summer, land जल्दी हीट होगी ओशन से ज़्यादा. So if you see this is hot but this is also hot, तो most probably ये पैरेलल ही होगी. अगर डिविएट करना है तो थोड़ा ऊपर ही डिविएट करेगी. क्यों? क्योंकि ये बहुत ज़्यादा टेंपरेचर है ना, तो यहाँ पे ज़्यादा टेंपरेचर है ओशियंस में नियर द इक्वेटर. दैट इज व्हाई इट विल डिविएट अगेन टुवर्ड्स द नॉर्थ ओनली, बट मोस्टली दे आर पैरेलल. ओके, दैट इज व्हाट आई कैन से अबाउट southern hemisphere in the month of January, because in the month of January north receives winter and south it receives summer. Okay, and next we have July. July they will not ask you question only because ocean will take a lot of time again to heat back and again to cool. During the month of July it will always stay parallel. Okay, that's it and that's all. ये बहुत सारे ग्राफ्स है जनवरी जुलाई के बीच में. Okay, there are different types of isotherms in NCERT. I think we cannot memorize all of them. Okay, and next let us see temperature inversion. See, temperature inversion, as you go above, temperature is increasing. That is temperature inversion. Okay. Usually what happens, as you go above, temperature drops. How much does it drop? It drops by 6.5 degrees Celsius as you go 1 kilometer above. Okay. We have two types of lab state. One is ELR and the other is NLR. ELR का मतलब environmental lab state and NLR का मतलब normal lab state. Okay. That's all. As you go 1 kilometer above, that might be around minus 6.5 degrees Celsius. Okay. And next we have longer winter nights. So these are the reasons why there is a temperature inversion. First is the longer winter night. When winter night is long, of course there is a clear sky and there is still air. So that is the reason why there is a radiative cooling from the land. So there will be heat loss from the land. During that time, what is going to happen? Heat is going to be dissipated, right? Heat dissipate होके ऊपर चली जाएगी. That is why the land below it is having lower temperature because the heat dissipated to the above. Clear sky है ना, तो ऊपर चली जाएगी. Sky clear है, winter है ना, the sky clear है and long winter night, so there is also still air. So that is the reason why यहाँ पे cool है due to radiative cooling. ऊपर गर्मी है ना. Winter में नीचे cool है, ऊपर गर्मी है, especially during long winter and clear sky. Okay, that's the reason. That's all. That is long winter night. There you can see temperature inversion. And next we have polar areas. Polar areas also there are one areas where you can observe temperature inversion. For example, you know snow, right? What does it do? It reflects. It has a lot of albedo. तो यहाँ पे हमेशा cool ही रखेगी, ऊपर गर्मी रखेगी. Because why? It is reflecting heat always due to high albedo. That is why heat it will go back. So polar areas there also you can observe what? You can observe temperature inversion. And next let us see hilly areas. Happens in the hilly areas. Let's say this is daytime. So in the daytime, this mountain top it will be having low pressure because it is hot, and here we are having high pressure because it is cool, right? Okay, so remember that during daytime mountain will become low pressure, which you can already guess. Now what is going to happen? The air moves from high pressure to low pressure. Got it? Therefore during daytime we are going to have valley breeze. But during night time, what is going to happen? The scenario changes. Now this becomes high pressure because it is night time and the top surfaces they are cool, and this is low pressure, right? This is high pressure. So the cooler denser area, the cool denser air particles, they slowly start to move down, right? That is called mountain breeze. So in the night time we get to see mountain breeze. Got it? This is called as air drainage. So the movement of air particles from high pressure to low pressure, or this mountain breeze during night time. This mountain breeze during night time is also called as air drainage, and this phenomenon protects plants from frost damage. Why I am saying that this temperature inversion prevents frost damage? Why? Because simple. See, पेड़ पौधे कहाँ पे होंगे? यहीं पे होंगे, right? When the cool denser air, when it is going downward, that will ultimately prevent the frost damage, right? यहाँ पे पेड़ पौधे थोड़ी होंगे. So it is preventing frost damage. So I am marking it as mountain breeze. So mountain breeze is also an example of temperature inversion. We have seen three till now: long winter night, polar areas, and mountain breeze. Temperature inversion, if we look into broadly, they can be surface inversion or upper air inversion. Surface inversion implies this temperature inversion happens near the ground, and upper air inversion implies it is happening higher in the atmospheric layers. So near the ground implies, what's the example for it? Rapid cooling of ground at night. What is that called? Radiation of earth, terrestrial radiation. That is something happening near the surface. Let's say this is surface. So here immediately due to radiative cooling, this is becoming cooler. This is warm, and of course the top is coolest, but if you are seeing immediately near to the ground, this is cooler and this is warm. That is why we are calling it temperature inversion. That kind of examples come under the surface inversion examples. Valleys during night time, just now we have seen, right? Mountain breeze, that is also an example for the surface inversion only. But if you are seeing upper air inversions, which is higher in the atmosphere, let's take this. So this is the top layer of atmosphere, and here to here you are comparing that this is cool and this is hot. Such kind of temperature inversions are called upper air inversions. The best example is anticyclone. In anticyclone, it is high pressure, not low pressure. Cyclone is low pressure and anticyclone is high pressure. Okay, anticyclone it is high pressure. Now the top one is low pressure. What's going to happen? This is going to be the direction, right? See, usually it's from high pressure to low pressure, but that is during horizontal. In horizontal scenario, you are going to consider high pressure to low pressure. But when you consider vertical scenario, that logic don't work, right? That we have already seen. Right? Let's say this is low pressure and high pressure. Got it? Horizontal transfer हो सकती है, लेकिन vertical में हम high pressure to low pressure ऐसे फॉर्मूला नहीं लगा सकते, क्योंकि low pressure it is warm and warm air it raises above and it subsides down. तो हमेशा ये है कि हाई प्रेशर एरिया पे सबसाइड होगी. गॉट इट? तो ये हाई प्रेशर है तो यहाँ पे सबसाइड होना चाहिए ना, तो सबसाइड होगी जो भी है. दैट काइंड ऑफ सिस्टम इज कॉल्ड एंटी साइक्लोनिक सिस्टम. सो इन द एंटी साइक्लोन्स इफ यू ऑब्जर्व हाई प्रेशर it is high pressure, therefore it is cool, and it is low pressure, therefore it is hot. Okay. Also, I want to tell you that there is a difference between tsunami and a cyclone. The cyclone, anticyclones, whatever we are talking. Tsunami, it is inside the ocean. So let's say there is some water quake, and then there can be a tsunami. लेकिन tsunami पानी के अंदर है. Okay, if you stuck into tsunami, you will go deep into the water. That is tsunami. But cyclones, they are on the top. They originate here at this level. Cyclones, typhoon, hurricane, they are all the same thing, different names. For example, cyclone, it is called cyclone in India. In India, we are calling cyclone anticyclone. India, this you can remember. Typhoon, ऐसा नाम कौन देगा? China देगा. Typhoon. Okay, hurricane. Who give these kind of names? USA, Australia. No, USA. Sorry, USA give this name hurricane. And what does Australia give? Willy Valley. That is Australia. So we have different names for cyclone. That is the example for cyclone and anticyclone. Okay. Now we need to see the other differences between surface inversion and we are seeing that only na surface inversion and upper air inversion. Surface inversion is basically near the ground, upper air inversion is higher in the atmosphere, and the example is rapid cooling of ground at night, and the example for this is anticyclone. And we also have short term and long lived. What is short term and long lived? Surface inversions are short term, easy peasy to remember. Why? Because see, we are saying daytime and nighttime. Nighttime there is rapid cooling, and daytime again land will become hot. So that is basically short term. Okay, upper air inversion it is long lived. See, mains a lot of people think what to write in the mains, but you need to generate another point from the already existing point by thinking of different dimensions. Like for example here the dimension that I could think of time period, that is one dimension, and location, where does it happen. So all such kind of dimensions you can observe a pattern when you are repeatedly seeing mains questions. Okay, now here I took a dimension time, so I'm saying it is short term and it is long lived. Cyclones are long lived. Okay, cyclones are long lived compared to this surface inversion. Upper air inversions are long lived. And next what we are having an important conclusion about pollutants, that pollutants they are trapped in this upper air inversions. Okay, they are trapped permanently below. Why? Because here it is cool na, it is cool. तो हमेशा विंटर के टाइम पे आप देखोगे फॉग क्यों क्रिएट होगी, क्योंकि पोल्यूटेंट्स आर ट्रैप्ड एंड अपर वी आर क्रिएटिंग हॉट. तो ये पोल्यूटेंट्स ऊपर या नीचे अटक के गई ना. Here also, if you see, here also there are pollutants which are trapped. Okay, let's say this is earth, this is cooler air, this is warm air. That is what temperature inversion. And again above you are having cold air. So basically here also particles are trapped. Here you can create smog. Smog creation is possible. In both of the cases, pollutants are trapped. Okay, so that is the main difference between surface inversion and upper air inversion. It is near the ground and it is higher in the atmosphere. Examples you can know. Okay, now one more question: gradual sinking of air and fast sinking of air. Which phenomenon is seen as more temperature inversion? See, before explaining that, I need to tell you what is adiabatic cooling and adiabatic heating. Okay, let's say there is an air parcel on the lower Earth atmosphere. Now this air parcel, when it expands, when it moves above, it will expand. Why do you think it will expand? Because atmospheric pressure, it is very high here. Because how is atmospheric pressure measured? Let's take this mercury barometer, and the amount of volume of air you are having here, that will increase here, rho gh. But when you go here, the pressure, rho gh, it is less, rho gh2. Which pressure is higher, rho gh2 or rho gh1? Obviously h2 is higher, so atmospheric pressure it is higher here compared to here. Here the atmospheric pressure is low. Therefore, since there is low pressure above, as the air parcel moves above, it will expand. That is called adiabatic expansion. Got it? Adiabatic expansion is also called adiabatic cooling. Why I am calling it as cooling? Cooling because see, ऊपर क्या रहेगी, नॉर्मल सिनेरियो में देखेंगे, अगर हम ऊपर जाएंगे तो टेम्परेचर घटेगी. So here the temperature is low, pressure is also low. Therefore, that is leading to expansion basically. And in the same scenario, if you see descending air, see here now we are having particle air mass in the atmosphere. Now this air is descending. So if the descending parcel of air comes down, it is going to be compressed. Okay, तो हम इसको ऐसे ड्रॉ करेंगे. अब ये क्या हो रही है, ये डिसेंड हो रही है नीचे. अगर वो डिसेंड करती है तो एक ये क्या हो जाएगी, ये कंप्रेस हो जाएगी. सो इट इज़ गोइंग टू बी कंप्रेशन. एंड नीचे टेम्परेचर ज़्यादा होगी या कम होगी, ज़्यादा होगी. सो टेम्परेचर इज हाई हियर. गॉट इट? That is basically called heating. So adiabatic heating is nothing but adiabatic compression. Okay, and why did it compress? Because the atmospheric pressure is very high there. Atmospheric pressure is very high here. Got it? High atmospheric pressure. समझ में आ गया यहाँ पे low atmospheric pressure. Low pressure. Okay, low atmospheric pressure. So that's the difference between adiabatic cooling and adiabatic heating. I have discussed that example because I need to explain you the difference between gradual sinking of air and fast sinking of air. See, I will explain you like this. Gradual sinking of air का मतलब है कि air है यहाँ पे. Now it is sinking. That is what we have discussed, right? सिंक होने के बाद क्या होगी, कंप्रेस हो जाएगी. एंड टेम्परेचर नीचे ज़्यादा है या ऊपर ज़्यादा है? टेम्परेचर नीचे ज़्यादा है, ऊपर कम है, राइट? सो एज यू गो अबव द टेम्परेचर ड्रॉप्स. दैट इज़ नॉर्मल सिनेरियो. तो हम इस एग्जाम्पल में ऐसे लेंगे, ये यहाँ पे एक है तो नीचे नीचे आके फाइनली ये बन रही है ना. सो नाउ आई एम टेकिंग वन मोर एयर पार्सल हियर एंड वन मोर एयर पार्सल हियर. नाउ आई एम टेलिंग दैट एज द एयर सबसाइड्स डाउन, व्हाट्स गोइंग टू हैपन इज दैट दिस particle must have more temperature, but in between layers what's going to happen is that this layer, the layer above, usually this is having high atmospheric pressure, it is more compressed in place, it must have high temperature. But there is a phenomenon where if it is gradual sinking of air, the air mass above it further compresses, it compresses even more. Okay, तो ये compress हो रही है धीरे धीरे, और ये ऊपर वाला ना ज़्यादा compress होना शुरू हो जाएगी इससे कंपेरेटिवली. एज यू आर मूविंग डाउनवर्ड ना, ये ऊपर लेयर्स एक पॉइंट पे ऐसे होगा कि ये ज़्यादा कंप्रेस होना लग जाएगी कंपेयर टू द वन दैट यू आर हैविंग हियर विच इज़ बिलो इट. तो ये ज़्यादा कंप्रेस होने की वजह से क्या होगा, इसका टेम्परेचर ज़्यादा होगा कंपेयर टू दिस. लेट्स से इसका टेम्परेचर है 10, तो इसका बन जाएगा 15. ओके, इसका टेम्परेचर ज़्यादा होगा. सो दैट काइंड ऑफ फिनोमेनन हैपेंस व्हेन देयर इज ग्रेजुअल सिंकिंग ऑफ एयर. ओके, टेम्परेचर इन्वर्शन. बट इफ इट इज फास्ट सिंकिंग ऑफ एयर, you cannot see such thing. Okay, this is also called subsidence inversion. Remember, whenever they are maintaining you, they are mentioning you subsidence inversion, remember this example, that in the gradual sinking of air, you can see adiabatic compression. There you can see, if you take any two upper atmospheric air masses, you can notice that the temperature has dropped. The temperature has dropped here. Not dropped. Basically, the warming is more here. Compared to the layer below it. Got it? That is gradual sinking of air. Now we have two things, cyclone and anticyclone. See, when it is revolving around low pressure zone, that is cyclone, and if it is revolving around high pressure, that is anticyclone. We are having air from high pressure zones, right? They are going to move and finally concentrate on the low pressure. See, air moves from high pressure to low pressure and finally सारे air इकट्ठा हो गए. And low pressure का मतलब होता है hot. Okay, since it is hot, the air it must raise above. So air will rise and finally it will create this cyclone. Okay, basically cyclone is nothing but low pressure converge and raise. Got it? Remember the trick, low pressure converge and raise, that is cyclone. Anticyclone का मतलब होता है high pressure sink and diverge. तो ऊपर से आ रही है आगे इस हाई प्रेशर जोन पे सबसाइड हो रही है, एंड देन हियर ऑनवर्ड्स दे आर जस्ट सिंकिंग एंड डाइवर्जिंग. सच काइंड ऑफ थिंग इज कॉल्ड एंटीसाइक्लोन. Now see, cyclones, it is important for both prelims and mains, and direct question if it is coming on cyclone, you need to draw this diagram in the exam hall. High pressure area से क्या हो रही है, पहले लो प्रेशर पे कॉन्सेंट्रेट हो रही है. सो फ्रॉम देयर व्हाट इज गोइंग टू हैपन, कन्वर्ज एंड राइज. दैट इज द ट्रिक वी हैव डिस्कस्ड. ट्रिक क्या है साइक्लोन का? लो प्रेशर, कन्वर्ज एंड राइज. हाई प्रेशर, सिंक एंड डाइवर्ज. दैट इज एंटी साइक्लोन. ओके, तो अब हम साइक्लोन का देख रहे हैं. लो प्रेशर, कन्वर्ज एंड राइज. तो हाई प्रेशर से लो प्रेशर पे आ गया. सो वेरेवर दे आर कन्वर्जिंग, दैट इज द आई ऑफ द साइक्लोन. ओके, दैट्स द आई ऑफ द साइक्लोन. एंड फ्रॉम हियर यू कैन सी दैट ये कन्वर्ज एंड रेज है ना, कन्वर्ज हुआ. अभी कन्वर्ज होने के बाद रेज होना चाहिए. क्यों? ये गर्मी है. लो प्रेशर का मतलब होता है वार्म. सो वार्म एयर, इट मस्ट रेज अबव. सो इट रेजेस एंड इट गोस. ओके, ये ऐसे नहीं रेज होगी, ऐसे रेज होगी. डायग्राम से समझ नहीं आ रहे उतने अच्छे से. ऐसे ऐसे एंड फाइनली ऐसे. ओके, so that is how it raises. Got it? That is why you are calling it a cyclone. It raises in this fashion. So basically they are raising in the vertical direction, right? For every action there is opposite reaction. So therefore there is a warm air around this eye wall which will be subsiding down. Okay, बेसिकली आई वॉल में क्या होगी, ऊपर जाएगी एयर, वार्म एयर ऊपर जाएगी, लेकिन ड्यू टू ऑपोजिट रिएक्शन कुछ एयर नीचे सबसाइड हो जाएगी अंदर. गॉट इट? बट व्हेन दे आस्क यू फॉर लो प्रेशर, आई मीन इफ दे आस्क यू फॉर साइक्लोन, यूजुअली यू विल कंसीडर फॉर आई वॉल. एंड आई वॉल में स्पीड ज़्यादा होगी विंड का. एंड इफ दे आस्क यू क्वेश्चन विच कंपोनेंट ऑफ द साइक्लोन इज हैविंग द हाईएस्ट स्पीड ऑफ द विंड, दैट विल बी योर आई वॉल. आई वॉल में विंड का स्पीड बहुत ज़्यादा होगी. ओके, या now they are telling that this is the direction of storm, so you cannot imagine all the direction, it changes actually depending. So for this I have a trick. Like first I am going to draw this, and then I am going to draw like this, easy peasy. You can also draw this diagram. Now tell me what direction is this? ये clockwise है. चलो अब what is this direction? This is anti clockwise. You can identify this is anti clockwise, this is clockwise. Now what I am doing is high pressure, low pressure. Okay, high pressure से क्या है? High pressure से sink and diverge. So what type of cyclone? Is it cyclone or anticyclone? It's an anticyclone. So in this diagram, whenever you see high pressure, that is talking about anticyclones. And in this diagram, whenever you are seeing low pressure, that is basically talking about cyclones. First point. Okay, high pressure it is for anticyclones and low pressure it is for cyclones. Now I'm going to tell second point. This whatever I have drawn, this is for the northern hemisphere and this is for the southern hemisphere. So if a question is asking you the direction of a cyclone in southern hemisphere, you need to choose this box. This is southern hemisphere, and they're asking for cyclone, so you need to choose this, not this. Okay, you are going to say that it is in the clockwise direction in the southern hemisphere. Direction of cyclone is clockwise in the southern hemisphere and anti-clockwise in the northern hemisphere. So it depends on the hemisphere actually, which hemisphere it is in. So finally you have seen the difference between cyclone and anticyclone. Great. See, since we have discussed adiabatic cooling and heating also, I want to tell you these values. Okay, if in case in the exam if they're going to ask you adiabatic lapse rate or environmental lapse rate, what is the answer that you can give? You easily remember that 6.5 degrees Celsius drop for every 1 kilometer that you go above, right? That is adiabatic or environmental lapse rate. But remember, if they are mixing you with a dry or wet, that will change. For example, if an examiner is asking dry adiabatic lapse rate, it is dry, so therefore the drop is going to be very high because it is dry. That is 10 degrees Celsius per kilometer. Okay, what is value for wet, or you can also call it saturated. Wet or saturated adiabatic lapse rate, it is going to have 5 degrees Celsius drop for every kilometer that you go upward. So therefore in the exam if they ask you which adiabatic lapse rate is the highest, you need to say dry adiabatic lapse rate is higher than wet adiabatic lapse rate. See, if you see humidity, they can be classified into different types of humidity. They are confusing. So let us see. First of all, what is humidity? Humidity is the amount of vapor or the amount of precipitation that it can happen. Okay, so based upon the type you are going to say the definition. For example, if an examiner is asking me absolute humidity, I am going to say it is the mass of water vapor that exists within a given volume of air. Mass of water vapor that exists within a given volume within the given volume of air, that is absolute humidity. So absolutely we are taking volume, that is absolute humidity. If they are asking me specific humidity, I will tell the examiner that it is the mass of water vapor given in grams per mass of air that I am taking in kgs. So it is gram of water vapor divided by the kilogram of mass air. So tell me, I am taking an air parcel. Now can I calculate absolute humidity? Yes, you can calculate. Can you tell that it is constant? No, I cannot tell, because volume, this volume of the air parcel, that is varying. If it goes above, it will expand, so it will vary, right? It will vary. So as you go, it varies. Therefore absolute humidity, it varies. But if you see specific humidity, it is constant. Okay, because you are taking per kg mass of air. Specific mass में तुम बता रहे हो, so that is not varying. Got it? That is constant. And the final is the relative humidity. Relative humidity measures the possibility of raining. Simple. It is measured in percentages. So you are going to do this and you are going to get some percentage. अगर relative humidity ज़्यादा है तो बारिश हो जाएगी ना. See, water holding capacity, maximum water holding capacity at a given temperature is in the denominator. Now the water capacity of your air is in the numerator. अगर ये water maximum capacity को reach करेगी तो relative humidity 1 हो जाएगी, I mean 100% हो जाएगी. तो 100% का मतलब बारिश होना. Okay, that is measuring the relative humidity, the possibility of rain. Okay, measured by water capacity that air is holding divided by the maximum capacity that it can have at a given temperature. Got it? Okay. Now an examiner is asking me about temperature. They are saying me that absolute humidity depends upon the temperature. My answer is no. Okay, it depends on the volume, but it doesn't depend upon the temperature. But if the examiner is asking me for relative humidity, I will say that it is depending on the temperature. Okay, one thing, absolute humidity does not depend upon the temperature. Relative humidity depends upon the temperature. That is why I have written at a given temperature. Okay, first point to be noted. And the second point is absolute humidity determines the amount of precipitation. It is the amount of precipitation. But relative humidity will tell you the possibility of precipitation. Like if it is, let's say, 77, so I'm going to tell, okay, 77% chances are that it is going to rain. Simply that is probability. इसको मैं सीधा probability बोल दूँगी, possibility of rain. But here if I'm measuring, I'm saying the amount of precipitation, that amount of water that the atmosphere is having. It is very different. Now I have a question for you. Let's take this India map. Okay, my question is, why is the day temperature maximum in the May and why not after the summer solstice? So for explaining this, I'm asking you why the day temperature, it is not maximum. I mean, it is maximum. It is actually maximum in the month of May, that everyone knows. But why not it during the summer solstice? That's my question. So first, what is the summer solstice? No, I did not explain, so I will explain. See, this is how it works. Sun तो center में है. अब क्या होगा? Earth के अंदर कुछ tilt है. So this tilt we can see. Now Earth is rotating around its own axis, and a certain part it receives insolation, right? Here, as you can see, most of the northern part it is receiving insolation. Then therefore it is called summer solstice, and it is seen in the month of June. Okay, 21-22. 21-22 examiner change नहीं करेगा, whatever date, but it is in the month of June. Okay, and winter solstice it is in the month of December. Here you can see southern hemisphere it is being covered. Okay, and we have equinox, and we have two equinoxes basically. So one half is getting see, here one half is getting the full sunlight, right? Here you can observe that the day and night they are the same on this one day. Equinox happens on 2 days a year. One is on March 21st, another is on September. So that time you can observe that the length of the day and night they are equal. So it happens 2 times a year. One is on March 21st, another is on September, where length of the day equal to length of the night. Okay, अगर day 12 hours है तो night भी 12 hours है, तभी तो कुल मिला के 24 होगी. तो ये फिनोमेनन हम equinox के टाइम पे ही देख सकते हैं, जो साल में 2 बार आती है. One on March 21st, another is on September 23rd. And you also know about summer solstice and winter solstice. Basically, to roughly put it, equinox ऐसा situation है कि sun is directly facing earth above the equator. That is equinox, where length of day equal to length of night. But we have solstice. Solstice है का मतलब होता है if sun is facing this, I mean somewhere above tropic of Cancer, like that I think. So अगर वो face करते हैं तो हम बोलेंगे June solstice. But if it is facing the southern tropic, that is called December solstice. I think these two, whatever I'm talking, that is basically Tropic of Cancer, or this is Tropic of Capricorn. If it is about Tropic of Cancer, then I'm calling it as June solstice. That's right. I remember. Sun, it moves through 2 tropics, Tropic of Cancer and Tropic of Capricorn. इससे ज़्यादा नहीं जाएगी. So when it is facing above Tropic of Cancer, that is June solstice, and when it is facing above Tropic of Capricorn, that is December solstice. So this is what we have seen. Okay. We have also covered humidity. Now to the same question. Yeah, why is it maximum in May and why not during summer solstice? उस टाइम पे तो directly above the Tropic of Cancer. तो ज़्यादा insolation. फिर भी हम क्यों May बोल रहे हैं? When is summer solstice? June 21 or 22. तो June है ना summer solstice, but why May? It is because of seasonal monsoon winds. When summer solstice starts on the month of June, India will start receiving monsoon also. तो उसकी वजह से ये होगी कि इट विल ब्रिंग कूलिंग इफेक्ट टू द क्लाइमेट ऑफ इंडिया विच वॉज फेसिंग इंटेंस हीट सिंस मार्च. देयरफॉर टेम्परेचर इज मैक्सिमम इन द मंथ ऑफ मे, क्योंकि मई के बाद जून आएगा, लेकिन जून के टाइम पे मानसून भी आ रही है. क्या मानसून आ रही है? एक तो साउथ वेस्ट मानसून एंड दूसरा नॉर्थ ईस्ट मानसून आ रही है. सो टेल मी व्हाट इज द टाइम पीरियड ऑफ साउथ वेस्ट मानसून? साउथ वेस्ट मानसून भी एक्जैक्टली जून में स्टार्ट होगी. साउथ वेस्ट मानसून जून से जुलाई अगस्त सितंबर 4 महीने. That is south west monsoon. And we also have north east monsoons. North east monsoons अक्टूबर नवंबर दिसंबर. देखना यहाँ पे सितंबर तक लिखा है ना हमने, तो यहाँ पे अक्टूबर टू दिसंबर तक लिख देना. सो बेसिकली इंडिया इज रिसीविंग monsoonal winds also, that is bringing cooling effect. That is the reason why temperature it is maximum during the month of May and not after summer solstice. And I'm asking you one more question. Why is annual range of temperature high in the Siberian plains? Okay, that's my question. You know Siberian plain? Okay, if you can see here I said that basically here you can see easterlies and here you can see westerlies, because they are originating from east and they are originating from west. But I can see that this Tropic of Cancer, this is the source of all the winds, right? And I also said the major source for all the winds in Tropic of Cancer, that is Siberian plains. Got it? And now I'm asking, what is the annual range? Why not is what? Why the annual range of temperature is highest in the Siberian plain? Because Siberian plains are positioned far from the ocean. Therefore, equalizing effect of oceans is relatively minimal. That's the reason why Siberian plains they have high annual range of temperature, because they are far away from oceans. Got it? यहाँ पे आंसर भी है, बट क्वेश्चन देखना, आंसर मत देखना. विच स्टेट रिसीव्स मोर रेनफॉल फ्रॉम नॉर्थ ईस्ट मानसून? तो मुझे हमेशा लगेगा ये कोई वेस्ट बंगाल या फिर कुछ वैसे स्टेट्स होंगी, बट द आंसर इज तमिलनाडु. येस, इट इज़ बेनिफिटिंग अप्रॉक्सीमेटली बाई 40 to 50%. एंड आई थिंक मोर रेनफॉल तमिलनाडु है, तो आंध्र प्रदेश भी उसी एरिया में है, तो आंध्र प्रदेश भी हो सकते हैं. तो तमिलनाडु एंड आंध्र प्रदेश दे आर रिसीविंग मोर रेनफॉल फ्रॉम नॉर्थ ईस्ट मानसून. एंड बाई एनुअल रेंज ऑफ टेम्परेचर हाई इन द साइबेरियन प्लेन, because the only reason, as I said, they are very far away from the ocean. That's why the annual range of temperature it is high in the Siberian plain. अगर वाटर होता तो कोई और ही सिनेरियो होता उसका. Now we are discussing air circulations. Okay, that's the 9th chapter of NCERT. Very simple logic is that as you go above, the pressure drops. As you come below, that pressure increases. तो एयर कॉलम है एक, अगर हम नीचे आएंगे तो प्रेशर इंक्रीज होगी, क्योंकि मास ऑफ द एयर above will increase. So when you finally come here, the pressure it rises a lot. Okay, and it is measured using mercury barometer or aneroid barometer. And also atmospheric pressure it is measured in Pascal. 1 Pascal equal to Newton per meter square, which is 10 to the power of minus 5 bar or 10 to the power of minus 2 millibar. Okay, millibar. 1 पास्कल इक्वल टू न्यूटन पर मीटर स्क्वायर विच इज 10 टू द पावर ऑफ -5 बार और 10 टू द पावर ऑफ -2 मिली बार। मिली का मतलब होता है 10 टू द पावर ऑफ -3, तो बन जाएगा 10 पावर -5 है ना। तो कुछ भी मैं बोल सकती हूँ। सो रिमेंबर दिस 1 पास्कल, रिमेंबर एनीथिंग और इतना याद रखना, तो इससे ये डिराइव कर ही लोगे, राइट। इट इज मेजर्ड इन पास्कल विच इज न्यूटन पर मीटर स्क्वायर विच इज 10 टू द पावर ऑफ -5 बार। ओके, एटमॉस्फेरिक प्रेशर इफ दे आर आस्किंग व्हाट्स द एटमॉस्फेरिक प्रेशर, इट इज 10 टू द पावर ऑफ 5 पास्कल्स, दैट इज आवर अर्थ एटमॉस्फेरिक प्रेशर। तो कुछ भी यूनिट्स में पूछ सकते हो। इफ दे आर आस्किंग यू मिली बार, जस्ट कन्वर्ट, राइट। नाउ यू नो 10 पावर 5 पास्कल, तो बट दे आर आस्किंग यू मिली बार, हाउ मच इज 1 पास्कल इन मिली बार, 10 टू द पावर ऑफ -2 मिली बार, देयरफॉर 10 पावर 3 मिली बार्स, 10 power 3 millibars is the atmospheric pressure, 101325, that is in pascals, and if I'm saying 1013, that is millibar. Got it? Now next, see, I will first explain vertical pressure gradient. See, let's say this is 101, this is 102, some, or else 101, 1021 millibar, let's say. तो इन दोनों के बीच में कुछ तो प्रेशर डिफरेंस है ना, so that can be in the vertical direction or the horizontal direction. If it is in the vertical direction, that we are calling vertical variation of pressure, and if it is in the horizontal, that is horizontal variation of pressure, which I denoted with Fe and Fh. Okay, so in the lower atmosphere, as you go above, the temperature it is dropping, and what else is dropping? Pressure is also dropping, which you know. So that pressure is also dropping. That is the vertical variation of pressure, that's all. Height increases, temperature drops, pressure drops. As you go up, pressure is dropping, that is vertical variation of pressure. And usually the vertical pressure gradient force, it is larger than the horizontal pressure gradient force, क्योंकि as you can see ना, ऊपर जाते जाते प्रेशर ड्रॉप होती जा रही है, and that's why I'm saying vertical pressure gradient force that is greater than horizontal. But there is a catch that this is affected by the gravity. As you can see, if there is vertical pressure gradient force, it is counterbalanced by the gravity, and finally there is a negligible effect. That is why हम vertical direction में हवा में नहीं उड़ रहे हैं, क्यों? क्योंकि that is counterbalanced by the gravity, and therefore it is having negligible effect, and we don't have upward winds, but we are having horizontal winds. वो तो है ना. See, if it is our earth, this is vertical direction from earth, and this is horizontal direction. हम अब इस horizontal pressure gradient का reasons देख रहे हैं. Okay. See, ये उतना आसान नहीं है. They are studied using isobots. Isobots are lines connecting same pressure. Okay, and based on that you are going to study the pressure gradient force, horizontal pressure gradient force. See, for example, there is a location 1. इस लोकेशन पे मुझे प्रेशर मेजर करना है, एंड इस लोकेशन पे मुझे प्रेशर मेजर करना है, फाइनली रिपोर्ट देना है किसी को. तो उसके लिए मैं क्या डायरेक्टली प्रेशर इतना वो बता के बोल दूँगी? नहीं. दे मस्ट बी फर्स्ट reduced to MSL, mean sea level, and then both of them must be reduced at MSL, and finally they must be reported. So reducing to MSL is must. Now using this information, let us try to study the factors affecting the velocity and direction of wind. अब तक हमने क्या पढ़ा? एयर सर्कुलेशन के लिए हमने ये देखा कि एटमॉस्फेरिक प्रेशर होता क्या है, एंड देन वी हैव सीन इफ दैट एटमॉस्फेरिक प्रेशर इज देयर, in which direction does it move. If it moves in the vertical direction, that is vertical pressure gradient, and if it is moving in the horizontal direction, that is horizontal pressure gradient. And we have also noticed that vertical direction पे mostly same ही होती है, क्योंकि there is no pressure gradient because it is cancelling out with gravity. That is what we have seen. But if you go in the horizontal direction, there are different isobars, so you might be having different pressure gradients. Now you need to study the factors affecting the velocity and direction of wind. सी, पहला फैक्टर होगी ये प्रेशर ग्रेडियंट ही. व्हेनेवर यू स्टडी ना, यू विल नोटिस दैट दिस इज इक्वेटोरियल लो प्रेशर बेल्ट, सब ट्रॉपिकल हाई प्रेशर बेल्ट, टेम्परेट लो प्रेशर बेल्ट एक्सेट्रा. तो ये प्रेशर बेल्ट डिफरेंट है ना. ये लो प्रेशर बेल्ट से हाई प्रेशर बेल्ट जाएगी, ऐसे बारिश होगी, फिर से ऐसे जाएगी. तो ये सब क्या है? They are pressure belts. So you need to study the pressure gradient. And what is pressure gradient का formula? This one. I said ना कि दो isobars के बीच में एक pressure gradient होगी. See, let's take 2 isobars. हम horizontally देख रहे हैं wind का मतलब. Vertical direction में wind नहीं होती है, मतलब होती भी है, वो बहुत कम है compared to horizontal direction. We have discussed convection and advection also. In the convection, I said that I can't recall any examples. But in the advection, I said that Hadley cell देखो या फिर Farrell cell देखना, जो भी देखना, वहाँ पे हम क्या देखेंगे? Mostly advection ही देखेंगे, because there you can see horizontal distribution of pressure. And also local winds are also example for advection that I said. Local winds हो गया, या फिर जो planetary winds हो गया. Planetary winds, पोलैरिटी का मतलब पोलर ईस्टर्लीज एंड वेस्टर्लीज, ऑल दो थ्री आर कॉल्ड प्लैनेटरी विंड्स. वो सब किसका एग्जांपल है? एडवेक्शन का. बट कन्वेक्शन का मैं ज़्यादा नहीं बता पाई, बिकॉज वर्टिकल डायरेक्शन में विंड होती नहीं है यूजुअली, बिकॉज इट इज मोस्टली काउंटरबैलेंस्ड बाय द ग्रेविटी. दैट प्रेशर ग्रेडियंट इज काउंटरबैलेंस्ड बाय द ग्रेविटी. हमें यूनिफॉर्म प्रेशर ही दिखती है. दैट्स व्हाई वी सी मोस्टली इन द हॉरिजॉन्टल. सो नाउ आई एम डिस्कसिंग इन द हॉरिजॉन्टल डायरेक्शन ओनली as per my knowledge. That's why I wrote horizontal. And pressure gradient, it is what distance between one isobar to the other. Let's say that is delta P. That is change in pressure divided by the distance between the isobars. देखना, अब इन isobar के बीच में 3 मीटर का डिस्टेंस है, लेट्स से, एंड इन दोनों के बीच में कितने एमबी का डिस्टेंस है, लेट्स से दैट्स 4 एमबी, 4 मिलीबार. तो वो हम 4/3 लिखेंगे, दैट्स ऑल. दैट विल बी आवर प्रेशर ग्रेडियंट फोर्स. अगर डिस्टेंस कम है तो क्या होगा? इन दोनों के बीच में अगर डिस्टेंस कम है तो क्या हो जाएगा? प्रेशर ग्रेडियंट फोर्स बढ़ेगा. गॉट इट? सो क्लोजर isobars एक्सपीरियंस मोर प्रेशर ग्रेडियंट. अगर isobars पास में है तो दोनों के बीच में डिस्टेंस कम है, इसी वजह से प्रेशर ग्रेडियंट फोर्स ज्यादा होगी. गॉट इट? एंड आल्सो द सेकंड फैक्टर व्हिच अफेक्ट्स द वेलोसिटी एंड डायरेक्शन ऑफ विंड इज द फ्रिक्शनल फोर्स. फॉर एग्जांपल, लेट्स सी दैट देयर आर सम बिल्डिंग्स, और यहाँ पे विंड जा रही है. नाउ लेट अस सी दैट दिस इज ओशियन. यहाँ पे विंड जा रही है, एंड वेयर डू यू सी मिनिमल डिस्टर्बेंसेस? ऑफ कोर्स इट इज नियर द ओशियन. So velocity and direction of winds, they are low near oceans and they are high near buildings. I mean the friction is high near buildings. तो cities में friction है क्योंकि ये सब आएंगे बीच में, है ना. friction is high near building, but the friction is low near the oceans. Got it? Then you can notice low frictional force near oceans. That is why velocity of wind it is higher near the oceans and it is lower near the buildings. So frictional force it affects. And you need to say Coriolis force. Coriolis force also affects the direction and velocity of wind. How? Simple है ना. मैं बताती हूँ Coriolis force का formula क्या होता है. that is 2 mv some omega sin phi. ये क्या लिखा मैंने? I'll tell you. See, let's take this as our earth, प्यारा सा earth. Now, this is our earth axis which is revolving around it. Now, what I'm going to say is that this is the tilt of earth, right? That tilt is phi. Okay. Uh, Sorry, not that tilt, the latitude. I think this is latitude of earth. I mean, from the area where you're measuring. Let's say this is 30-degree latitude and you want to find the Coriolis force here. Then this depends on the latitude or the position where you are at. That is phi. As per my knowledge, please check your sources. And this is the velocity of wind, and this is the angular velocity of the earth. Got it? तो इससे मुझे पता चल रहा है कि if the wind velocity is higher, अगर wind ज़्यादा तेज जाएगी तो मेरी Coriolis force भी ज़्यादा होगी उसके ऊपर, because they are directly proportional. And also it depends upon the latitude of earth. That is my Coriolis force का formula. Now you got to identify three factors. One is pressure gradient force, and another is friction force, and the third is the Coriolis force. As you can see by the formula only, it depends upon the velocity and angular velocity of earth, and also the latitude of earth. So these are the factors which are affecting the velocity and the direction of wind. Coriolis affect करेगी. See, even in the easterlies and westerlies, ये ऐसे जाना जाती है actually high pressure. This is what subtropical high pressure belt, and this is equatorial low pressure belt. तो wind पहले ऐसे जाना जाती थी, लेकिन ये Coriolis ना ऐसे act करती है. That is, see, there is one more diagram also for the Coriolis I want to tell you. ऐसे एक और diagram है. अरे ये क्या हुआ? So this is right and this is left. Okay. तो ये Coriolis force ना, if you are in the northern hemisphere of earth, a Coriolis force na right side act करेगी. So if you're going like this, Coriolis force will push you rightward, and in the southern hemisphere, if you see, it will push you leftward. For example, if you're going like this again, it will push you towards the left. That is the Coriolis force. I remember this symbol from this symbol. That's why I can say this is right and this is left for the Coriolis, and it depends upon the velocity and latitude of earth. That's the formula for Coriolis. Got it? तो ये मैं ये बोल रही थी कि इफ यू लुक इनटू द प्रेशर बेल्ट व्हिच इज इक्वेटोरियल लो प्रेशर बेल्ट एंड सबट्रॉपिकल हाई प्रेशर बेल्ट, ये हाई प्रेशर बेल्ट है, दैट्स व्हाई इट वांट टू ट्रैवल फ्रॉम हाई प्रेशर बेल्ट टू लो प्रेशर बेल्ट. लेकिन क्या होगी कि कोरियोलिस फोर्स ना नॉर्दर्न हेमिस्फीयर में किस साइड धक्का देगी? राइट साइड धक्का देगी ना, राइट? दैट्स व्हाट वी हैव सीन इन द नॉर्दर्न हेमिस्फीयर. सो राइट साइड धक्का देने की वजह से ये राइटवर्ड शिफ्ट हो जाएगी. गॉट इट? राइटवर्ड शिफ्ट हो जाएगी ऐसे, या राइट या लेफ्ट. दिस इज राइट. व्हाई? सी, यू आर वॉकिंग इन दिस डायरेक्शन. इफ यू आर वॉकिंग इन दिस डायरेक्शन, तेरा लेफ्ट क्या होगा, राइट क्या होगा? दिस इज योर राइट, राइट? तो तेरे तो राइटवर्ड चले जाओगे. गॉट इट? You're going right also this direction. Don't be confused. You need to see from this perspective. As if you're standing from here and you're going in this direction, for you the right is this side, therefore you will go rightward, because Coriolis force acts rightward. So therefore you need to go in this direction. That is why this area it is called easterlies, because it seems like winds they are originating from the east. Okay, that's Coriolis. Fine. These are the factors: pressure gradient, friction force, and the Coriolis force. And also, you know, right? This is something like as I already discussed this for cyclones. लेकिन cyclones भी एक तरह के windy तो है. Got it? That is why I said, see, cyclones. So cyclones, etc., they are also winds, right? That's why I drew this diagram here. But remember, cyclones na, they originate only over, not which type of cyclone, that also is important. Let's say I'm talking about tropical cyclone, तो ये हमेशा only over the ocean originate करेगी. Now if I'm talking about extra tropical cyclone na, that originates both over land and ocean. Got it? So you need to understand whether I'm talking about extra tropical or tropical cyclone. Let's say I'm talking about extra tropical which can originate over land and ocean. तो ये land पे originate हो गया अब, तो उसका direction किस direction होगी? Is it in the clockwise or anti-clockwise? So which direction? You can take the same diagram for the cyclones that I have taught. Got it? It is like what we draw this diagram, right? Low pressure, high pressure. So this is for anticyclones and this is for cyclones. So cyclones, tropical cyclones, I mean that is one type of cyclone only. And extra tropical cyclone, all of them they are concentrated over low pressure only. Therefore you are going to take again this diagram, and in the northern hemisphere you can see that extra tropical cyclones they move in the anti-clockwise direction, and in the southern hemisphere they rotate in the clockwise direction. Now we need to see what is geostrophic wind. This is what I hear many times. Okay, when isobars are free from friction, let's take two isobars. Let's take this isobar 1 and isobar 2. Okay, they are free from friction, and when isobars are free from friction, that is somewhere around 2 to 3 kilometers above earth, somewhere like that. So these isobars they are free from friction, and let's say this is isobar B1 and this is B2. pH, the pressure gradient force, the pH that you are seeing, it is balanced by the Coriolis force of the earth. Got it? So vertical direction में पता है अगर ये हेरते हैं तो vertical direction it is counterbalanced by the gravity, but in when you're going in the horizontal direction, let's say if it is counterbalanced by the Coriolis, let's say that is some other direction where you need to go like this, but Coriolis is also acting like this, something like that. And let's say any local wind, when such kind of thing happens, when Coriolis force, when it is counterbalancing the pressure gradient force, it results in horizontal, I mean parallel direction which is parallel to the isobar. I mean when isobars are free from friction, and when the pressure gradient force it is balanced by the Coriolis, the resultant wind blows parallel to isobar. That's it. The resultant wind it is parallel to isobars. That parallel wind to isobar, that is called geostrophic wind. तो ऐसे condition है कि it is free from the friction also. That is also one condition. Let's say it is free from friction somewhere above 2 to 3 kilometers. But if there is no friction and pressure gradient is counterbalanced by the Coriolis, in such scenario, the wind moves parallel to isobar. Such kind of wind is called geostrophic wind. Got it? Geostrophic wind पूछेगा exam में. So basically we have covered the what is vertical pressure gradient and horizontal pressure gradient, and we have also seen the factors affecting the velocity and direction of the wind. I think the next is seeing the pressure belts only. See, if we are studying the world distribution of pressure now, you need to understand this world map that around 0 degree we are having equatorial low pressure belt, and here we are having subtropical high pressure belts. Next we have temperate low pressure belts and polar high pressure belts. These names must stick in your brain. Now, actually we are just saying low pressure belt for our simplicity. They are actually not the belts, but they are like some pressure cells. You are having different pressure cells, equatorial low pressure cells, and you have subtropical high pressure cells, etc. So let's say this is low pressure cell and high pressure cell. यहाँ पे बारिश, I mean ऊपर जाएगी और high pressure पे बारिश हो जाएगी. Got it? But one thing you need to notice is that pressure belts, they are not permanent. They are not permanent because they oscillate with the movement of the sun. Let's take this as our earth, प्यारा सा earth. अगर sun ऊपर नीचे जाएगी तो pressure cells भी automatically ऊपर नीचे चली जाएगी. So it oscillates with the movement of the sun 5 to 10 degree north or south of the average position. Got it? Let's say this is our sun. So you're having 5 to 10 degree north or south of the average position. And then if you notice, the pressure belts are more in the northern hemisphere compared to southern hemisphere. The reason is being simple. Northern hemisphere is having more land compared to southern. And since there is more land, what's going to happen? Water, it will be in direct contact with land. And land, it heats faster than water. लैंड हीट्स फास्टर देन वाटर बिकॉज वाटर इज हैविंग हाई स्पेसिफिक हीट. तो लैंड ज़्यादा हीट हो जाएगी तो ये वाटर भी कॉन्टैक्ट में है तो कंडक्शन होकर ये भी हीट हो जाएगी, है ना. सो इन द नदर्न हेमिस्फीयर दैट इज व्हाई यू कैन आइडेंटिफाई मोर प्रेशर सेल्स. सी सन का इफेक्ट किसके ऊपर ज़्यादा रहेगा? लैंड के ऊपर. एंड नदर्न हेमिस्फीयर इज हैविंग मोर लैंड एंड वाटर विल बी कॉन्टैक्टेड. Therefore there will be connection between land and water, and that will lead to more pressure cells in the northern hemisphere compared to the southern. Got it? And also pressure cells, as I'm telling you, this is our pyara earth. Here you are having equatorial low pressure belt, subtropical high pressure belt, temperate low pressure belt, etc. Right? So this equatorial low pressure belt, this will be shifting. That is called shift of pressure cells. But if you see in the temperate low pressure belt, etc., or polar high pressure belt, there you cannot see more deviation. You cannot actually see the deviation. Why? Because the deviation is more in the lower latitude. Lower latitudes experience more deviation because at max the sun moves between Tropic of Cancer and Tropic of Capricorn. That is why lower latitudes they have more shift compared to polar latitudes. So that is also something you need to know about the pressure belts. One is they deviate 5 to 10 degree north or south of the average position, and they are more seen in northern hemisphere because it is having more land, and the pressure cells they shift more in the lower latitudes compared to polar latitudes. So it depends whether pressure belts move northward or southward. Okay. See, sun position, it has two extremes. One is Tropic of Cancer and Capricorn. When it is at Tropic of Cancer, so sun is above the equator, right? In the scenario, pressure belts they must shift upward, northward, and during Tropic of Capricorn they must shift southward. Okay. So what is this? This is summer solstice, which is in the month of June. And what is this? This is winter solstice, that is in the month of December 22nd, etc. So this is June 22nd, and this is December 22nd. And you can see that pressure belts they are shifting northward during summer solstice and in the southward during winter solstice. And even in the tropical areas or subtropical areas, if you're asking me, where do you see or where do you observe more pressure? That is usually near the Siberian high pressure belt or Canadian high. They are the areas of high pressure. See, if you observe, this is equatorial low pressure belt and subtropical high pressure belt ना. So origin तो high pressure belt पे ही होगा और low pressure belt की तरफ जाएगा, and shift will be in the right direction due to Coriolis force, right? तो यहाँ पे जो origin में बता रही हूँ ना, ये जो origin में बता रही हूँ इस डायरेक्शन में, यहाँ पे ऐसा होगा कि इस डायरेक्शन पे भी एक विंड होगी. Why? Because this is equatorial low pressure, subtropical high pressure belt and temperate low pressure belt. तो विंड ऐसा जाएगी और ऐसे भी जाएगी, तो ये एक origin point बन गया ना. तो ये high pressure belt ना, this is more high in the Siberian high and the Canadian high, which is what you need to know. तो अब हम डिस्कस करेंगे ITCZ होता क्या है. ITCZ इज इंटरट्रॉपिकल कन्वर्जेंस जोन. ओके, दैट इज क्रिएटेड ड्यू टू 2 to 20 डिग्री शिफ्ट. सो दैट इज ITCZ. बेसिकली देखना, ये हमारा प्यारा रहता है. अब यहाँ पे हमारा सन है. ओके, दिस इज दैट इज व्हाई यू आर कॉलिंग इक्वेटोरियल लो प्रेशर बेल्ट. लेकिन सन हमेशा इक्वेटर के सामने नहीं रहेगी ना. इट मूव्स बिटवीन टू एक्सट्रीम्स. वन इज ट्रॉपिक ऑफ कैंसर, अदर इज ट्रॉपिक ऑफ कैप्रिकॉर्न, राइट? सो व्हेन सन मूव्स टू द अदर एक्सट्रीम्स, देयर विल बी अ शिफ्ट इन द प्रेशर बेल्ट्स. दिस इज अवर अर्थ, एंड देयर विल बी अ शिफ्ट इन द प्रेशर सेल्स. यूजुअली लो प्रेशर बेल्ट सेल्स यहाँ पे होगी, लेकिन प्रेशर बेल्ट सेल्स दे शिफ्ट 2 to 20 डिग्री नॉर्थ और 2 to 20 डिग्री साउथ, डिपेंडिंग ऑन वेदर सन इज मूविंग अपवर्ड और मूविंग डाउनवर्ड. आई मीन मूविंग टुवर्ड्स ट्रॉपिक ऑफ कैंसर और ट्रॉपिक ऑफ कैप्रिकॉर्न. Okay, so therefore ITCZ it is also called thermal equator or meteorological equator or zone of calm conditions. Zone of calm conditions. See, as you can see in this diagram, I have noted down the same, that this is intertropical convergence zone, and as the sun is near the Tropic of Capricorn, the pressure cells they moved below. You can see this became the equator. This is low pressure and uske upar high pressure belts there. And when it is summer na, you can see the pressure belt moved above, and you can see high pressure cells here. Got it? Now let us see the general circulation of atmosphere, how this pressure belts happen. Wow, बढ़िया प्यारा diagram. You know Coriolis force क्या important है diagram को समझने पहले, कि Coriolis force it will deflect you towards right in the northern hemisphere and then deflect you towards left in the southern hemisphere, and yet it rotates eastward from west to east. Got it? And if they are origining, if you feel like they're origining from the east, you will call it as easterlies. Just because they're moving in east, you will not call easterlies. No, they move towards west actually. But you need to see the origin point. If origin point is east, you will call it easterlies. Okay. And as I said, in reality, we are not having these pressure belts. We are having pressure cells. For simplicity, we are seeing these pressure belts. Okay. And 3 pressure belts. I mean, what are the cells that you know? Hadley, Farrell, Polar. See, simple. I remember it with a trick actually. Hadley, देखना, मुझे लगता है डायग्राम के बिना समझाना पड़ेगा. See, this is our pyara here. Got it? Now we are having different belts, right? Belts you need to definitely memorize. The first belt is it is not at the center. Wait, वैसे center पे होना भी नहीं चाहिए. How will I explain if it is at the center? Okay, see, you need to have different pressure belts. First would be equatorial low pressure belt here, and then we are having subtropical high pressure belt here, and next we are having temperate low pressure belt, that is here, and next what else? Polar high pressure belt. Okay. Similarly, you are also having the same pressure belts in the southern hemisphere also. Got it? Now what's going to happen is, see, you need to mark first. You always remember that it is equatorial low pressure belt, and then subtropical high pressure belt above and below, subtropical high pressure belt, and here you are having temperate low pressure belt, and this is also temperate low pressure belt. And finally, you are having polar high pressure belts. This is in the downward, that is also a polar high pressure belt. Okay, so these are your belts. Remember that when I'm saying high pressure belt, this is equatorial low pressure belt, right? This low pressure, why is it induced? Because of the sun warming. Sun warmed this land and oceans, and it became warm, and that is why we are calling it equatorial low pressure belt. So this is what this is thermally induced. Thermally induced. Got it? So when I'm saying polar high pressure belt, that is also thermally induced. Got it? तो पहला एक आदमी हैडली होता था, उन्होंने बताया कि देखना ऐसा होगा, इक्वेटोरियल लो, तो लो का मतलब वार्म, वार्म हो जाएगी तो ऊपर जाएगी, ऊपर जाके हाई प्रेशर पे बारिश बरसेगी। सो दैट्स व्हाट ही सेड। उन्होंने एक सिंपल सीधा साधा मॉडल बताया। सो दैट इज व्हाई दीस टू इक्वेटोरियल लो प्रेशर एंड पोलर हाई प्रेशर दे आर थर्मली इंड्यूस्ड, दे आर थर्मली इंड्यूस्ड। लेकिन एक्चुअली सिनेरियो में ऐसा नहीं होती है। गॉट इट? सो यू आर हैविंग द टेम्परेट लो प्रेशर बेल्ट, राइट, व्हिच इज नॉट थर्मली एक्चुअली। हैडली ने उसके बारे में सोचा ही नहीं था। सो दैट वाज थॉट बाय another guy, Ferrell. Okay, that's why we are having another pressure belt, which is temperate low pressure belt, but that is not thermal. That is dynamically induced, dynamically due to wind and earth rotation, etc. We said that there are dynamic low pressure belts also. That is dynamically induced pressure belts. Got it? Remember that temperate low pressure belt, it is not due to thermal, but it is due to dynamically induced pressure belt. Now you need to plot. See, I remember it like diagram. तो मैं पहले equatorial low pressure belt से start करूंगी. So hot water raises above. Hot water because warm हो गया, तभी तो ये low pressure है. Low pressure मतलब warm हो गया. So warm water it raises above. Hot, warm water से अच्छा hot water बताना. Hot का मतलब H का मतलब Hadley. So I remember Hadley. It will start with Hadley because confusion होता था whether it's Hadley or Ferrell. So Hadley. But warm water it raises above. Hot water raised above Hadley cell. And then इस तरफ जाना पड़ेगा रेज होने के बाद. Got it? And then it needs to fall down one day or the other. It needs to precipitate, and here we have seen that it is high pressure belt. तो high pressure belt पे precipitation हो जाएगी. So here there will be precipitation. Okay, these cells are called Hadley cells. These two cells are called Hadley cells. And now you are going to see Ferrell cell. Okay, अब now you are seeing that winds are coming down, and high pressure पे हमने क्या पढ़ा? High pressure sink and diverge. तो इस तरह diverge हो जाएगी, sink and diverge. This is high pressure, so sink and diverge. Got it? Now they are diverging. So they are diverging from high pressure. तो मैंने बताया this is horizontal, और horizontal to the earth we are going to see this principle. Winds move from high pressure to low pressure, but that principle do not work in the vertical direction as I said. ये ऐसा नहीं होगी, ऐसा ही होगी. But in the horizontal direction it will move from high pressure to low pressure. That principle works. So now I'm saying this is high pressure belt. So winds they are moving like this. So on the earth they need to come to a low pressure belt to concentrate, right? So winds they are converging at the temperate low pressure belt, and they are again rising, and this is due to winds that is dynamically induced, not due to some thermal. Why thermal होगा तो यहाँ से यहाँ तक ही होगा, because sun moves from two extremes. यहाँ पे thermal नहीं हो सकता temperate low pressure belt पे. So that's why it is temperate low pressure belt, and low pressure पे क्या होगा? Low pressure. I said ना, low pressure converge and rise. Okay, it is going to converge and it's going to rise. Low pressure converge and rise. Got it? It raised. Raise होने के बाद फिर से इधर उधर जाना पड़ेगा. So you'll go in this direction and you'll go in this direction. And finally, high pressure belt, polar high pressure belt से पे फिर से बारिश हो जाएगी. Okay, and similar diagram you can draw here, right? In the southward direction also you can. This is Hadley cell, this is Ferrell cell, and this is polar pressure belt. Okay, so I think you are clear with the three types of cells: Hadley, Ferrell, and polar. तो बेसिकली हैडली ने क्या दिया? वन सेल मॉडल सजेस्ट किया, लेकिन फेरल ने थ्री सेल मॉडल सजेस्ट किया. ऐसा होगी भाई, यहाँ पे डायनामिकल इंड्यूस्ड प्रेशर बेल्ट को भी हमें कंसीडर करना है. सो फेरल की ये थ्री सेल मॉडल. एंड व्हाट एल्स डिड वी मिस एनीथिंग? तो हैडली ने जब ये मॉडल बताया उन्होंने कोरियोलिस फोर्स कंसीडर नहीं किया, बट फेरल ने जब ये थ्री सेल मॉडल बताया उन्होंने ना कोरियोलिस कंसीडर किया, इक्विनॉक्स पोजीशंस ऑफ सन ये भी कंसीडर किया, एंड देन ही आल्सो थॉट दैट अर्थ इज यूनिफॉर्म. ही डिड नॉट कंसीडर द अनइवन डिस्ट्रीब्यूशन ऑफ लैंड एंड एयर. ही जस्ट थॉट अर्थ इज यूनिफॉर्म. दैट्स हिज assumption, and he also considered the sun's equinox position, and he has also seen he has also considered Coriolis. So that is why we are following Ferrell cell models. Okay, and yeah, did I tell you the directions or no? Okay, तो हमारा Ferrell का मॉडल है ना ये. So he has also talked about directions. See, I'll tell you. अब directions को discuss करना है. So see, Earth winds they are parallel to Earth, right? I mean they are not in vertical direction. Winds, I mean vertical direction पे ज़्यादा नहीं होगी. That we have already seen. It is mostly in the horizontal direction. I mean it is in the horizontal direction. It is balanced by Coriolis. See, horizontal direction पे Coriolis balance करेगी. Vertical direction पे क्या कौन बैलेंस करेगा? ग्रेविटी. एंड वर्टिकल डायरेक्शन पे मोस्टली विंड्स नेग्लिजिबल हो जाते हैं, एंड हॉरिजॉन्टल डायरेक्शन पे कोरियोलिस बैलेंस करेगी. अगर वो इक्वल टू बन जाती है, व्हेन दिस बिकम्स इक्वल टू, देन इन सच सिनेरियो दैट टाइप ऑफ विंड व्हिच इज पैरेलल टू आइसोबर, इट इज कॉल्ड जियोस्ट्रोफिक विंड दैट वी हैव सीन. एनीवेज, नाउ एज वी नो दिस सबट्रॉपिकल हाई प्रेशर बेल्ट एंड इक्वेटोरियल लो प्रेशर बेल्ट, तो हाई प्रेशर पे ओरिजिनेट करना पड़ेगा और इसको जाना तक कहाँ पे? लो प्रेशर पे. लेकिन ये लो प्रेशर नहीं जाएगी. क्यों? क्योंकि कोरियोलिस है ना, एंड कोरियोलिस का काम क्या है? डिफ्लेक्ट करना. और किस तरह डिफ्लेक्ट करेगी? इन द नॉर्दर्न हेमिस्फीयर इट विल डिफ्लेक्ट टुवर्ड्स योर राइट, एंड इन द सदर्न इट विल डिफ्लेक्ट टुवर्ड्स योर लेफ्ट. ओके, नाउ व्हाट्स गोइंग टू हैपन? सी, आई एम मूविंग लाइक दिस. मी, तो मेरी राइट वर्ड इस तरफ है ना, तो आई विल गो दिस डायरेक्शन ड्यू टू कोरियोलिस. बिकॉज कोरियोलिस, व्हाट इज कोरियोलिस? दैट फोर्स इज क्रिएटेड ड्यू टू रोटेशन ऑफ अर्थ व्हिच इज मूविंग फ्रॉम वेस्ट टू ईस्ट, राइट? देयरफॉर आई विल गेट अ राइट वर्ड डिफ्लेक्शन इन द नॉर्दर्न एंड लेफ्ट वर्ड डिफ्लेक्शन इन द सदर्न. राइट, सो मैं इस तरफ जाऊंगी, एंड so it feels like it is originating from the east, right? East direction का मतलब क्या है? It feels like it is originating from the east. That is why we are also calling them as easterlies. Okay, and ना तुम इस डायरेक्शन में एक्चुअली नहीं जा पा रहे हो, That is why I will just denote it with dotted lines. Actually ऐसे जाना चाहते हो but you are going in this direction, and then similarly you want to go in this direction because you are at high pressure belt, तुम originate पहले यहाँ से ही start करना पड़ेगा. Okay, now you want to go in this direction, but again in the north Coriolis it deflects you towards your right, and when you are going in the north direction, your deflection, your right side is going to be this direction, right? So therefore Coriolis, due to Coriolis force, again you will go in that other direction. But now when you are going from subtropical high to temperate low, when you are going from subtropical high to temperate low, what's going to happen? You feel like you are originating from the west here, right? That is why they are called westerlies here. Okay, westerlies. अब देखेंगे आगे का कहानी. नाउ टेम्परेट लो प्रेशर, पोलर हाई प्रेशर. सी हाई प्रेशर से ही तो ऑरिजिनेट करना पड़ेगा हमें, तो लो प्रेशर बेल्ट की तरफ जा रहा है. नाउ यू आर हियर, राइट? यू नीड टू गो इन दिस डायरेक्शन, बट अगेन व्हाट इज योर राइट? दिस. सो यू विल गो इन दैट दिस डायरेक्शन लाइक दिस. विंड्स तो ऐसे होंगे, ऐसे. गॉट इट? तो ये लो प्रेशर बेल्ट है ना. सो हियर यू कैन सी winds are actually converging. Now it feels like it is again originating from the east, but they are near poles. That is why you are calling them as polar easterlies. Okay. These are the three type of winds. These three together they are called as planetary winds. Okay. So this is what I have written here. Yeah, it feels like originating. अगर मैं exact direction मुझे बताना है तो देखना. चलो अब बताओ. This is north and this is east, and when I extend it feels like it is coming actually from northeast. So therefore I will call it as northeast trade wind. Okay, and this also अब इसको extend करना इसी line को, so it feels like it is originating from the southeast. That is why they are called southeast trade winds. Okay, and we also have westerlies. सो नॉर्थ ईस्ट ट्रेड विंड, साउथ ईस्ट ट्रेड विंड्स एंड वेस्टर्लीज के लिए कुछ है नहीं, तो सिर्फ वेस्टर्लीज बोलेंगे. अगर कुछ बोलना है तो बोल सकते हो, कोई प्रॉब्लम नहीं है. बट वेस्टर्लीज दे आर क्रिएटेड इन द टेम्परेट एरियाज. गॉट इट? दैट इज अबाउट 3 cell model of Farrell. Okay, and now you need to know very important thing. ENSO, that is El Nina, La Nina, etc. things. Now we are going to discuss about ENSO. What is ENSO? N का मतलब होता है El Nino, SO का मतलब होता है Southern Oscillation. We are going to discuss about ENSO, El Nino, which is happening in the Southern Ocean. That is ENSO. And second, we are going to discuss about La Nina. Okay, these two phenomenons. Now we are going to discuss about ENSO. What is ENSO? EN, everyone knows that EN stands for El Nino. El Nino. And SO stands for Southern Oscillation. Okay. Southern Oscillation. First, let us see what this Southern Oscillation means. See, Southern Oscillation का मतलब होता है below the equator. I have drawn Earth like this for my simplicity. This is our world map. Okay, and this is our seabed. Got it? Now this is our Asia, Australia, and this is North America and South America. And we are discussing about Pacific Ocean. This El Nino, La Nina, whatever phenomenon that we are going to see, that is in the Pacific Ocean. So before even starting ENSO, I want to first start what is neutral phase. See, we first have a neutral phase. Okay, this phase we are going to see, and next we are going to see how it's different from El Nino, and next we are going to see La Nino. These three things we are going to see. Okay, now when I said ENSO, there you have seen that we are talking about Southern Oscillation. Okay, so now that means whatever that we are going to observe, it is in the Southern Oscillation. Southern Oscillation मतलब Southern Oscillation का मतलब क्या है? S का मतलब साउथ, that is Southern Hemisphere. Below the equator we are seeing this phenomenon. And oscillation का मतलब है कि कुछ तो oscillate हो रही है. वो क्या oscillate हो रही है? What's oscillating is the temperature, the warm temperature that is oscillating. Warm temperature, कभी कभी ये warm temperature हो रही है, कभी कभी ये. तो so the temperature it is oscillating here to here. So that is why we are calling it as Southern Oscillation SO. Now we need to see what's El Nino and what's La Nina. But before even that we need to see what is actually happening in a neutral phase. Okay. Now I will tell you what happens in a neutral phase. See, this is our equator. यहाँ पे सन होगा, इसका मतलब ये कि ये रीजन वार्म हो जाएगा, राइट? सो यू आर हैविंग सम वार्म ओशन हियर, एंड यू आर हैविंग ट्रेड विंड्स आल्सो. ट्रेड विंड्स, which direction do they travel? Trade winds that equator region. See, you know our planet Earth, right? These are easterlies, right? Here we have seen easterlies. Easterlies का मतलब क्या निकलता है? Trade winds, they are originating from east. So this is our map, and this is west, this is east. So they must originate from east, right? Trade winds. तो equator के area पे trade winds they are moving in this direction, right? So trade winds they are taking warm oceanic water in a neutral phase to where? To नॉर्थ अमेरिका, सॉरी, टू एशिया एंड ऑस्ट्रेलिया. गॉट इट? सो पहले न्यूट्रल फेज में मैं कुछ वार्म ओशियनिक करंट लिखूंगी जो यहाँ पे है, लेकिन ये ट्रेड विंड ने क्या किया? ट्रेड विंड ने, दैट इज ईस्टर्ली, ये ट्रेड विंड ने क्या की? ईस्ट से आया और इसको वेस्ट की तरफ खींच के गई. गॉट इट? So in the same diagram only, now that warm oceanic current it traveled to here. So here you are having warm oceanic current, right? Now you need to understand that this became the low pressure area. So warm जहाँ पे है वहाँ पे low pressure create होती है ना, तो यहाँ पे low pressure create हो गया. Low pressure create होने के बाद क्या होती है कि लो प्रेशर क्रिएट होने के बाद क्या होती है? एवापोरेट हो जाती है. सो दिस वाटर इट एवापोरेट्स. आफ्टर टाइम क्या होगी? ट्रोपोपॉज, इट विल रीच द ट्रोपोपॉज. एंड हाउ इज ट्रोपोपॉज? Tropopause is cool because you know lapse rate, height increases, temperature decreases, and tropopause is the coolest in the troposphere. Therefore, when this warm oceanic current meets a troposphere, it will finally precipitate. Okay, finally precipitation occurs after condensation. तो मैं उसको ऐसे लिखूंगी और यहाँ पे ही मैं प्रेसिपिटेशन भी लिखूंगी. सी, लॉट ऑफ पीपल विल थिंक दैट ओके ये लो प्रेशर है ना, तो यहाँ पे कोल्ड ओशियनिक करंट है तो ये हाई प्रेशर हो गया है ना. दैट्स एक्चुअली करेक्ट. दिस इज हाई प्रेशर. नाउ पीपल विल थिंक दैट दिस इज हाई प्रेशर. तो यूजुअली जैसे कि हम प्लैनेटरी ड्रॉ करते हैं ना, ये लो प्रेशर और ये हाई प्रेशर, सबट्रॉपिकल हाई प्रेशर. तो बारिश तो यहाँ पे नहीं होगी ना, बारिश कहाँ पे होगी? हाई प्रेशर बेल्ट पे जाके वहाँ पे बारिश होगी ना. तो लॉट ऑफ पीपल विल थिंक प्रेसिपिटेशन विल हैपन एक्चुअली हाई प्रेशर. नो, दैट इज द डिफरेंस बिटवीन द प्लैनेटरी सर्कुलेशन दैट वी आर सीइंग एंड एल निनो ला निना. दैट्स व्हाई पीपल नीड टू एक्चुअली फोकस एल निनो ला निना. तो बारिश यहीं पे हो जाएगी लो प्रेशर एरिया पे. ओके, एंड उसके बाद क्या है? बात क्या होती है? बारिश यहीं पे होगी एंड ये जो एयर है वो ड्राई हो जाती है। क्यों ड्राई हो जाती है? यहाँ पे टेम्परेचर कूल है ना, सो सी वार्म एयर वट एवर इट इज लेफ्ट दैट इज गोइंग टू बिकम लाइक एन आइस। तो इसका मतलब है कि वो ड्राई हो रही है, इट इज नॉट मॉइस्ट, सो दैट ड्राई एयर इट विल मूव 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 एंड फाइनली हाई प्रेशर है ना, हाई प्रेशर मतलब सिंक एंड डाइवर्ज है ना, तो ये हाई प्रेशर एरिया पे क्या कैसे विंड्स आएगी? ड्राई विंड्स आएगी। ओके, लेकिन सिंक एंड डाइवर्ज मतलब पानी नहीं आएगी यहाँ पे, सिर्फ कोल्ड एयर आएगी, कोल्ड एयर। रिमेंबर ओनली कोल्ड एयर, इट्स नॉट प्रेसिपिटेशन। प्रेसिपिटेशन हैपेंस हियर ओनली एट द दिस एरिया, गॉट इट? तो क्या हुआ? ऐसा ऐसे एंड देन ऐसे, so you are perfectly able to see Walker circulation in the neutral phase. In neutral phase Walker circulation happen. This is not some La Nina just because you are seeing La raha hai barish. No, this is just a neutral phase. But yeah, neutral phase and La Nina, they are almost similar. Okay, now we have seen this neutral phase, right? We have seen the neutral phase. Now we need to see what is happening in El Nina. See, El Nina, it is El Nino, southern oscillation El Nino. Okay, fine. Now I want to tell you that the warm oceanic current, whichever it was there here, now that is not having much energy. Where am I? Yeah, that is not having the momentum to stay here. कोई ट्रेड विंड्स नहीं है इस टाइम पे, यूजुअली सीजन के ऊपर डिपेंड करती है ना ट्रेड विंड्स आल्सो, सो दैट टाइम दे विल अगेन गो बैक टू हियर ड्यूरिंग एलिना। सो ड्यूरिंग एलिना वार्म ओशियनिक currents go back and they go to this place. Okay, when this happens na, what's ultimately going to be there? See, that is why I'm calling El Nino La Nina is different from neutral phase. In the neutral phase we are not using the seabed anywhere, but now in El Nino La Nina I'm going to talk about the seabed also. See, since this is warm oceanic current, but here in the neutral phase we have seen it is cold, therefore this warm oceanic current they are replacing cold, the cold water it will submerge, so the cold water it is going to be submerged. तो ये cold water submerge होके कहाँ जाएगी? लेकिन ये कहीं और पे जाना चाहती है ना, so it will go here this side, got it? ये cold oceanic water submerge होके इस साइड चली जाएगी, got it? This became cold, got it? Now this is warm and this is cold. वार्म पे हमने ऑलरेडी डिस्कस किया, लो प्रेशर पे वहीं पे बारिश होगी, सो प्रेसिपिटेशन हैपेंस हियर ओनली, clouds will be there and precipitation will happen here only. But what is happening here? It is cold, so it is bringing drought wala conditions here to the Asia and Australia. Okay, so western Pacific Ocean it is receiving drought condition, and eastern Pacific Ocean like Peru etc. they are receiving precipitation. Got it? That is ENSO. Now the general question people ask is the Walker circulation diminishing? And the answer is yes. Walker circulation it is diminishing. For example, let's take this like this. ये वॉकर सर्कुलेशन ना पूरा फिनिश नहीं हो रही है, ये डिमिनिश हो रही है क्योंकि इट इज स्प्लिटिंग इनटू टू हाफ्स लाइक दिस। ये पूरा कोल्ड करंट है यहाँ पे, व्हाट इट, एंड दैट्स व्हाई इट बिकेम ड्रॉट। सो एक्चुअली द वॉकर सर्कुलेशन इट इज स्प्लिटिंग इनटू डाइपोल्स, टू डिफरेंट डाइपोल्स. That is what you need to understand. In the El Nino phase, water circulation it is diminishing and we are receiving drought conditions. Got it? That is in the El Nino phase. And the convection is happening where? The convection is happening near America and South America. Okay, now we need to see what's happening in La Nina. Okay, La Nina it's different. See, La Nina it is similar to neutral phase only. Neutral phase में हमने क्या देखा कि warm ocean current it is here ना, तो यहाँ पे पहले cold है ना, सी दैट्स द सेम थिंग। अब वार्म ओशन करंट इस साइड जाएगी, लेकिन यहाँ पे तो कोल्ड है हमने देखा, तो ये कोल्ड फिर से वापस क्या करेगी? नीचे सबसाइड हो जाएगी, नीचे सबसाइड होकर किस तरफ जाएगी? इस तरफ चली जाएगी। सो हियर इट इज गोइंग टू बी कोल्ड नाउ, राइट? हियर यू आर गोइंग टू कोल्ड ओशियनिक वाटर. सी, current is different from water. When I am taking it like this, that is cold oceanic water. Okay, and when I am moving a current, that is current. Now cold oceanic water it is going to be there here. Got it? And whenever cold oceanic water surfaces, now remember that it is going to bring phytoplankton growth, or else you are going to get high number of fish production, etc. things, because it is denser. So they are going to bring nutrient-rich water. Anyways, now coming to the point, this is warm oceanic current. Therefore, it is low pressure now, and since this is cold oceanic water, it is high pressure now. तो यहाँ पे similar scenario देखेंगे हम कि पहला ये convection हो जाएगी और बारिश यहीं पे बरसेगी, और क्या ड्राई हो जाएगी एयर, ड्राई होके होके यहाँ पे एयर करंट्स हम देखेंगे. बट इट दिस इज व्हाट वी कॉल this is what we call Walker circulation. So Walker circulation is observed in the La Nina phase, but it diminishes in the El Nina phase. Okay, that is ENSO. I will read out a question for you. El Nino increases the plankton. El Nino matlab ye. Now the question is saying true or question is asking true or false. Okay, El Nino increases the plankton growth and fish production in the Eastern Pacific Ocean. Is this correct? El Nino, is it increasing fish production in the Eastern Pacific Ocean? Which side is Eastern Pacific Ocean? This side. This is Western side. अब cold current, cold oceanic water किस side जा रही है? इस side, west side. तो west side production ज़्यादा होगा, Western Pacific Ocean. Therefore, that statement goes wrong. Got it? So in using this logic, you need to attempt prelims questions. Just remember the simple logic that I said you in the beginning. El Nino ले मतलब ले रही है बारिश, and La Nina ला रहा है बारिश. Got it? ला रहा है बारिश मतलब low pressure high it is going to be here. Sorry, low pressure is going to be here. Warm oceanic currents are moved here this side, and therefore precipitation will happen here. And after it becomes dry, it goes to the high pressure. But high pressure पे बारिश नहीं होगी क्योंकि वहाँ पे cold oceanic water आ रही है. Okay, that is cold oceanic current. And then in the what is that? It is in the La Nina. And if it is El Nina ना, El Nina पे क्या होगी? ले रही है बारिश. तो warm oceanic current सब इस side है, तो यहीं पे precipitation होगी. लेकिन Walker circulation to two parts में divide हो जाएगी. That is why Walker circle diminishes. That is what we say in the El Nino phase. Now I'll tell you different terms that you can find it in the prelims. For example, doldrum. Doldrum is a state of confusion. State of confusion due to weak winds. Usually in the historical times, sailors they used to use these trade winds to do navigation. But when there are weak winds, you cannot really do navigation, right? Because पानी आपको खींच के नहीं लेके जा रहे, खुद मेहनत करना पड़ेगा. So it is a state of confusion due to weak winds. It usually happens near the intertropical convergence zone where we see calm air, weak winds. Okay, therefore ancient sailors they get confused and they gave this term doldrum. Doldrum क्योंकि ऐसा याद रखना कि ड्रम वो वीक विंड की वजह से वो कंफ्यूजन स्टेट में चला गया, कंफ्यूजन स्टेट में जाके ड्रम बजाना शुरू किया, डोलड्रम. रिमेंबर लाइक दैट व्हाटएवर मेमोरी ट्रिक यू कैन यूज. एंड नेक्स्ट वी हैव हॉर्स लैटिट्यूड. सी हॉर्स लैटिट्यूड का मतलब होता है these are the latitudes, these latitudes located at the 30 degree north and 30 degree south of equator, characterized by sinking air, high pressure. देखना, these are the latitudes with sinking air and high pressure. They are also called high latitude because these are also weak areas. यहाँ पे भी winds weak होगी. See, even near the equator, they are weak. That is why near equator I'm calling them doldrum, and if it is near 30 degree north and south, then I'm calling it horse latitude. Horse latitude doesn't mean that winds are moving speed. No, winds here also they are weak, and sailors are they are again confused even near 30 degree north and south. And इस बार उन्होंने ड्रम्स बजाना के अलावा कुछ और प्लान सोच लिया कि चलो इस हॉर्सेस को फेंक देते हैं पानी के अंदर. It will reduce the capacity of the boat and they can do their sailing. Got it? That's all. They are horse latitude and it is near 30 degree north and south. Remember, if it is near 30 degree north and south, it is a horse latitude and they are characterized by sinking air, that we know, and it is high pressure, that also we know, and they are weak wind areas. And doldrum, it is near intertropical convergence zone, state of confusion near equator. And next we have easterlies and westerlies. They are nothing but trade winds. See, I'm talking about easterlies. Easterlies are also called trade winds. अगर कोई trade winds पूछता है, so immediately mark it as easterlies. Got it? ये मत सोचना कि वो westerlies है. Trade winds, just mark easterlies as correct. Got it? Trade winds easterlies. Okay. And next, I want to tell you offshore east and offshore west. कैसे किसको क्या बोलते हैं? See, if you are getting east or east, and let's say this is your continent or place, whatever. Now, if there are east or east, oceanic water ये है, तो offshore east पे क्या होगा? पानी बरसेगी, है ना? So rainfall will be at the offshore east. नहीं, इसको ऑफशोर नहीं बोलेंगे, इसको ऑनशोर बोलेंगे ना, क्योंकि पानी आ रही है, राइट? दैट्स व्हाई वी आर कॉलिंग इट ऑनशोर ईस्ट. बट व्हाट्स हैपनिंग हियर, ईस्टर्लीज की वजह से यहाँ पे डेजर्ट बन रही है, सो दैट इज व्हाई वी आर कॉलिंग ऑफशोर वेस्ट. सो ईस्टर्लीज दे ब्रिंग यू ऑफशोर, सॉरी ऑफ नहीं, ऑनशोर ईस्ट एंड ऑफशोर वेस्ट. ओके, ऑनशोर ईस्ट एंड ऑफशोर वेस्ट, दैट इज अबाउट ईस्टर्लीज और ट्रेड विंड्स. नाउ वेस्टर्लीज के बारे में डिस्कस करते हैं. वेस्टर्लीज को हम ट्रेड विंड्स नहीं बुलाते, लेकिन डिपेंडिंग अपॉन द लैटिट्यूड वी कॉल इट डिफरेंट नेम्स. आई मीन, आई थिंक इट इज फॉर द सदर्न लैटिट्यूड ओनली दैट वी गिव दिस डिफरेंट नेम्स. फॉर एग्जांपल, इफ यू आर एट द 40 degrees south, 40 degrees south, only in the southern, that's right, it is only in the southern that we give this name, not in the northern. Okay. So if you are at the 40 degree, it is called rearing forest. 40 degree पे we call it rearing forest, and 5 for F, that is furious. So furious 50s, that is 50 degrees southern latitude. And if it is 60, 6 का मतलब screaming 60. So furious 50, screaming 60, and rearing forest, that is 40. So you are having different names for westerlies. Got it? Rearing forest, furious 50, and screaming 60. So westerlies यहाँ पे होगी या यहाँ पे होगी? Usually it happens here and here, right? Where between subtropical high pressure belt and temperate low pressure belt we get to see westerlies. Got it? यहाँ पे आएगी, हम westerlies देखेंगे. So they originate from where? They seem like they are originating from west. Got it? I have drawn this wrong. So yeah, they seem like they are originating from west. That is why we have given that name westerlies. Okay. Now I want to tell you that they are variable. They are variable in the northern hemisphere. Westerlies, they look very variable in the northern hemisphere and uniform in the southern hemisphere. That is why you get to see a lot of hurricanes, etc. in the northern hemisphere. The reason is simple: extratropical cyclones and all, they are observed because of variability only. Due to why is this variability in the north and why not in the south? The reason is a complex mix of land and sea. That is the reason for the variability. Complex mix of land and sea. Okay. मैंने ऑलरेडी बताया कि अगर लैंड सरफेस ज्यादा है तो विंड्स को बहुत फ्रिक्शनल रेजिस्टेंस झेलना पड़ेगा. दैट्स व्हाई इट इज वेरिएबल इन द नॉर्दर्न हेमिस्फीयर. एंड नेक्स्ट, इफ वी डिस्कस ऑफशोर एंड ऑनशोर फॉर एनी continent in the temperate belt, see, between subtropical and temperate belt, here the westerlies, they are going to bring what? They are going to bring onshore west. This is not off. Okay, जहाँ पे बारिश हो रही है वहाँ पे, so this is going to bring onshore west. Therefore there will be rainfall in the which coast? In the east coast of the continent, and there is going to be drought condition in the west coast of the continent. Okay, that is onshore west and offshore east. So till now we have seen easterlies, which are called trade winds, right? And again we have seen westerlies, right? And now we need to see polar easterlies. Okay, polar easterlies, they are actually weak. They are weak. The reason being they have less mass of air, क्योंकि वहाँ पे water vapor ही नहीं है ना. हमने देखा है water vapor equator के एरिया में ज़्यादा है, and water vapor that is what 4% of the atmosphere, total volume of the atmosphere. And here कितना था? यहाँ पे I think it is almost negligible water vapor. So that is why we are seeing lesser mass of air and lesser amount of insolation. These are the reasons why the winds, the polar easterlies, they are weak, because insolation ही नहीं है, and then I mean lesser amount है, and then they are having lesser mass. Okay, polar easterlies, they are weak. Now you are having cold dry winds here, and they are highly variable again. क्योंकि why? You are near temperate low pressure belt, because these winds are moving from polar high pressure to temperate low pressure, right? Subtropical high, temperate low pressure belt. So from polar high pressure you are moving to temperate low pressure, high pressure to low pressure, right? And in the temperate, if you know, they are variable again, especially in the northern hemisphere they are variable. So here you get to see variability. Polar easterlies, they are weak and they are also variable. So finally, I'm concluding planetary winds. They are also called prevailing winds, and we have easterlies, westerlies, and polar easterlies. And secondary winds, they are not planetary winds. They are additional to planetary winds. That is why we are calling them secondary winds. And prevailing winds, if they ask, they are also prevailing. Implies planetary. That is primary. PPP. ऐसे याद रखना. P primary, prevailing, planetary. These are the main. But secondary, they are atmospheric disturbances. Example: seasonal winds and local winds. Seasonal winds and local winds. Okay. You are having a different local winds and a different seasonal winds. Season मतलब different season पे different winds होते हैं. Example monsoon winds in the Southeast Asia. They are example for seasonal winds. But if you see local winds ना, hot local winds, cold local winds अलग अलग होते हैं. For cold local winds I remember Mr. Bora and Blizzard. Mr. Bora and Blizzard. Blizzard I can remember for cold. Mr. Bora मतलब Mistral and Bora, and they are also cold local winds. In exam to give some examples. And hot local winds Lu and Foyne. Lu and Foyne I can still remember if I say 2-3 times. Rest of them it is different. It is difficult. Harmat Tansi Rukko and Chinook. But yeah, they are hot local winds. If I need to write example in the mains. Okay, that is seasonal and local winds. And we have land and sea breezes. Land and sea breeze, see, this is land, high pressure, and this is sea, which is low pressure. Now, why this became high pressure and why this became low pressure? That is daytime and nighttime. See, during daytime, what's going to happen? I have already discussed this. Anyways, during daytime, this is going to behave low pressure. तो ये है daytime पे ये डायग्राम है. लैंड के ऊपर लो प्रेशर आएगा. जब लैंड लो प्रेशर आएगी तो क्या आएगी? ये ऊपर जाएगी और सी की तरफ जाएगी. ओके, एंड फाइनली सी इज हाई प्रेशर, तो यहाँ पे एंड सी हाई प्रेशर है ना, ये लो प्रेशर है तो सी हाई प्रेशर है. गॉट इट. कोल्ड वाटर इज गोइंग टुवर्ड्स हाई प्रेशर. नाउ ये हाई प्रेशर टू लो प्रेशर ट्रैवल करना पड़ेगा हॉरिजॉन्टल डायरेक्शन पे. हमने देखा ये प्रिंसिपल पैरेलल टू अर्थ लागू होगी. सो हियर यू आर गोइंग टू सी हाई प्रेशर टू लो प्रेशर, एंड दैट इज व्हाई वी आर कॉलिंग इट as sea breeze. So basically when the land is at low pressure during daytime and when sea is at high pressure you get breezes from high pressure to low pressure from the sea, and that is why during daytime you get to see sea breeze. So sea से हमें ठंडी ठंडी हवा आती है. That's why during daytime we tend to go to sea. Okay, we tend to go towards sea during daytime because ठंडी ठंडी हवा आ रही है. But what's happening in the night time? नाइट टाइम ना लैंड इट बिकम्स हाई प्रेशर एंड सी बिकम्स लो प्रेशर. सिंपल, ये कूल है, कूल का मतलब हाई प्रेशर है ना, एंड सी इट इज लो प्रेशर. देयरफॉर हाई प्रेशर टू लो प्रेशर, एंड इफ यू सी एक्चुअली द कूल विंड्स आर मूविंग टुवर्ड्स द लैंड. दैट्स व्हाई नाइट के टाइम पे यूजुअली लोग जब जाएंगे भी उनका हेयर फॉल ना, जब भी आप देखना नाइट टाइम पे देयर हेयर इट मूव टुवर्ड्स द सी बिकॉज winds are moving this direction. Therefore my hair also it tends to blow in this direction when I went to some beach etc during night time. Okay, this is land high pressure and sea low pressure, and you get to see winds in this direction. That is why it is called land breeze, because breeze is moving from the land to the sea. So that is land breeze and sea breeze. Okay, that's how it happens during daytime and night time. Okay, so during daytime we observe sea breeze, sea से आएगी, and during night time we observe land breeze क्योंकि land से sea की तरफ जाएगी night time पे land breeze. Okay, and next we need to see mountain and valley winds which you already know. Okay, daytime and night time देखना, अब मैंने बताया already. daytime का मतलब क्या है? We are talking about different winds. That is why I am discussing all these winds again. See, daytime पे क्या होगी? सनी है, सनी का मतलब होता है लो प्रेशर, है ना. So low pressure will be created. If this is low pressure, this is high pressure. So from where it must go? It must go from high pressure to low pressure. तो डायरेक्शन ऐसे होगी ना. That is why it is called valley breeze during daytime. And valley breeze को हम एक और नाम देते हैं. What is that? Anabatic wind. Anabatic. Okay, anabatic wind. And night time पे हम क्या बोलते हैं इसको? Katabatic. कैसे याद रखोगे? डे में ये है तो एनाबैटिक. अब नाइट में, नाइट को हम ऐसे भी नाइट बोलते हैं ना, के. सो कैटाबैटिक. You can try to memorize anabatic and katabatic like that. And during night time it is cool, therefore it is high pressure, and this is low pressure, and high pressure to low pressure. That is why since the wind is from mountain, we are calling it as mountain breeze. That is mountain wind. That is difference between mountain breeze and valley breeze. Valley breeze happens during daytime because this is high pressure, and mountain breeze happens during night time because this is the high pressure. That is why we can see mountain breeze. And during mountain breeze, I think we have discussed the temperature inversion also. दैट सिंस दिस इज हाई प्रेशर, तो ये कूल डेंस से कहाँ पे जाएगी? नीचे जाएगी. तो ये और कूलर बन गया ना, क्योंकि यहाँ पे चली गई है नाइट टाइम. सो हियर द टेम्परेचर इज लो एंड हियर द टेम्परेचर इज हाई. Therefore we are seeing temperature inversion during mountain breeze. That we discussed in temperature inversion during night time in the mountain valley area. Why? क्योंकि कोल्ड डेंस से नीचे चली गई ना, दैट इज व्हाई बिकेम, इसका टेम्परेचर बहुत लो हो गया. एंड दिस प्रिवेंटेड द फ्रॉस्ट डैमेज. एंड एयर masses, if you see, we have different characteristics based upon the temperature and humidity. एयर मास को हम डिफरेंट क्लासिफिकेशंस कर सकते हैं बेस्ड अपॉन द 5 मेजर रीजन्स. दिस वार्म टेम्परेट एंड सबट्रॉपिक ओशंस, सीटी, एमपी, सीपी एंड सीए. तो मुझे नहीं लगता है कि ये कुछ इंपॉर्टेंट है. ओके, बट या सी एमटी क्या है? एमटी का मतलब है मैरीटाइम ट्रॉपिकल. गॉट इट. इफ यू सी मैरीटाइम ट्रॉपिकल, दैट इज एमटी. First remember the names. Okay, MT is maritime tropical. C मतलब continent, so that is continental tropical. And next MP again. MP मतलब maritime polar. CP मतलब continental polar. And CA का मतलब continental arctic. Okay, continental polar, continental arctic. And CT continental tropical. MT maritime tropical, maritime polar. So you know 5 major regions where you get to see different air mass. I think it is in the NCERT. That is why I wrote. So here where this is usually observed, this maritime tropical. ये maritime tropical air mass कहाँ पे हम देखेंगे? We see this near warm temperate and subtropical oceans. Maritime मतलब ocean. Okay, and it is near warm temperate and subtropical. You remember that maritime it is associated with warmness, and that is why I'm saying warm tropical and subtropical oceans. Tropical and subtropical, warm tropical and subtropical ocean. And we have CT, that is continental tropical, मतलब subtropical hot desert. CT, subtropical hot desert. Continental tropical is usually at subtropical, and continental tropical बोल रही हूँ तो hot desert याद रखना. There you get to see a different air mass. So subtropical air mass is different, and then you get to see cold high latitude ocean. वहाँ पे भी air mass different. Okay, maritime polar मतलब cold high latitude, maritime matlab again it is ocean, and polar matlab cold high latitude, so that is a cold air mass. And we have CP, that is continental polar. Continental polar matlab polar, it is snow covered, right? Snow covered and continental, so it is in the continent and it is in the high latitude, that is why we are telling continental polar. And then we have CA, that is continental arctic. Continent है, so it is in the Arctic, sorry, it is in the continent. And Arctic है, that means it is permanently ice covered air mass which is in the Arctic and Antarctic. So just based upon the name, try to guess. Maritime implies ocean and tropical implies it can be warm tropical and subtropical. And if it is a continental tropical, वहाँ पे ocean भी नहीं है, तो इसका मतलब just think of it as a hot desert, subtropical hot desert. And maritime polar, maritime again it's ocean, and polar मतलब some cold high latitude. And CP, C का मतलब, sorry, P का मतलब है कि it is snow covered, and C का मतलब है it is again in the continent, which is in the high latitude because it is in the polar. And CA का मतलब होता है it is in the continent. So these are the different air masses which I don't think they never would ask, but I thought I should discuss, and that's why I discussed. But this will be asked. Friends, 4 types of friends that we have. Okay, warm front, cold front, occluded front, and stationary front. These are the 4 fronts that you need to know. So front happens when two different air masses meet and they form a boundary. Let's say that that phenomenon is called frontogenesis. See, when two different air mass, let's say this warm air mass, it is meeting cold air, or else let's say this is warm air. This is not some water, right? This is some air actually that is meeting some cold other air. So when two different air mass, now we discuss the different types of air mass. They can be many different, but these are the major based upon the temperature and humidity. Now such kind of different masses, when warm air mass, when it is meeting cold air mass, it forms a boundary. That boundary is called frontogenesis or formation of front. So here when warm air meets cold air, we see warm front, and when cold air meets warm air, we see cold front. That's all. अगर warm air जाके cold air के साथ टकरा रही है, so warm front बन जाएगी. अगर cold air जाके warm air के साथ टकराएगी, तो वो बन जाएगी cold front. And next we have occluded front. See, here we have some warm air, right? When cold air it meets warm air, that will create cold front, right? When cold air meets warm air, that is going to create cold front. And similarly, here you are having warm air, right? That is also going and meeting with some other cold air. So when warm air meets this cold air, it will create a warm front, right? Because this is meeting warm air and this is meeting warm air. Sorry, this is meeting cold air and this is meeting warm air. So this is meeting this, so cold front create होगी, and this is meeting this, so warm front create होगी. Now what's going to happen is that you are having two fronts, cold front and warm front. Now अब ऐसा सिचुएशन होगी कि ये cold front है ना, इस warm front को ऊपर लेके जाएगी, क्योंकि see this is cold, तो ये denser है ना, तो denser नीचे रहेगी, और warm है तो वो हल्का weight है, so that will go above. Got it? The warm air it raises above and finally it precipitates also. Got it? But here the cold air it is going to stay below, and that is called as occluded front. Stationary front matlab the front which is stationary. I have nothing much to say. See, now we are going to discuss extratropical cyclones. Okay, for extratropical cyclones I need to discuss this with you. Let's say this is our equator and this is 30 degree north, 60 degree north, and this is our north pole. तो क्या होगी कि इक्वेटोरियल लो प्रेशर बेल्ट, सबट्रॉपिकल हाई प्रेशर बेल्ट, एंड दिस इज टेम्परेट लो प्रेशर बेल्ट. तो यहाँ पे वार्म एयर है ना, वार्म एयर यहाँ पे है, एंड नॉर्थ पोल पे क्या है, कोल्ड एयर है ना. सो व्हेन वार्म एयर एंड कोल्ड एयर दे मीट, what is going to happen, fronts are going to be created, right? Fronts are going to be created. Now here is the catch. Fronts are going to be created, but this warm air it will raise above the cold air, क्योंकि warm air हल्का है, it is less weight, I mean light weight, it is having lighter weight, that is why it will go above the cold air, and finally यहाँ पे कुछ low pressure area create होगी. Got it? यहाँ पे एक लो प्रेशर एरिया क्रिएट होने के बाद ये ऊपर जाएगी, जो भी वार्म एयर एंड कोल्ड एयर मिला है, तो वो कन्वेक्शन का प्रोसेस एक ना एक पॉइंट पे होना चाहिए. सो कन्वेक्शन इज गोइंग टू हैपन एंड क्यूमुलोनिम्बस क्लाउड्स विल बी फॉर्मड एंड दैट विल लीड टू प्रेसिपिटेशन आल्सो. जो व्हाटएवर फिनोमेनन दैट लो प्रेशर एरिया ऐसे ना एक पॉइंट पे लो प्रेशर क्रिएट होगी, सो व्हाटएवर फिनोमेनन और स्ट्रीम्स दैट यू ऑब्जर्व हियर, दे आर बेसिकली कॉल्ड जेट स्ट्रीम्स. ओके, जेट स्ट्रीम्स. गॉट इट? दे आर सिमिलर टू एक्स्ट्रा ट्रॉपिकल साइक्लोन्स ओनली. नाउ जेट स्ट्रीम्स you can see at two places, near subtropical and near temperate low pressure belt. You can see two types of jet streams, subtropical jet streams and subpolar jet streams. If it is at 23 and off degree north, that is subtropical, right? So that we call subtropical jet stream, and if it is at 66 and off degree north, we call it as subpolar jet streams. See, in this example I said ना कि एक पॉइंट पे एक फिनोमेनन क्रिएट होगी, जेट स्ट्रीम लो प्रेशर क्रिएट होगी, वो फिनोमेनन ऐसे दिखेगी, ऐसा कुछ. सी, दिस इज वार्म फ्रंट एंड दिस इज सम कोल्ड फ्रंट, एंड ऐसा कुछ जेट स्ट्रीम्स क्रिएट होगी 60 डिग्री नॉर्थ पे. गॉट इट? दिस इफ यू सी इन द वर्टिकल डायरेक्शन. And now they are extra tropical cyclones, these are jet streams whatever we are seeing. But if they are tropical cyclones, they are happening near the tropical areas. Okay, if it is near equator we call it as a cyclone. See, cyclone के बहुत different names हैं, लेकिन अगर वो cyclone tropical area पे होगी तो इसको हम बोलेंगे tropical cyclone. And tropical cyclones they occur only over the ocean. See, if it is near India we call it a cyclone, and if it is near Japan etc we call it a typhoon. Japan नहीं, चाइना याद रखना. Okay, यहाँ पे चाइना लोग टाइफून बोलेंगे ना, तो चाइना याद रखना. And if it is near India it is cyclone, and if it is near Australia Willy Valley, and if it is near North America we call it as a hurricane. Okay, that is about tropical cyclone. I mean that is about cyclone. Tropical cyclone का मतलब है कि it is happening in the tropical areas, that's all. Now let us see the conditions for this cyclone to become a tropical cyclone. कि पहला condition, sea का temperature 27 degree Celsius से ज़्यादा होना चाहिए, and Coriolis force must be there. If Coriolis force is not there, how can it become a cyclone? So Coriolis force must be there, and vertical wind speed must show some variation. हमने देखा है ना कि वर्टिकल डायरेक्शन पे विंड नहीं होगी, क्योंकि इट विल बी बैलेंस्ड विद द ग्रेविटी. बट नाउ फॉर दिस ट्रॉपिकल स्टॉर्म्स टू हैपन, वो वर्टिकल डायरेक्शन के फिनोमेनन है ना, साइक्लोन्स है. तो साइक्लोन्स आर द एग्जांपल्स फॉर आवर वर्टिकल विंड्स. गॉट इट? वी हैव आई सेड यू दैट कन्वेक्शन इट इज वर्टिकल ट्रांसफर ऑफ हीट, एंड आई सेड एडवेक्शन. लेकिन हॉरिजॉन्टल पे मैं लोकल विंड्स इमेजिन कर पा रही हूं, बट आई एम नॉट एबल टू इमेजिन वर्टिकल डायरेक्शन. व्हाई? बिकॉज़ वर्टिकल डायरेक्शन में प्रेशर डिफरेंस ही नहीं है, तो क्या विंड होगी? बट साइक्लोन्स दे आर एग्जांपल्स. व्हाई? बिकॉज़ इन साइक्लोन्स यू रिक्वायर वर्टिकल विंड वेरिएशन. ओके, एंड नेक्स्ट प्री एक्जिस्टिंग वीक लो प्रेशर एरिया. See, you need to have low pressure area. ऑलरेडी प्री एक्जिस्टिंग लो प्रेशर एरिया। सी एज आई सेड सी टेंपरेचर 27 डिग्री सेल्सियस से ज़्यादा होना चाहिए, तभी तो ये वार्म होगी, तभी तो एक लो प्रेशर एरिया क्रिएट होगी, तभी तो वर्टिकल विंड वेरिएशन भी है उस पोजीशन पे, एंड दे आर ऑल एंड द कोरियोलिस फोर्स इज आल्सो हेल्पिंग फॉर द क्रिएशन ऑफ द ट्रॉपिकल साइक्लोन। ओके, at least it must have some low level cyclonic circulation, and there must be upward divergence, and that will ultimately create this tropical cyclone, and you know that will be concentrated near the low pressure, यहाँ पे आई है, and इसको हम क्या बोलेंगे, आई वॉल। so from eye wall the whatever water is there, it will convergent raise। see यहाँ पे हाई प्रेशर एरिया से वाटर इकट्ठा हो रही है लो प्रेशर पे, एंड इट इज कन्वर्जिंग एंड इट इज रेजिंग इन द आई वॉल्स। तो यहाँ पे जो है ऑपोजिट रिएक्शन की वजह से इट इज सबसाइडिंग इनसाइड, गॉट इट। एंड इस आई का डायमीटर कितना है, इट इज समवेयर बिटवीन 150 to 250 किलोमीटर्स, एंड यहाँ पे क्यूमुलोनिम्बस क्लाउड से तो बारिश होगी यहाँ पे। ओके, दैट इज अबाउट ट्रॉपिकल साइक्लोन। दिस इज अबाउट जनरल साइक्लोन, एंड ट्रॉपिकल मतलब इट विल हैपन ओनली ओवर द ओशियंस, गॉट इट। cyclones they can be, again I'm telling you, tropical and extratropical that we have seen, and extratropical as we have seen they can happen over land and ocean. Tropical they must happen definitely over the ocean. See now this whatever you are seeing now, who said that it cannot happen over the land? We are just talking about air masses here, extratropical which are happening somewhere at a 10 kilometer. See at 10 kilometer you are seeing these jet streams, got it, near where, near the temperate low pressure and subtropical high pressure you are seeing these jet streams, got it. That is why they are actually associated with the air masses, but when you are saying tropical cyclone they are associated with the water, warm oceanic water. So now you need to see the differences between extratropical and tropical. See extratropical it is mainly due to clear frontal system, but tropical it is not due to frontal system, and extratropical they can originate over land and sea, but tropical they originate over sea only, and finally they reach land. सिंपल ना, साइक्लोन ओरिजिनेट और सी आई ऑलरेडी सेड दिस इज आवर ओशन, एंड साइक्लोन मतलब यहाँ पे क्रिएट होगी, सुनामी मतलब यहाँ पे क्रिएट होगी, तो सुनामी का कोई चांस ही नहीं है, हम डिस्कस भी नहीं कर रहे हैं, बट डिस्कसिंग अबाउट साइक्लोन एक्स्ट्रा ट्रॉपिकल एंड ट्रॉपिकल। तो ये यहाँ पे ओरिजिनेट होगी, ओरिजिन तो हमेशा ओशन ही है, लेकिन ये लैंड के ऊपर चली जाएगी, बिकॉज ये पॉइंट यहाँ पे है ना, लैंड के ऊपर भी चली जाएगी, गॉट इट। दे ओरिजिनेट ओवर द सी एंड दे रीच लैंड, ओके, बट दे दिस एक्स्ट्रा ट्रॉपिकल दे कैन ओरिजिनेट ओवर बोथ लैंड एंड सी, एंड एक्स्ट्रा ट्रॉपिकल दे आर वेरी इरेगुलर, पता नहीं कब क्रिएट होगी, ये फ्रंटल सिस्टम कोई आता आता पता नहीं है समथिंग, एंड दिस ट्रॉपिकल इट इज सीजनल। सीजनल मतलब हमें पता है कि चलो अब समर सीजन है ना, तो हमारा पैसिफिक ओशन हीट होने वाली है, तो यहाँ पे लो प्रेशर क्रिएट होगी, शायद साइक्लोन भी क्रिएट हो सकती है, हमारे ऊपर साइक्लोन भी आ सकती है, सो दे आर सीजनल एंड दे हैपन ड्यूरिंग लेट समर, सो दैट्स व्हाट आई कैन से अबाउट ट्रॉपिकल। एंड एक्स्ट्रा ट्रॉपिकल आई एम सेइंग इट एज इन्वर्टेड वी शेप, एंड ट्रॉपिकल आई एम कॉलिंग इट एज वी शेप। सी सिंपल ना, इट इज ड्यू टू क्लियर फ्रंटल सिस्टम। नाउ टेल मी, दिस इज कोल्ड एयर मीटिंग वार्म एयर, दिस इज वार्म एयर मीटिंग कोल्ड एयर, एंड फाइनली वार्म एयर ऊपर जाएगी, कोल्ड एयर जाएगी, एंड ये क्या आएगी, यहाँ पे एक लो प्रेशर एरिया क्रिएट होगी, लो प्रेशर इंप्लाइज फाइनली इट इज हॉट, एंड यहाँ पे क्या होगी, कन्वेक्शन होगी एंड प्रेसिपिटेशन हो जाएगी, लेकिन द शेप दैट यू आर सीइंग हियर ना, दैट इज इन्वर्टेड वी, so that's why I am calling it as inverted V. But tropical it is simple, ये low pressure है directly, यहाँ पे we can see the water converging from here, from the high pressure area, and finally it is raising like this, so we can directly see a V here, so that is why I am calling, that is why I am calling tropical cyclones as V shape, okay, V shape, elliptical, semicircular or circular, and extra tropical they affect larger areas, extra tropical cyclones they affect larger areas, but tropical cyclones they affect lesser areas. सी वाई एम सेइंग एक्स्ट्रा ट्रॉपिकल इट अफेक्ट्स लार्जर एरिया, अरे जेट स्ट्रीम्स कहाँ पर है, ये पूरा सारा रीजन जेट स्ट्रीम्स ही है ना ऊपर, सो इट विल डेफिनेटली अफेक्ट लार्जर एरियाज, गॉट इट, बट ट्रॉपिकल इट इज अफेक्टिंग स्मॉलर एरियाज। फॉर एग्जांपल सी आफ्टर टाइम साइक्लोन इट विल डिमिनिश, राइट, सो समवेयर नियर द पैसिफिक ओशन इट ओरिजिनेटेड, यहाँ तक आते आते ही इसका पूरा एनर्जी खत्म हो जाएगी, एंड लेट्स से इट रीच लैंड आल्सो, हियर आल्सो इट केम, बट it is having a frictional resistance from buildings, trees, etc. तो ये खत्म हो ही जाएगी, so that is affecting lesser area because वहाँ पे disturbances है, but if you see extra tropical they are happening somewhere in the atmosphere that is 10 kilometer above the earth ना, so extra tropical they are affecting larger areas, but tropical they are affecting lesser areas, and the direction if you ask extra tropical they are westerlies in nature, okay, tropical see imagine our earth ना, so direction जब भी पूछेंगे ये diagram draw करना, equatorial low pressure, subtropical high pressure, temperate low pressure belt, right, now where are you seeing, you are observing in the tropical, so this and this area you are having easterlies, right, that is why I am saying that tropical cyclones we get to see easterlies, and what about the extra tropical, as I said it is here, it is in the subtropical and temperate, right, यहाँ पे हम क्या देखा, इस एरिया पे हमने यूजुअली वेस्टर्लीज देखा है ना, सो एक्स्ट्रा ट्रॉपिकल्स आर वेस्टर्लीज इन नेचर बिकॉज दे आर ओरिजिनेटिंग फ्रॉम वेस्ट एंड मूविंग टुवर्ड्स ईस्ट, दैट इज एक्स्ट्रा ट्रॉपिकल एंड ट्रॉपिकल। नाउ क्वेश्चन वाज दैट स्पीड किसके ऊपर ज्यादा होगी, एक्स्ट्रा ट्रॉपिकल और ट्रॉपिकल, तो जनरल सिनेरियो पीपल विल थिंक इट इज एक्स्ट्रा ट्रॉपिकल क्योंकि ये जेट स्ट्रीम है, जेट है, लेकिन नहीं, रिमेंबर दैट ट्रॉपिकल साइक्लोन्स आर हैविंग मोर स्पीड है तो जल्दी मरेगी, सो दैट्स व्हाई आई एम टेलिंग ना, okay, tropical cyclones they are having more speed, see tropical cyclones they are having more speed because they are getting the heat, speed, energy का formula क्या है, half mv square kinetic energy, right, that is equal to latent energy, so latent energy is going to create the kinetic energy, और latent energy extra tropical के लिए है, tropical के लिए ज़्यादा है, tropical के लिए ज़्यादा है क्योंकि सन बहुत देर से गर्म किया और वाटर का स्पेसिफिक हीट भी बहुत ज़्यादा है, फाइनली गर्म करके करके एक पॉइंट पे आ गया कि बहुत गर्म हो गया, बट इट देन सो वाटर को हीट करने बहुत टाइम लगती है, फाइनली दैट हीट इट इज ऑब्जर्व्ड बाय द वाटर एंड दैट latent energy it got converted into kinetic energy, and that kinetic energy became half mv square, implies the velocity is high, right now the velocity it is very high for the tropical cyclones, got it, so that's the difference between extra tropical cyclones and tropical cyclones, and you need to know difference between thunderstorm and tornado also. Thunderstorm is nothing but when intense convection happens, see when intense convection happens na, here you are going to get clouds, cumulonimbus clouds create, that these cumulonimbus clouds they are going to generate lightning, now these cumulonimbus clouds they are going to generate lightning, right, and clouds, they are having temperature of around 0 degrees Celsius, right? They are going to create hailstorms. So thunderstorm क्या है? Intense lightning created by the cumulonimbus clouds. That's all. So हम जो sound सुनते हैं ना, cumulonimbus clouds, that is just a sound, thunderstorm. बस. And hailstorms. Next is hailstorm. Hailstorm is nothing but if clouds their temperature is 0 degrees Celsius, they start producing hail. So that's what we call it as hailstorm. Tornado का मतलब है कि ये thunderstorm सिर्फ sound generate किया, light generate किया. See, basically I'll tell you, people get to confuse between these three. Light and मतलब light spark create होना. अगर उस spark के ऊपर हम एक sound ऐड करते हैं, वो thunder बन जाएगी. Okay, thunderstorm ये है कि cumulonimbus clouds जब create होती है, वो thunderstorm create करती है. And tornado का मतलब होता है कि this thunderstorm ना, this lightning and spark along with sound, if that trunk of spiraling wind from that intense cumulonimbus cloud, if it finally hits the earth, that is called as tornado. Trunk of spiraling wind hitting with the force and destroying the earth is called tornado. So remember God Indra. So if a God Indra want to punish someone, he will launch a tornado on you. Got it? So intense thunderstorm, or else remember the trunk of spiraling wind coming at a force and hitting the earth and destroying it. Usually it happens in the middle latitudes. हमारे इंडिया के अंदर नहीं होती है. It happens usually in the middle latitudes. Got it? We are in the subtropical. Now I am talking about temperature, that is around 66 kind of degree या फिर 40 डिग्री के नॉर्थ, यहाँ पे भी हम देख सकते हैं क्या टॉर्नेडोस देख सकते हैं. But if the tornadoes, if they are hitting over the sea, we call them as water spouts. Got it? If tornadoes hit over the sea, we call them as water spouts, and normally we call them as tornado. Got it? I think you are clear, and you are also clear about hailstorm. See, thunderstorm is different from hailstorm. If the clouds, if they are having 0 degrees Celsius, they provide a precipitation which is hail. That is hailstorm. Now, water in the atmosphere. Discuss the topic water in atmosphere. Before discussing this, you need to know what is water cycle. Okay. Now, as you can see, from oceans, water evaporate and there will be air mass movement. And after a period of time, they condense on the dust particles, forming clouds. After a period of time, they again precipitate and lead to surface runoff on the earth. And slowly, they even infiltrate into the ground. And there you can see groundwater movement. So this is how water cycle happens in nutshell. Now let us see each stage of the water cycle: evaporation and how condensation happens, precipitation, etc. First, evaporation. Okay. What is evaporation? Evaporation is the process of change of water into water vapor. That's all. Process of change of water into water vapor is called evaporation. And what are the factors that evaporation depends on? It depends upon temperature, because as temperature increase, evaporation increase. Therefore, it is directly proportional. Evaporation also depends on surface area. Surface area increase, evaporation increase. And wind speed. Wind speed, for example, let's take this as our surface water. Okay. If speed of the wind is high, then the evaporation will be high, right? That is the reason why you get to see more humidity near the oceans. Why? Because there is also this factor called wind speed, due to which water particles on the surface, they go to the atmosphere, and that is why you get to see more humidity near the ocean or coastal areas. Okay. Now, so temperature, surface area, wind speed, they are the factors to which evaporation is directly proportional. Now let us see indirectly. For example, air pressure. If the pressure of the air increase, then do you think the evaporation will be high or low? The evaporation, it will be low. Therefore, air pressure, it is inversely proportional to evaporation. We also have salinity. Let's say the water is more saline. That means it is more dense. If density increase, will evaporation increase or decrease? It will decrease. Therefore, salinity, it is inversely proportional to evaporation. Air pressure and salinity, they are inversely proportional to evaporation. What about transpiration? Transpiration is same as evaporation only. Basically, transpiration means evaporation from the plant's stomata. Okay. Plants also exhale some water vapor from their leaves, from their stomata. That is called transpiration. And if you are asking me to compare the rate of evaporation between plants and rate of evaporation on the earth, then the evaporation from the plants, that rate is higher than that of land, because what plants are doing, for the same surface water droplet that you take, the surface area, it will increase when plants are transpirating through stomata. That stomata surface area, it will increase. Therefore, the rate usually it increases for plants compared to evaporation that is happening on the land. So these are some of the factors on which evaporation is depending: temperature, surface area, wind speed, transpiration, of course, and then inversely proportional to air pressure and salinity. Now we shall see condensation. Okay. Evaporation, you know what is evaporation? Process of change of water into water vapor. Now similarly, what is condensation? Process of change of water vapor, which is in the form of clouds. Okay. Process of change of water vapor into water and also ice. Okay. Condensation can also be in the liquid form, or it can also be in the solid form. Okay. How does a condensation usually happen? It usually happens when moist warm air, it comes in contact with cool air. Okay. Of course, that is the reason why this air is getting certain catalyst to become into water or ice again, because it needs to react with something. ये water vapor हवा में क्यों है? क्योंकि इसका temperature ज़्यादा है. But if it is reacting with cool air, then automatically it will lead to condensation, and it will precipitate either in the form of water or in the form of ice. Okay. Now let us see various forms of condensation. The first form is dew. Okay. And the second is frost. Dew and frost, they are almost similar only. First, I'll tell you what is dew. When air moisture, it reacts with a cool surface, the water droplets are formed. For example, you can find some water droplets on the bottle, on your water bottle. Why? Because the water vapor, warm water vapor in the atmosphere, it reacted with your cool surface, and therefore it condensed on your surface. That is about dew. Okay. Basically, if water droplets are forming when warm moist air, it's reacting with cool surface. When water droplets are forming, then that is called dew. Remember, since water droplets are forming, we say that its temperature, the temperature of dew point, it is greater than freezing point. Okay. But if temperature of dew point, if it is less than freezing point, then water droplets will be formed. Water droplets will not be formed if temperature of dew point less than 0 degrees. Ice crystals will be formed. That is called frozen dew. Frozen dew is sometimes also called as frost. So that's the difference between dew and frost. Here water droplets are formed. Here frozen dew or ice crystals they are formed. They are also called frost. Okay. Now let us see what are the conditions for the formation of dew. First, the sky must be clear. If there are dust particles in the sky, then the particles will, I mean, the warm air, it will cool down on these particles only, and it will lead to formation of clouds, and that process will be different. It will lead to precipitation. But if you want dew formation on the surface, then of course the sky must be clear, right? So first thing is that sky must be clear. Okay, and next calm air. Why calm air must be there? See, if dust particles, if they are reacting with that wind, of course they will not be forming any water droplets on the surface. So the water droplets will fly away with the wind, right? Therefore, the air must be very calm for the dew to happen. Okay. And the next one is relatively high humidity. Of course, humidity must be high. If humidity is not high, then how can they react with the cool surface and form water droplets on the surface? It's not possible. And next, night time, it must be very long night, of course. I mean, I'm combining them both together, and I'm just saying that if it is a long night, then the sky might have been more clear, and you might have found some calm air. That's why I said long night. That's all. Not a necessary condition. I mean, okay, fine, good condition. Radiative cooling. Radiative cooling in the sense, now let's say our ground is very cool. If ground is very cool, then that means that a lot of heat might have been lost through radiation, terrestrial radiation, right? Since the dew point is less than freezing, water droplets will be formed on this ground surface. Because ground is cool, therefore the water droplets will be formed on this ground surface, and the heat will be lost in the form of terrestrial radiation. That is about radiative cooling. And next, let us see grass, leaves. Okay, grass and leaves. Grass and leaves, they must be cool. They are actually cool. They are cooler than paved concrete surfaces that we see. Therefore, you generally find that dew water droplets they are formed on the grasses and leaves, okay, on the vegetative surface rather than the paved surfaces, because they get cooler faster than paved surfaces. That is about dew. As we have seen the conditions for dew, let us now discuss fog. Fog is nothing but ground level cloud. Okay, see, you have seen dew and frost, they are completely different, and fog is completely different. For example, let's say this is me and I'm seeing some far distant object. Now to see that far distant object, the air must be clean, then only I can see. But if it is a fog, I can see only up to 1 kilometer. So this is the worst. I mean, after 1 kilometer, it is difficult to see because there is a lot of dust condensed into the atmosphere. Therefore, my visibility range will be only up to 1 kilometer. But what is mist? Mist is relatively less denser than fog. Therefore, my visibility range lies somewhere between 1 kilometer to 2 kilometer. And we have haze. The visibility for haze lies between 2 kilometer to 5 kilometer. So these are about fog, mist, and haze. Basically, they are just ground level clouds, and the visibility range changes for fog, mist, and haze. Haze is relatively lesser denser than fog and mist. Okay, the visibility range, just remember 1, 2, and 5. You know 5 cube. Since we are discussing about three things, just remember it as 5 cube, 125. Therefore, I'll write 1, 2, and 5 here, 125. And then I will say that fog visibility range is 1 kilometer, mist visibility range is 2 kilometer, and haze visibility range is 5 kilometers. Basically, fog happens when warm moist air reacts on the surface of cold dust particles. Okay, that dust particles they are providing surface for the formation of fog. Okay, and the types of fog there are radiation, advection, and precipitation. Radiation fog in the sense, for example, since the surface is cool, we have seen that warm moist air it reacts with the cold surfaces, and then that will lead to formation of fog and release of the terrestrial radiation from the earth. That is ground level fog. Okay, there you are seeing warm air closer to the ground. Now let's say warm moist air it is going in the horizontal direction. That warm moist air it is going in horizontal direction and the surface is cool. Over a period of time, as the warm air moves uh, in the horizontal direction, it will slowly condense on the dust particles present in the air because the surface is cool. Then such kind of fog is called advection fog. Okay. Similarly, we have precipitation fog. Precipitation fog is formed due to frontal conflicts. I mean, see, for example, when warm moist air it reacts with a cold air, rather than using this word react, it feels like chemistry. Use the word meets. Okay, better. So when warm moist air meets cold air, it will create warm front, right? Over a period of time, what's going to happen is that the warm water vapor it raises and lead to a formation of fog because there are dust particles, right? So the warm moisture it automatically condenses on the cold dust particles that are there in this side. Okay, this is warm moisture, and let's say they are cold dust particle. They raise into the atmosphere and they create precipitation fogs or frontal fogs. Okay, what are the impacts of fog? First impact that you know is visibility will reduce. The other thing would be crop yield. Okay, you might wonder why crop yield will reduce. See, if dust particles, if they are creating the base for the formation of clouds, that means they are not precipitating because they are taking the water that actually needs to be formed on the ground. Therefore, the crop yield it will reduce, especially to the late sowing crops. Okay, that means that on the right time, at the right time, you are not going to have the right amount of precipitation. Okay, that is the implication of it. So crop yield will reduce. Now we have discussed about crop yield. Now let us see tea and coffee yield. See, crop yield will definitely decline, but what about tea and coffee yield? It will increase. Why? Because tea and coffee, these crops require dim sunlight. So due to fog formation, there will be no scorching sunlight, and that will increase the tea and coffee yield. Okay, general crop yield it will reduce, but tea and coffee yield will increase during the fog, and then visibility will decline. That we know. Human health issues will also be there. For example, lot of fog is in the atmosphere. The dust particles they are not going into upper air. Therefore, what is going to happen? We are going to breathe the air which is having lot of dust particles, and that will lead to human health problems. As we have studied the impacts of fog, now let us see different types of terms that you need to know in this chapter. First is latent heat. So when water changes into water vapor, a certain amount of heat is required. Then only water can change into water vapor. So the absorbed heat in this process is called latent heat of evaporation. So the heat required for the water to convert into water vapor is called evaporation. Similarly, if water vapor need to be converted back into water, then certain heat must be released into atmosphere. So that released heat is called latent heat of condensation. Now you understood when is latent heat required and when is latent heat released. Okay, if latent heat is observed for formation of water vapor, then it's called latent heat of evaporation. If latent heat is released, then it is called latent heat of condensation. What is saturated air? See, our atmosphere definitely has some water particles, right? But if the water particles are so high that after this there cannot be further more water particles in it, then that stage of air is said to be saturated air. Basically, saturated air, it happens when the amount of water vapor in the air matches its capacity to hold water at a specific temperature. Then such air is called as saturated air. This means air can't absorb any more water vapor at that temperature. Okay, that is air reached 100% humidity. Okay, that is called saturated air. Air reaching 100% humidity. What is hygroscopic nuclei? The dust particles which are attracting water vapor, they are called hygroscopic nuclei. I mean, see, they are cold. That is why warm water vapor particles they are getting attracted. So these dust particles which are attracting the water vapor, they are called hygroscopic nuclei. They are also called as particles which are having high affinity for water vapor. They can be dust, salt particles, or even pollutants. What is dew point? As you have already studied about dew, you know this. Dew point is temperature at which air equal to saturated, beyond which air might get converted into air droplets, or they can be converted into frost also. Frost is also kind of precipitation. So dew point is temperature at which air becomes saturated. Temperature at which air becomes saturated is called dew point. Now let us study about the four types of cloud. Okay. What is the cloud? Cloud is mass of minute water droplets or ice crystals formed when water vapor condenses at elevated heights. See, if water vapor condenses in the troposphere or somewhere in the troposphere, then we call it as fog or something name. We give it some different name. But if water vapor, if it condenses at elevated heights, then it is called cloud. Clouds are nothing but mass of minute water droplets. Mass implies bulk. Minute implies small. So the definition is saying that mass of minute water droplets or ice crystals formed when water vapor condenses at elevated heights. So there are mainly four types of clouds that you need to know. Just remember these elevations. One is 1.5, 4, 8, 12. You can easily remember 4, 8, 12, 4 table. Just remember this 1.5 kilometers. So the stratus clouds, also called as layer clouds, and the nimbus clouds, they are formed at elevation of 1.5 kilometers from the ground level. And we have 4 kilometers and 8 kilometers. So between 4 to some 7 to 8 kilometers, cumulus clouds are formed. Cumulus clouds are basically they look like cotton wool or cauliflower flat based clouds. Okay, they are cumulus clouds. They are formed somewhere between 4 to 8 kilometers. The NCRT actually said 7 kilometers, but for my remembrance for the 4 table, I put it as 4, 8, 12. Okay, and then cirrus clouds, they are detached fibrous feathery white clouds which are formed between 8 to 12 kilometers above the ground level. So at 1.5 kilometer stratus clouds or layered clouds, and rain bearing clouds which are dense and opaque to sunrise, these are rain bearing clouds. Both of them they are formed at 1.5 kilometers. And cirrus clouds which look like cotton wool patches or cauliflowers with flat base, they are formed between 4 to 8 kilometers. And we have cirrus clouds somewhere between 8 to 12 kilometers which look very feathery, fibrous, detached, etc. So they are cirrus clouds. Stratus and nimbus at 1.5, cumulus between 4 to 8, and then cirrus clouds from 8 to 12. There are four families of clouds that you need to remember: high clouds, middle clouds, and low clouds. The fourth is clouds with extreme vertical development. So you remember cirro, right? They are high level clouds. Just add strato and cumulo form. Do you know what is strato? This, and cumulo is this. So when you add, they are the major forms. Okay, when you add this form to the cirro, it will become high cloud. Okay, cirrus, cirrostratus, and cirrocumulus, they are high clouds. Similarly, these two forms, when they are added to alto, then they will become middle clouds: alto stratus and alto cumulus. You need to remember this alto for middle clouds. Okay, the next is low cloud. Strato is a low cloud, right? So you cannot add strato. So you can add cumulo. So it will become stratocumulus. Next you have nimbo cloud. Nimbus is also low level. Strato is also low level. So for strato, I cannot add strato. Therefore, I added cumulo. So it is stratocumulus. The second is nimbo. For nimbo, I added stratus. Okay. There is no nimbo cumulus, but we have cumulo nimbus. That means the upper part, higher elevation, it is connecting to nimbus, or it is connecting up to this much. If it is connecting up to this much, that means it is not connecting. Therefore, it is cumulus. But if it is connecting to nimbus, then it is cumulonimbus. That's all. So you have cumulus and cumulonimbus, but you don't have this. You don't have this, but you have this. Okay, that means you have cumulonimbus, but you don't have nimbocumulus. So the four families: cirro, cirrostratus, and stratocumulus; alto stratus and altocumulus. The ground level you have strato and nimbo, stratocumulus and nimbostratus, cumulus and cumulonimbus. Okay, these are the four families. Now let us see what's cloud seeding. we have studied about clouds, but do you know any technique which can help in the formation of cloud? Yes, there is a technique which is called cloud seeding. Basically, you are throwing some seeds in the atmosphere and they're creating clouds. So cloud seeding refers to a technique of introduction of substances to manipulate clouds to alter their micro-physical properties. That is called cloud seeding. Cloud seeding refers to the technique. Cloud seeding refers to the technique of introduction of substances to manipulate clouds to alter their micro-physical properties to influence the weather patterns. Okay. Now, what are the cloud seeds that you know? One is silver iodide, which is also called dry ice, that will create precipitation. This is very famous. And then you have salt. You can add salt, it will create solid precipitation, also called hail. The next is different kind of salt, not only NaCl but also CaCl to urea. They are also used to clear fog in the atmosphere. Okay, these are the different uh, cloud seeds that you need to know. And now let us see what is precipitation. Okay. Now we have seen condensation. The first you have studied about evaporation and then condensation. You studied about clouds. Now you need to know about precipitation. Precipitation is release of water vapor back to earth in the form of water, or it is also defined as release of moisture into the earth's surface after the condensation. This is the formation of condensation. So release of moisture to the earth's surface after condensation is called precipitation. Now what are the various forms of precipitation that can happen? It can be in the form of drizzle. Drizzle, its diameter is 0.5. Its diameter is less than 0.5 mm. If the diameter of water droplet is less than 0.5 mm, definitely they are chota particles. If that such particles are there in the atmosphere, then you cannot see properly. So visibility will reduce. Drizzle, the diameter is less than 0.5 mm. What about rain droplets? Rain droplets, they have diameter greater than 0.5 mm. Drizzle less than 0.5 and rain greater than 0.5 mm. Now what about snow? Precipitation can also happen in the form of snow when there is sublimation. Sublimation is nothing but conversion of water vapor into solid without involving liquid stage. बादलों से सीधा solid गिर रही है. That means what is it? It is sublimation. Process of conversion of water vapor into solid without involving liquid. See, solid, liquid, gas, you know the three stages, right? If gas is converting into solid without even involving liquid, then such process is called sublimation. Okay. Sublimation can happen in the form of ice crystals, small pellets, or flakes. Now, let's see what is sleet. Sleet is created when rain, before falling on earth, passes through cold layer of air and freezes. Okay, see, this is cold layer of air, and the rain is falling. Before even reaching the earth, they are reacting with this cold layer of air, and they are forming small pellets here. Okay, and they are freezing there only. Chota chota pellets. These pellets they might fall on the ground, or they might even condense there only in the atmosphere and later fall on the ground. Anything can happen. So that is sleet. Okay, precipitation can also happen in the form of sleet. Basically, when rain droplets, when they're falling on the ground, they react with the cold layer of air, and before even reaching the ground, they freeze. They freeze, and then small pellets fall on the ground. Those small pellets that are precipitating on the ground are called sleet. And next we have hail. Hail. See, the diameter of hail is very large compared to whatever you are seeing in the drizzle, rain, snow or sleet. Hail, इसको hail इसलिए बोलते हैं क्योंकि इसका diameter इतना ज़्यादा है. It is somewhere between 5 to 50 mm. Okay, this is 5.5 mm. This is 5 mm. So minimum here 5 mm है और maximum it is 50 mm. So they are basically small balls or pieces of ice that are falling on the ground. And do you know what? Hail formation सबसे ज़्यादा summer में होगी, not in winter. Something that people might mark it wrong. लोग यही सोचेंगे कि winter में ज़्यादा होगा snowball, summer में ज़्यादा क्यों होगा? That is what people will think, ना? But hail formation is more in summer compared to winter. The reason is very simple because see, summer में गर्मी ज़्यादा है, so lot of water vapor will be released. Lot of water vapor will evaporate and it will go to upper atmospheric layer, and there what's going to happen? It is going to condense at the freezing temperature. upper air में temperature बहुत कम है ना, तो उस temperature में ये freeze हो जाएगी. Okay, there the water droplets they are freezing. So water droplets they freeze here, and then those snowballs or whatever, they are falling on the earth. Okay, sometimes we also call it as Ralla Varsham in Telugu. That means stones are falling from the atmosphere. So that happens typically in the summer, not in the winter, because there is unstable air in the summer. There is a lot of unstable air and also a lot of temperature. That is the reason why hails are more prevailing in the summer rather than winter. You know Vadadebba in Telugu? That is something like strong winds. So Vadadebba you get to see in summer, not in winter. Okay, they are the reason for the formation of hails, because these unstable winds they are even helping the water vapor to further carry upward. Okay, okay, great. But there is a certain condition for hail to be developed. What is the condition? See, the base of the cloud, its temperature must be below freezing point, below 0 degrees Celsius. Let's say that temperature is T. But the upper layer, it must have very lesser than T. Let's say if it is T, the upper layer is T1, the T1, it must be lesser than T. Then in such scenario, cloud will be formed. अगर इसका 0 है, तो इसका होना चाहिए -2. तभी हेल का फॉर्मेशन होगी. मान लेना कि ये आइस है. अब ये भी आइस जैसे है, थोड़ा स्नो है. ओके, सो दे आर snowballs or pieces of ice which are called hail. Okay, this is the condition how cloud must be there. You have seen drizzle and rain, you have seen snow, and then sleet where there is cold layer of air, and then you have seen hail 5 to 50 mm dia prevailing in the summer, and the fifth precipitation is varga. Okay, what is varga? Varga, it is formed when the relative humidity of air below a precipitation cloud is relatively low. For example, there is a cloud, okay, and there is air here, and then the air will have some relative humidity, right? This cloud is also going to have some relative humidity. If the relative humidity of air is यहाँ पे humidity नहीं है, if the relative humidity of air is less than the humidity of the cloud, then definitely cloud is having lot of humidity. Therefore, इसका humidity ज़्यादा है तो वो precipitate होगा ही ना, so it will precipitate, right? So when that happens, what is going to happen, you know, before even reaching the ground, they might even evaporate, or else just as they reach the ground, they just evaporate. They are not forming just because they need to precipitate. They are forming क्योंकि यहाँ पे इतना वजन नहीं है नीचे एयर में. The air below the cloud, it is having lesser relative humidity compared to relative humidity of the cloud. That is why it is getting precipitated. But इस ये precipitate नहीं होना चाहती है. That's why it will again evaporate back to ये atmosphere. Why? Because its temperature is high only. Therefore they can stay as water vapor in the atmosphere. But the thing is that they are getting condensed क्योंकि नीचे इस cloud के नीचे जो air है इसका relative humidity comparatively less है compared to the cloud base. The relative humidity of air below the cloud is less. And that is why the precipitation before even reaching the ground, it is getting evaporated, or once they reach the ground, they're just getting evaporated within a second. Okay, precipitation, they can be classified into different types based upon the origin. For example, let's say this there is a lot of sunlight here, and due to a lot of insolation this became warm, therefore it will create a low pressure. When low pressure is created, water, it is going to converge from high pressure areas to low pressure area, and that water, it is going to finally rise, right? When it rises, it will create some cumulonimbus clouds, and that is going to ultimately create precipitation. That is called convectional precipitation. Just when low pressure water is rising from a low pressure area, and it is creating cumulonimbus cloud after reaching its water capacity, it will precipitate, right? That is convection rainfall. Orographic rainfall, that is over the mountain. See, for any mountain, you are going to have a windward and a leeward. Leeward is nothing but rain shadow side. Let's take India. India, if you see these Western Ghats, this side it is what it is windward, and the other side, if you see, it is rain shadow. So that's how it works. When the monsoon wind comes, they fall on the windward mountains, right? Windward side of the mountains, not on the leeward side. Okay. Orographic, it is over the ocean. Basically, what's going to happen? Wind, they are traveling normally, लेकिन एक माउंटेन बीच में आ गया, तो अब ये स्ट्राइट लाइन पे नहीं जा सकती है, तो उसको ऊपर जाना पड़ेगा. तो ये ऊपर जाएगी, मुझे नहीं पता ये क्या होगी, लेकिन ये ऊपर जाएगी, ऊपर जाएगी, लेकिन ऊपर जाने के बाद एक पॉइंट आएगी जहाँ पे टेम्परेचर लो है. सी माउंटेन्स, यू नो, as with altitude, so the temperature is going to drop. So when you go here, the temperature, it will decrease. But this is a warm air and it is meeting cool air. So what happens when water molecules meet with a cold air? There is going to be a condensation, right? So condensation is going to happen here. लेकिन एक पॉइंट होगी जब ये कंडेंसेशन वाटर वेपर वाटर कैपेसिटी को रीच होगी, तब ये बारिश बरसेगी यहाँ पे. दैट इज ओरोग्राफिक प्रेसिपिटेशन. Got it? Some people will think that here temperature will be high because there is sun, that we have discussed in the mountain and valley concept. But remember, mountain and valley concept, we are discussing it because we are comparing it with a valley, not in a general scenario. In general scenario, you will always tell that if you are comparing this and this, you will always tell that यहाँ पे temperature कम होगी, यहाँ पे temperature ज़्यादा होगी, and altitude के साथ temperature घटेगी. See, that is the difference when you do with the valley and when you do in normal scenario. People think geography is easy, everything seems easy, but you need to note down the subtle differences. For example, this is mountain and valley, and this is mountain. For mountain and valley, you are going to just plot the sun, and you are going to say this is high pressure and this is low pressure during daytime. This is low pressure and this is high pressure during daytime. Sun है तो ये low pressure है, तो breeze कहाँ से होगी? Is the diagram not good? I'll draw again. See, let's take this as mountain and let's take this as a valley. Oh, got it? Now when you are considering a mountain valley scenario, you are going to consider sun, and with respect to valley, you are saying temperature is high, and here this is going to create low pressure. Temperature is high implies low pressure. Got it? And here it is a high pressure. Therefore, during daytime, you are getting to see valley breeze. But in general scenario, if you think, you are going to say temperature is actually low here because you are at the top altitude. Got it? So general scenario में consider करना. अब मैं जो भी बता रही हूँ, here the temperature is low, therefore the condensation is going to happen and it will finally lead to precipitation. Got it? And you are having cyclonic precipitation. That means cyclones के बारे में अब तक क्या पढ़ा है हमने? हाई प्रेशर से वाटर इकट्ठा होगी लो प्रेशर एरिया पे, and at the low pressure area, the water is going to converge and rise in the eye walls, and finally after a point, they are going to form cumulonimbus clouds, and when water equals to water capacity, it will finally lead to precipitation. That is cyclonic precipitation. Finally, we have frontal precipitation. Frontal is when warm moist air meets cold air. What's going to happen? A warm front is going to create, and what's going to happen? The water is going to converge and rise, and these are the clouds which will lead to precipitation, right? That is frontal precipitation. That's all. These are the four types of precipitation. These are the four types of precipitation: convectional, just a normal precipitation; orographic, over the mountain, over the mountain, over the mountain; orographic, cyclonic, over the cyclone. Okay, and then frontal. By seeing the name only, you can guess. Now, if you need to understand the world distribution of precipitation, you need to draw some lines to understand. Okay, what are the lines? What are the areas which are having same precipitation? Such kind of lines are called isoheights. Isoheights. Okay. Isoheights, they are lines connecting same amount of rainfall. Now, if they are connecting less than 50 centimeter rainfall, then such rainfalls are called scanty rainfall. And if it is somewhere between 50 to 100, it is low rainfall. 100 to 200, it's moderate, and heavy rainfall more than 200. Just I multiplied 50 with 2 as I move upward. Okay, they are the different isoheights. So where do you get to see scanty rainfall? Somewhere on the leeward side of the mountain range. For example, you have seen this is orographic rainfall. It happens on the windward side. This is leeward. तो यहाँ पे rainfall नहीं होगी. That is why leeward side is famous. So scanty rainfall happens in the leeward side of mountains or even in the desert areas. Okay, very less than 50 centimeter. Now, if it is more than 50 but less than 100, then that might be somewhere in the tropical or temperate areas or wherever it is. They can be central part of tropical islands because see, the central part it is mostly landlocked. तो वहाँ पे कम बारिश होगी ना comparatively. So central part of tropical islands or somewhere in the temperate lands you can find the low rainfalls. And if it is moderate rainfall, moderate 100 to 200 का मतलब that must be some warm temperate zone. Warm तो होगी तभी तो humidity है, तभी तो 100 से ज़्यादा है. And it might be somewhere in the temperate, क्योंकि there you get to see some winds also. So moderate rainfall will be in the warm temperate zone, and heavy rainfall, if you are asking, it is in the equatorial belt, and also where there are mountains and western coast mainly. Okay, not all the western coasts of mainly temperate zones. Okay, for example, if you see temperate zone, let's say Europe, is side both seas है ना, and you get westerlies also, winds coming from west, that will create some rainfall, right? That rainfall can be more than 200 centimeter. एंड सिमिलरली इक्वेटोरियल बेल्ट, वाई इक्वेटोरियल बेल्ट, क्योंकि वहाँ पे ना मोस्टली ओशियनिक सर्फेस बहुत ज़्यादा है इक्वेटोरियल बेल्ट में. दैट्स वाई इवन इन द वेस्टर्न कोस्ट ऑफ टेम्परेट जोन देयर आर आल्सो लॉट ऑफ सीज एंड ओशंस. Therefore I'm saying equatorial belt and western coast of temperate zone as the main focus area for heavy rainfalls. Okay, now you know scanty rainfall less than 50 centimeters, leeward side of mountain or desert. Low rainfalls 50 to 100, they usually occur in the temperate lands or somewhere in the central part of tropical island. And moderate rainfall warm temperate zones, 100 to 200, and heavy rainfall more than 200, equatorial belt or western coast of western coast of temperate areas. Thank you. Now let us see next chapter. Starting the topic of climatology, let us see the Köppen scheme of climate classification. We have A. A stands for tropic humid. B. Subtropic humid. C is warm temperate climate, and D is cold temperate climate. E is cold polar, and H is highland. So as you can see, A and B, they are little bit hot, and C and D, it is transitioning from warm to cold. Okay, warm temperate to cold temperate, and E, it is completely polar, and H is highland. Okay. So in the warm temperate, if you see the winter temperature, it lies less than 18 degrees Celsius, but more than minus 3 degrees Celsius. But if you observe D, the cold temperate, which usually be like a cold snow forest climate, this cold snow forest climate in the winter, its temperature will be less than 10 degrees Celsius. So this is how the climate groups are classified. And these climate groups, they are having again sub-letter codes. Like for example, if you see the climate group code, they are having letters, sub-letters. So you need to know the meaning of them. For example, yes, small s stands for summer dry, small w, winter dry, m, monsoon, rainfall throughout the year. It is also called as wet climate, and you have frost or frigid climate, T for tundra. Okay, don't confuse with the capital S and capital W. Okay, if it is small s and small w, then they are summer dry and winter dry. But if they are capital S and capital W, the meaning changes. What is the meaning? It is semi-arid or steppe. S stands for semi-arid or steppe, and W stands for arid or desert. Semi-arid or steppe are the regions that are being transitioned into desert. Okay, that is a semi-arid or steppe, and W is arid or desert. And now you have FA. FA is summer warm. Okay, so when you see the alphabet code F, don't think that it is rainfall throughout the year when it is added with a small letter A or small letter B. Okay, the meaning changes. If F is continued with some letter A or B, the code changes. It becomes summer warm if it is A, and if it is FB, then it will become summer warm and cool. Remember it like be warm and cool, not warm or not cool. Be both warm and cool. Okay, that is be warm and cool. And A is just warm. Okay, and K, just think of high. How do you think of it like a hike? Okay, hike. So K will be in the middle, and since you're starting with H will be low point, right? So that is how you can try to memorize. Okay. Yeah. So now you have understood about different alphabet codes. Now let us try to see how they are classified. As I said, A is tropic humid climate. As we have seen, A stands for tropic humid. A is tropic humid, and B is subtropic humid. Okay, subtropic dry, not humid, dry. So you need to be very careful. Why I'm telling you to be careful? Because with this word humid and dry, the entire meaning changes. For example, by seeing humid, you can say that there will be at least rainfall here in the alphabet code A. But in the B, as you can see, it is entirely dry. So whatever code classification it is there, they are mostly going to stay dry, and they're mostly going to stay humid. So there is a vast difference between A and B. A is tropic humid, and B is subtropic dry. Okay. Now A can be classified into A, F, M, W. Since it is humid, of course, it's going to have rainfall throughout the year. That code will be there. So therefore, it is F, wet. And next, humid का मतलब rainfall भी हो सकता है या फिर monsoon की वजह से भी हो सकता है. What is monsoon? Monsoon is nothing but seasonal reversal of wind. Okay. Write it here only. Monsoon is nothing but seasonal reversal of wind. So when they give you a characteristic called seasonal reversal of wind, just remember that they are talking about monsoon only. So basically, in the tropical monsoon, you are going to see seasonal reversal of wind. So if they are saying rainfall throughout the year or seasonal reversal of wind, take a guess that they are talking about tropical humid climate. It can be AF or AM. And next is AW. AW is tropical wet and dry. Wet है और dry भी है. Can you remember an ice cube? Ice cube, it is wet, but at the same time it feels dry also. So that is a tropical wet and dry. Basically, they are referring to winter dry season. Okay. And if it is rainfall throughout the year in the AF, it means there is no dry season here. No dry season. And if they are talking about our monsoon, then of course there can be a short dry season because it is monsoonal. That is seasonal reversal of wind is there. Okay, that is about tropical humid. Now let us see subtropic dry. Dry can be in low latitude or middle latitude, not high. Not in the high latitude. High latitude का मतलब क्या होगा? That can be in the temperate or some polar. So we can only classify them into two sub. One is low and the other is middle. And low can be again further classified into semi-arid, that is steppe, and arid, that is dry. Similarly, mid latitude can be classified into semi-arid, and this is arid. Okay, they are the two classifications. S and we also have FA, FB. What is the difference? See, S stands for summer dry and FA stands for summer warm and FB stands for summer warm and cool. All three are summer, but this pure S, it is just dry. But if you are adding some wetness into it, that will become summer warm. And if you are adding code B, it is summer warm and cool. Okay, that is the difference. Now you have seen A and B. Now you need to see C and D, right? A, let us try to revise. A is tropic, B is subtropic, and C is temperate. C and D both are temperate, but C is warm temperate and D is cold temperate. Okay, these are the letter codes. And A is not just tropic, it is tropic humid, and subtropic, it is not normal subtropic, it is dry subtropic. Okay, humidity को हम कैसे classify कर सकते हैं? Humidity we can classify them into full rainfall or monsoonal or winter dry. Okay, and subtropic they can be classified into again three, not three, four. Okay, low latitude and mid latitude. Low latitude का मतलब क्या है? Low latitude means H. Mid latitude implies K. Okay, and next what else? You need to see whether they are semi arid or सेमी एरिड और एरिड. सेमी एरिड को एस से डिनोट करते हैं और स्टेपे को किससे डिनोट करते हैं? एस से. एंड एरिड को डब्ल्यू से. ओके, एस डब्ल्यू. सो दिस इज हाउ यू सब क्लासिफाई ड्राई. एंड व्हाट अबाउट वार्म? That I will tell you. So now C is warm temperate and D is cold temperate. Cold temperate or similar to cold snow forest. Okay, now warm temperate they can be split into S, FA and FB. Since it is warm, it is usually implied that there is some wetness in the atmosphere. That is why we denote it with F. Okay, लेकिन वार्म का मतलब ये होता है कि क्या गर्मी. अब गर्मी का रीजंस क्या हो सकता है? या वहाँ पे या फिर प्योर समर हुआ होगा और एल्स समर. Different kinds of summers can be there. And what are the three different kinds of summers that you have seen? One is yes, small s. Okay, summer dry. And the other thing that you saw, summer warm because of moisture in the atmosphere. That is FA. And the third summer that you have seen is summer warm and cool. That is FB. So these are the three codes that we have written in the warm temperate. Okay, C is warm. So warm से हमें क्या पता लग रहा है कि yes हो सकता है या फिर F या FB हो सकता है. If it is yes, then it is Mediterranean climate. Remember, if it is yes, it is a Mediterranean climate. If it is FA, then we are calling it as humid subtropical. Why? See, FA का मतलब क्या है? Summer warm. Warm का meaning humid. And what is usually very summer usually observed in the subtropic, so therefore we are calling it as humid subtropic. And what is FB? It is both warm and cool. Summer warm and cool. Where do you see both coolness and warmness? When you are near some coastal area, right? When you are near some coastal area, then even if you feel warm, you can feel cool because of the coastal climate. That is marine west coast. That happens near European west coast. Okay, marine west coast. So now you have seen warm temperate. CS one is Mediterranean, that is pure hot summer, which is a dry season. And then FA, that is just a summer warm, that can also be called as subtropic humid. And in the subtropic humid, what do you get to see? As I already said, FA stands for summer warm. That is what you get to see. And there is no dry. As the name suggests, there is no dry. And marine west coast, it is both summer, it is summer warm and cool. Okay, there also you get to see no dry climate. The warmness and coolness is because of land breeze and land breeze and sea breeze, etc. And there is no dryness observed. Only in the Mediterranean you see dry. Okay, and in FE and FB, since the name itself has EF, so you don't get to see dry. In the question, they are going to just give you humid subtropic. Immediately you need to write the letter code humid and subtropic. That means they are talking about some F. And subtropic में hot है, so they are talking about FEA. They are talking about summer warm, humid subtropic. And marine west coast, it means they are talking about FB. वहाँ पे both summer warm and cool है. Okay, if it is Mediterranean, it is complete summer. Okay, summer, complete summer dry. S. Okay, that is a S. And this S and this S, you should not be confused because this S stands for steppe and dry. S and W, they stand for steppe and dry. They are denoted with capital S. Okay. Now I said you that D is cold temperate. अब cold temperate में क्या हो सकता है? Snowfall हो सकती है. If there is snowfall, definitely there is some rainfall throughout the year, right? Snowfall throughout the year. Therefore, I will denote it like F only. And then there might not be snowfall. It can be frost. Then I will denote it as W. So see, it can be either wet or it can be dry, right? I mean, so there can be snowfall or there can be ice. So I will denote it with small w or small f. If I'm writing D with F, it will be humid continental climate. Okay, humid continental climate. D stands for humid continental and DW stands for subarctic. See, since you did not go to tundra, ice and all, DW you can remember it as subarctic, but I mean you did not enter into Arctic area, right? Therefore, remember DW as subarctic because as I said, you are seeing a dry winter. That means you are seeing frost, so that must be subarctic. That is transitioning into complete ice, but still you are seeing some frost. Okay, that is DW. And DF, there is humidity in the continent. Okay, why? Because there is snowfall. Okay, that is humid continental. That is DF and DW. Now I'm asking you, is there a dry season here? No, there is no dry season because I'm denoting it with F. But there is severe winter. Okay, because I'm denoting the code D. Code D implies severe winter. First of all, there is a severe winter. There is severe winter, but since I'm denoting it with F, that means there is no dryness. But this is letter code W. W itself means winter dry, and since I'm denoting it with a D, it means severe winter dry. Okay, that is the difference between humid continental and subarctic. Okay, now we need to see ET. E का मतलब है कि हम टुंड्रा रीजन रीच कर लिया. Okay, so that is ET. Okay, T stands for tundra. Okay, and H is polar ice. No, this is not H actually. This is F. Okay, ET, EF. this is capital F. Capital F का meaning क्या है? वहाँ पे बहुत frost है. Okay. So ET. T stands for tundra and F it is polar ice and H stands for highland. Highland with snow cover. I mean full snow. Let us try to attempt the MCQs. Which one of the following is suitable for Köppen's A type of climate? Okay, A type of climate. What are the codes that we saw? It's A, B, C, D, E, H. Right? A is tropic and B is subtropic and A is tropic humid, B is subtropic dry. Now A. So basically in the A type of climate, we get to see A type of climate is basically tropic humid, right? It will be humid and humid implies there will be full rainfall or monsoonal rainfall or else winter dry. Okay, anything it can be. Tropic humid. Anyways, let us try to evaluate the option. High rainfall in all the months. See, if it is a monsoon, then there cannot be high rainfall in all the months. So option A will be wrong. Mean monthly temperature of the coldest month more than the freezing point. They're saying that monthly temperature will be more than freezing point, mean monthly temperature, which doesn't seem to be correct. I mean, see, tropic areas, they are hot areas, okay, and you're saying they're just above freezing. Doesn't suit this definition according to me, but I will consider this as last one. Mean monthly temperature of all months more than 18. This seems to be correct because they are tropic and they are humid. There is a rainfall also, and monthly temperature of all months more than 18 degrees Celsius. Yeah, monthly temperature more than 18 degrees Celsius. This seems to be a generalized statement because of humid climate. And then subtropic, they are very hot because they are semi-arid and arid. They are very hot, and humid, they are not so hot compared to subtropic according to me. And I am thinking that more than 18 degrees Celsius temperature, this option should match. Option C. Average temperature for all months below 10 degrees Celsius. This also seems to be wrong. This will suit for temperate areas, etc. Not here. Okay, therefore C. Köppen's classification can be termed as applied system. See, they are the empirical codes. Köppen's system of classification, they are the empirical codes. Okay, most of the Indian peninsula can be grouped into which category? Okay, now Indian peninsula comes under which category? Tell me one thing. India passes through Tropic of Cancer, right? Tropic of Cancer. That means what does that imply? It implies that India is in the tropic humid. That is A wala zone. So that can be either AF or AM. Now let us see. F is rainfall throughout the year. Do we experience rainfall throughout the year? No. Then what is M? M is seasonal reversal of monsoon. That is yes, we receive monsoon winds. Therefore D. Okay. Which one of the following years is supposed to have recorded the warmest temperature the world over? This is an old NCRT question. Now, if you are asking, the warmest temperature is 2024 currently, but at that time it was 1998. Okay. Anyways, now the hottest temperature recorded is in the year 2024. Which one of the following groups of four climates represent humid condition? Try to make a guess here. They're asking humid conditions. Okay. A, we have tropic humid, and subtropic B, it is completely dry. That is subtropic dry. So we need to eliminate B for sure. This option has B. This option has B. And next, C stands for warm temperate, right? Warm implies garmi. So if there is a code yes also where that is complete dry, that is true. But there are codes F and FA, FB also, which indicates warmness. Okay. And next we have D. D stands for cold temperate. And in that cold temperate, we have seen it can be due to snowfall, which again will represent humid. So humidity is also there in the D. Okay, now in A, C, D, we have seen humidity. Now we need to analyze E and F. Let me tell you the difference between E and H. See, in E also you have ET and EH, right? ET is tundra. They are sometimes even called as cold deserts, okay? But it's not the same with EF. Okay, EF trees can also be grown here. Sometimes it is even warm. They are called as a boreal forest or something. Okay, these trees you can easily see in the EF, and when you go to polar, complete ice. So therefore, if the question is asking which one of the following represent humid condition, the answer will be A, C, D, and E. Option B. Sorry, it's not boreal, it's boreal forest. Okay. Let's discuss the topic water. I mean the oceans. Okay. Do you know what is planetary water? Planetary water, it can be oceans or they can be groundwater. Soil moisture can also be part of planetary water, and glaciers, many other which are available on the planet Earth. Okay. Out of that, 71% it is in the oceans. Now, if we see our water cycle, let's say Earth is having 100% of water. Okay. Out of whatever water that Earth is having, 59% goes in the form of evaporation. If 59% is going in the form of evaporation, then the other water would go in the form of glaciers, and some water they infiltrate into the groundwater, and some water they stream as surface runoff. So just remember two percentages. 71% of the planetary water it's oceans, and 59% it goes in the form of evaporation. If you see this world map, we have Pacific Ocean here. This is the first ocean that you need to know, and then we have Atlantic Ocean, Indian Ocean, Arctic Ocean, and Southern Ocean, which is Antarctic Ocean. Let's take this as our ocean. Okay, in this ocean, if we see if this is our sea level, then if you go 3 to 6 kilometer downward, then you can find the ocean floor. Usually, you can find ocean floor somewhere 3 to 6 kilometer below the sea level. Okay. And this ocean floor, it can be divided into two categories: major reliefs and minor reliefs. There are 4 major reliefs and 6 minor reliefs. Now let us see what are the 4 major reliefs. Okay, continental shelf, first this is the continental shelf, and then you get to see continental slope. Then next continental rise, which here abyssal plain is also part of continental rise only. Abyssal plain is also part of continental rise. And the fourth major relief is deep trenches, which are very deep. For example, you have come here and then you are seeing very deep trench which is extending 3 to 5 kilometers below the oceanic floor. Then they are called deep trenches. Okay, they are the four major reliefs: continental shelf, continental slope, continental rise or abyssal plain, and deep trenches. Basically, now let us first discuss continental shelf. Okay, it is the extended margin of the continent. This is all I can tell about continental shelf, and its slopes, its average gradient, it ranges less than 1, or it might be equal to 1 also. It is usually less than or equal to 1, the gradient of the continental shelf. I mean, what does 1 imply? Tan theta equal to 1. It implies the slope is something like this. This is continental shelf. Okay, this is the area of photic zone. I mean, here, till here the sunlight will reach. Therefore, the continental shelf, it is a photic zone, and you can find lot of fossil fuels. For example, if there are any dead bodies that are floating, they come to the seashore, right? So here you can find fossil fuels also, and you can, this is a photic zone. Now you need to see the width of the continental shelf. The width of the continental shelf, it is in average around 80 kilometers, but the largest width, it is found in the Siberia, in the Siberian shelf, in the Arctic Ocean. There you get to see around 1500 kilometers. Okay, the largest width of continental shelf is in the Siberian shelf of Arctic Ocean, where it stretches up to 1500 kilometers. And the depth of the continental shelf, it is 200 meters. As I said, the ocean, you can get to find the ocean floor somewhere 3 to 6 kilometers below the sea level. Therefore, the max you can extend is up to 6 kilometers. That is 6000 meters. Okay, now you understood about the continental shelf. The depth is 200 meters. It is the general depth, but it might vary from 30 to 600 meters also. In general, we are saying that it has a depth will be 200 meters. Okay, next we need to see continental slope. Before proceeding into continental slope, I would like to tell that not only fossil fuels but also sediments, good sediments, they are all not only good sediments like I mean massive sediments, they are also found near continental shelf. Okay, now let us see continental slope. Continental slope, the average gradient lies between 2 to 5. What does this mean? For example, if you take this as a triangle, if this slope is increasing, that means this width is increasing. So you are going something like this. So the average gradient, it lies somewhere between 2 to 5. Okay, this is continental slope, and the depth extends up to 3000 meters. 3000 meters. So the depth of continental slope lies between 200 to 3000 meters. This continental slope, it connects the continental shelf to the continental rise, which you get to see later. Okay, continental slope connects continental shelf and continental rise. The change from continental shelf to continental slope, this changing point is called shelf break. Okay, because shelf is breaking and now you are starting with slope. Now finally, with the continental slope, the continental slope, it is the end of continent. After this, this region will not count into your continent anymore. Now the continental rise starts from 3000 meters. Usually in NCRT they mentioned that continental rise is between 2000 to 5000 meters, and abyssal plain, it is somewhere between 3000 to 600 meters. Okay, so in this area only you can find either a continental rise or else abyssal plain. Abyssal plains are nothing but deep sea plain, so they can be like this or sometimes they can also be like this. So it completely depends. So that is continental rise or abyssal plain. Continental rise from 2000 to 5000 meters, and 3000 to 3000 6000. Add 1000 extra here and extra here, then you'll get abyssal plain range. Okay, so these are the three major relief features that you studied. Now let us see deep trenches. See, deep trenches below the ocean floor, if you are extending 3 to 5 kilometers below, then that will be a deep trench. The best example for deep trench is Mariana Trench. And how do you describe abyssal plain as? Abyssal plains are flattest and smoothest. So the flattest and smoothest deep sea plains are called abyssal plains, and their depth range is between 3000 to 6000. So the only thing that they're going to ask you is the range. So continental shelf 2000, continental slope, continental shelf 200, continental shelf to continental slope 3000, and continental rise from 2000 to 5000, and abyssal plain from 3000 to 6000, and deep sea trenches 3 to 5 kilometers below the oceanic floor. Okay, now let us see minor relief features. So the minor relief features would be what are they? Whatever extra things you are seeing here. For example, mid-oceanic ridges. Mid-oceanic ridges, basically it is composed of two chains of mountains separated by large depression. For example, you are seeing two chain of mountains, right? And they are separated by large depression. That is called mid-oceanic ridge. The peak of mountain range, it can be as high as 2500 meters also. I mean, see, they can extend up to here also. That is also possible, but still they can be mid-oceanic ridge. Okay. If they're asking you example, I mean, if they don't usually ask, but in the mains you need to write example. So write Iceland. Actually, Iceland, the Iceland that you are seeing, it is formed as a part of mid-Atlantic ridge. Okay, Atlantic, mid-Atlantic ridge. Example, Iceland. Basically, just remember that mid-oceanic ridges, they are composed of two chain of mountains separated by large depression. The next is seamount. Here you can see seamount, right? Seamount are just like pointed summits rising from the seafloor that do not even reach the oceanic surface. Okay, pointed summits rising from the seafloor that do not reach the surface of the ocean. Okay, they can be as tall as 3000 to 4500 meters. Okay, example for seamount, you can write like Emperor Seamount. There is Emperor Seamount in the Pacific Ocean. Actually, Pacific Ocean has more than 10,000 seamounts, but the famous seamount in the Pacific Ocean, there is an Emperor Seamount that you can write in your mains. And next we have Mid-Oceanic Ridge Seamount. There is a submarine canyon. Submarine canyon, they are deep valleys. See, they are deep valleys, and They are comparable to Grand Canyon or Hudson Canyon. Submarine canyons are just deep valleys in the ocean. That's all. If they're asking you, for example, write Grand Canyon and Hudson Canyon. There are some famous example. Grand Canyon, it is in Colorado River. So just write the submarine canyon example, Grand Canyon of the Colorado River. Okay. Now you have seen mid-oceanic ridge, submarine canyon, and the deep sea mount. Now you have seen mid-oceanic ridge, seamount, submarine canyon. The next one is guyot. So guyots, they are similar to plateaus on earth. For example, seamount, if they are pointed summits, guyots, they are like plateaus on earth. Okay. They are flat-topped seamounts. Flat-topped seamounts are called guyots. Almost same. Okay. Mm. For example, if you are writing Emperor Seamount example here, then write more than 10,000 seamounts are available in the Pacific Ocean as an example here. More than 10,000 guyots are available in the Pacific Ocean can be example for guyot, and for seamount, write Emperor Seamount. Okay, that's how you manage. And for submarine canyon, write Grand Canyon in the River Colorado, and mid-oceanic ridge, Iceland in the mid-Atlantic Ocean. Okay, and then what else do we have? Atoll. Okay, atoll is also a minor relief feature. If you see, there is an island which raised above the water. Okay, they are island arcs. If you look at this diagram, if you view the ocean in the top view, there is this island which rose from the oceanic floor up to a certain extent. Okay, there are many such islands which are forming group. Okay, and people started living on these islands. So this group of islands, they are together called as atoll, and the water between this group of islands, that is called lagoon. Lagoon is lake of salt water. Lake of salt water or fresh water. It can be salt water or fresh water, or it can even be brackish water. Any lake which is formed between the group of islands is called lagoon. So atoll and lagoon, they are also minor relief features. Now we have seen four major relief features: continental shelf, continental slope, continental rise, and abyssal plain. Also six minor relief features. What are they? Mid-oceanic ridge, example Iceland. Seamount, example Emperor Seamount. Guyot, example more than 10,000 guyots in the Pacific Ocean. And submarine canyon, example Grand Canyon of Colorado River. Deep trench, example Mariana Trench. Atoll and lagoon. Now let us discuss the temperature of oceans. Okay, what are the factors that are affecting the temperature distribution of oceans? They can be latitude, unequal distribution of land and water, prevailing winds, ocean currents. All of them, they influence the temperature distribution. How latitude affects? For example, if you are here near the equator, the temperature of the surface water, it decreases from the equator towards the poles. That is because here the insolation is very high, therefore temperature will be high. As you move poleward, the temperature drops. Okay, that is about latitude. Now let us see unequal distribution of land and water. See, northern hemisphere has more land mass compared to southern, therefore lot of water, it will be in contact with land and it gets heated up. That is why the temperature of the northern ocean water is greater than southern ocean water. The third thing we have are the prevailing winds. This prevailing winds, this topic is important because see, in the next topic you will study that ocean currents. They are of two types. One is surface current and the other is deep current. And there you get to see thermohaline circulations. See, thermohaline circulations, they are also called subsurface circulations. It is the process of downwelling and upwelling. Let's say there are some surface winds and they create some surface currents. Now what happened? A lot of warm water in the equator, it moved towards this pole. So they move towards the poles, okay? And after the warm water moves towards the poles, what is going to happen? There are icebergs in the polar regions, and slowly they start to melt. As they melt, they are definitely going to have some salt. So the salt concentration in the water, it will increase and the water start to go downward. Okay, the denser water, whatever is the denser salt water, they tend to go down. And after they go down, there are deep water currents. We have seen two types of water currents. One is surface water current, another is deep water current. So these deep water current, they take the downwell water to the other side because it is denser, and therefore they again move equatorward. See, what happens is that when there is insolation, the temperature near the equator, it will increase and the water rises 8 centimeter above the equator. Then in that situation, the water moves from equator towards the pole. The surface water, it moves from the equator towards the pole, and the surface water, it is warm. Due to thermal expansion, the water near the equator, it raised 8 centimeter above, and then it will move from equator towards the pole. And the poles, after they melt, the concentration of salt, it will increase, and the dense water, it sinks down. And the deep water, the deep surface current, they carry that dense water towards the equator. Okay, and in the equator, there will be again upwelling because you again got some cold water from the bottom. Okay, you get to see upwelling. That is why equators, they have nutrient rich water, that is presence of fishes, phytoplankton, etc., because upwelling will be there near the equator only. So just remember, this is a subsurface circulation. Basically, equator, it is warming up and the surface current are moving towards the polar region, and here you get to see downwelling, and the deep water current, they carry this water again to the equator, and there you will see the upwelling, and due to this upwelling, the region will have higher fisheries, phytoplankton growth, etc. So this is how latitude, distribution of land and water, prevailing winds, they affect temperature distribution. Now let us see oceanic currents also. Oceanic currents, this is what you have already seen, so we need not discuss about it again. But one thing you need to know is that if it is an enclosed sea and if it is an open sea, okay. For example, if it is in the low latitude area and it is an enclosed sea, if it is like this, if it is an enclosed sea, the temperature will rise because it has nowhere to go, and there is a lot of insulation. Therefore, definitely the temperature will increase. But if it is an open sea, if it is an open sea, then they will mix with the ocean water, and the temperature it is comparatively low in the open sea. And similarly, when you move to the higher latitudes, the temperature is higher in the closed sea. The temperature is higher in the open sea, and the temperature is lower in the cold sea. Why? Because higher regions, higher latitudes, they are usually cool, and the enclosed seas they have comparatively lower temperature than the open seas. Because in the higher latitudes, the open seas they uh, in the higher latitudes in the open seas they are connected to warm oceanic currents, and that is why their temperature is relatively higher than the enclosed seas. So if they ask you about enclosed sea and open sea, the closed seas they are having higher temperature than the open seas due to insulation, because these water they are not connected to anything. And in the higher latitudes, see, if they're asking you the in the lower latitudes, okay, if they're asking you to compare enclosed sea and open seas in the lower latitudes, it is very clear that in the lower latitudes, the enclosed seas they are having higher temperature, and why they are having higher temperature due to insulation. And if they're asking you in the higher latitudes, then the open seas will have high temperature because they are connected to warm oceanic currents. So open seas they are having high temperature than the enclosed seas in the higher latitudes. Okay, the phenomenon is just reverse. So these are some of the factors which are controlling the temperature distribution. Now let us see vertical distribution of temperature. Okay, as you can see the map is starting from 0, 4 and etc. 4 table till 24 we have taken, and this is 500-meter depth and 1000-meter depth, and the depth is increasing. Thermocline, it is the region where you see a rapid decline in temperature. Okay, region of rapid decline of temperature in the oceanic water, that is thermocline, and it might start somewhere around 200 meter, but in the map we have taken it from 500 meters, but it can start even near 200 meter. Okay, now till 500 meter we are just considering it as surface water, and from 500 to 1000 it's a thermocline, and from 1000 meters, I mean 1 kilometer from the oceanic surface, that will be deep oceanic floor. Below 1 kilometer, that will be very cold water. Okay, why? See, surface water, let's say the temperature it's almost equal to earth, let's say it is somewhere between 20 to 24 degrees. Now till here the temperature is between 20 and 24 only in the surface layer, but once it reaches this thermocline, the temperature rapidly declines to around 4 degrees Celsius, and after the 1 kilometer, wherever you go you will experience the similar temperature, that is 4 degrees Celsius only, everywhere deep inside the water. That is about the vertical distribution of temperature. Okay, as the depth increase, the temperature will decrease, the temperature will drop out, and the rapid change of dropout is observed somewhere between 500 to 1000 meters. Now let us see the horizontal distribution of temperature. Okay, now we have equator, which is 0 degrees Celsius. Okay, there the average temperature is somewhere around 16 degrees Celsius, let's say. But the tropics, if you see tropics, somewhere around 14 degrees Celsius, the temperature will be maximum because it is latitude above the equator, right? There the insolation is actual maximum. Therefore, the temperature is highest noticed there somewhere 40 degrees, and 20 degrees again the temperature drop to 22 degrees Celsius because of the interaction with the cold oceanic currents, etc. And then as you go towards 90 degrees pole, the temperature is 0 degrees Celsius. So the temperature is maximum at the 14-degree latitude. Okay. Therefore, the highest temperature it is recorded slightly above the equator, not at the equator. Okay. This is the highest temperature recorded, but you see, if you see the average is 19 degrees Celsius. Okay, and the rate of drop of temperature as you move from one latitude to other, it is somewhere around 0.5 degrees Celsius. Similarly, let us try to understand the salinity of the ocean water, like how we understood the temperature of oceanic water. Salinity of oceanic water, it is defined as salt dissolved divided by the sea water. Okay, salt dissolved in grams divided by the sea water. Okay. What are the factors that are affecting the salinity of oceanic water? There can be evaporation and precipitation. As if evaporation is high, salinity will be high. I mean, a lot of salt will remain here, right? Therefore, water will be saline. And what if precipitation is there? If there is rainfall, of course, salt water concentration it will be reduced. And similarly, fresh water inflow from the rivers, they also affect the salinity concentration. And wind, ocean currents, they are also some of the factors that are affecting the salinity of oceanic water. You might ask how wind contributes. See, wind may transfer because due to the water transfer, there is also a change in salinity, right? Because wind it is influencing the surface currents, therefore you can see the change in salinity. Similarly, oceanic currents, we have seen how they are contributing to salinity before. So these are some of the factors. Now let us see where the highest salinity is recorded in the oceanic water. See, the first highest salinity you can find it in the Don Juan Pond. The Don of salinity. Okay, Don Juan Pond, it is located near Antarctica. The precipitation, the parts ppt, Don Juan Pond, Don Juan Pond, it records the highest salinity around 440 ppt. Okay, and then we have Lake Retba, which is in Senegal. So one is in Antarctica, other is in Senegal, and third is also in Antarctica. So you can see that Antarctica, the polar areas, they are the major source of salt. Okay, Don Juan Pond of Antarctica around 440 ppt, and Lake Retba, it is in the Senegal, which is 400 ppt, and we have Lake Vanda, it is in Antarctica, 350 ppt. So they are the top three highest salinity water: Don Juan, the Don, Lake Retba, and Lake Vanda. Okay. In the NCRT, they have given Lake Van. It is somewhere around 330 ppt. Okay, that they are all the salt water bodies that you need to know. Dead Sea, it is also a salt water body. Okay, around 238 ppt. Anyways, just remember the Don Juan, which is in Antarctica, Lake Retba, which is in Senegal. They are the top two, Don Juan and Lake Retba. Similar to how we have seen vertical and horizontal for the temperature, let us see for the salinity. Okay, salinity. We have low salinity this side and high salinity this side, and this is the depth. Okay, as you move towards the right, the salinity will increase. Now they are the polar areas, so that means there is a lot of ice in this side, and let's say it is the equator area. Okay. So tell me, where do you find highest salinity? Near the equator or near the poles? See, poles, the ice is having salt, but water is not having salt, no? Not that much salt. Uh, Similarly, in the surface, if you see, they are having more salt compared to ice poles. And the subtropics, they are having more salt more than equators. Why? See, there is a lot of evaporation that is being observed near the surface water. Therefore, the subtropics, they are more saline compared to equators. Now, what's going to happen? Along with depth, we need to check how the salinity is varying. See, definitely subtropics at the surface, they are having more salt than equator due to evaporation, and polars, they are having the low salinity. That's for sure. Now, with the depth, there is an interesting fact. See, as depth increases, the salinity will decrease. The salinity will decrease for what? That will decrease for equator regions. And as the depth increases, the salinity will increase for polar regions. Why? If I talk about polar, na, the ice, it is just ice. It is a land surface. Now, whatever salt water is there, that is heavy and it will go down. So it will subside down. Therefore, salt water below the ice, they are more saline compared to land. Therefore, the salinity, as you move below the polar regions towards the water, into the water, then the salinity will increase. Okay. In the equator regions, if you observe, the deep oceanic currents, they are generating upwelling, the diagram that you have seen. Therefore, the salt, it is recorded, the salinity, it is recorded maximum here. Okay, salt content is maximum near equator and subtropic, and they are minimum as you go down. If you apply general logic anywhere in the ocean, you will think that salt water, it is dense, and it must be here for everything. You will think, therefore, with for everything you will plot something like this, but the diagram will go wrong. Just remember the diagram that we have studied just before. In the polar region, salt water will subside down. Therefore, salinity, it will be maximum in the bottom, maximum at the bottom for the poles. And as you move towards the equator, there will be upwelling, and the salinity, it will be maximum in the surface water. Okay. Now, if I ask you where is the maximum salinity in the surface level, whether it is at the equator or it is at the pole, the answer will be at the equator. The salinity is maximum, and at the poles the salinity is low. And as you go down, the salinity, it is a maximum near the poles, and it is minimum at the equator and subtropics. And which one is having a more salinity, subtropics or equator? Subtropics are having more salinity than equator, because subtropics, they are also subjected to evaporation, more evaporation, and therefore the concentration of subtropics, they are relatively higher than equator. Okay, just remember this logic. So I wrote a diagram for you here, so it will be easy. Halocline. So what is this halocline? See, similar to how we divided the temperature, similar to how we have divided the oceanic water based upon temperature distribution. Now let us try to divide the oceanic water subject to salinity. Okay, the halocline, they're having rapid change of salinity. The thermocline, right? Haloclines are the region of rapid change of salinity, and the thermoclines, they are region of rapid decline of salinity. One second, haloclines, they are the region of rapid change of salinity. That is change. Thermocline, they are the regions of rapid decline of salinity. Okay, and we can divide them into three zones: surface water, halocline zone, and deep water zone. Okay, they might ask what is stratification of salinity. Stratification of salinity is nothing but layering of water bodies due to different densities. Layering of water bodies due to different densities, it is called stratification of salinity. Now let us see horizontal distribution of salinity. Okay, we have oceanic water. Oceanic water, उसका salinity कितना है? 33 to 37 ppt. Oceanic water, the salinity lies between 33 to 37 ppt. And we have landlocked Red Sea, इसका salinity है 41 ppt. And Asheris and Arctic, somewhere 0 to 35 ppt. See, these are all the salinity which you don't need to read, and no one is going to ask. But there are certain salinity that they might ask, because see, who is going to remember all and who is going to ask? Technically, no one. But so you need to realize that certain salinities are important. For example, the highest salinity, it is, where is it recorded? Similar to how you studied highest temperature, it is recorded at where you have seen the graph. They are recorded in the subtropic. So the highest salinity, they are also recorded in the subtropic. And what is that? That is somewhere around 37 ppt. I mean, in average, it is 37 ppt. That's not the highest, but it's the average. Now let us see horizontal distribution of salinity. The highest salinity, it is recorded near the subtropic, somewhere between 15 to 20 degrees latitude. There is the highest salinity recorded. And the North Sea, they are having more salinity. Why? Because of North Atlantic drifts. They are warm currents, right? So due to those warm currents, the ice water, they are melting, and the salinity is recorded maximum near the North Sea. I mean, they are more in the North Sea. And if you see Baltic Sea, Black Sea, people will think that okay, they are saltwater lakes, etc. But no, Baltic Sea and Black Sea, they are receiving many freshwater influx. That is why they are having low salinity. And we also have Mediterranean Sea. Mediterranean Sea, it will have more salinity because the evaporation is high there. Mediterranean Sea, due to high evaporation, the salinity is more in the Mediterranean Sea. Okay, now these are the three things that you can know. You also need to know about Indian Ocean. Indian Ocean, the salinity is somewhere around 35 ppt. And if you are asking me to compare Arabian Sea and Bay of Bengal, which is having more salinity, see, wherever there is high temperature, there is a low salinity. For example, Arabian Sea, it is having nowadays the temperature is very high in the Arabian Sea. Therefore, the salinity is more in the Arabian Sea. And also Bay of Bengal, it is having less salinity because we are seeing some freshwater influx into the Bay of Bengal. That is why it is having lower salinity. Okay. And maybe you can try to memorize or just leave it. If evaporation is high, the salinity will be high. The maximum temperature, the maximum salinity that was recorded is 70 ppt. Discuss about the movement of ocean water. We have tides, current, and waves. Okay, tide implies rise and fall of oceanic levels. They are called tides. And currents, they are the movement of water in a specific direction. And waves, they are the movement of energy across water surface. So when question mentions rise and fall, people usually think waves. Why? Because waves also you draw like this and you will see rise. That's not correct. Waves, it represents the movement of energy across water surface. Tides, they represent the rise and fall of oceanic levels. And if you're talking about direction, like clockwise direction and anti-clockwise, they are currents. Okay, movement of water in a specified direction. Okay, these are the definitions that you must know. Okay. So what are the factors which affect the movement of ocean water? We have temperature, salinity, wind, etc. For example, if temperature increases, what's going to happen? If temperature increases, there will be a lot of evaporation. And if there is a lot of evaporation, there will be more evaporation. And if there is more evaporation, what happens to the density? People will then think that there will be more salt water, and therefore the density will increase and the movement of water will slow down. This is what people will think it and mark it wrong, but that's not actually correct. See, if temperature increases, you don't go till evaporation. Okay, just think normally. Evaporation के लिए time लगेगा ना. Evaporation होने से पहले क्या होगा? Thermal expansion of water will be there. So due to this thermal expansion and heating and all, जो actually salt water है, density जो है वो नीचे subside हो जाएगी. So the lighter water, it will move above. Okay, when it moves above, the movement of water, it increases. So just think normally, don't go till evaporation. Okay, when you think normally, you will realize that there will be thermal expansion of water, and the ice water, whatever it is there, cold water, it will subside down, and the movement of the water above the water surface, it will increase. So movement of water surface will increase. That is when the temperature increase, movement of water will increase. And when temperature decrease, what happens then? If temperature decreases, water will be more dense, therefore movement of the water, it will decrease. Okay, here movement of water will decrease. What about the salinity? If there is more salinity, of course the movement of water, it will decrease. And what about wind? See, if there are more surface winds, of course the movement of water will also increase. And what about Coriolis force? Coriolis force hai to of course there will be current. How are the currents created? They are because of the Coriolis force only. So Coriolis force also affects the movement of ocean water. And next we have sun. Does sun affect? Do you see any effect of sun? Of course, sun is providing insolation in the tropical area, and that is increasing the warmness, and that is how the movement of water is getting affected. What about topography of the ocean floors? See, for example, let's say this is your sea mount. Let's say it's your sea mount, and it is some trench. So as the water moves, some of the water, it will move in the downward direction. Okay, that is downward movement of water. When there is downward movement of water, of course, the original moment in the upstream, it will reduce. Why? Because lot of water, it is subsiding down only. Therefore, here the velocity, it will reduce. So that is how the topography of ocean floor can also affect. Okay, for example, if there is sea mount, the water direction might change. So this will also affect the moment of ocean water. So there are different factors which affect the moment of ocean water. Now waves. Now let us start with each topic. Waves. Waves are actually the energy. They are not the water. Okay, this is what you need to know. Waves are the energy. It is not the water. And basically, wind, it is providing energy. Wind provides energy, and that energy travels across the ocean floor. That's all you need to know. Okay. And one more thing you need to know is that when a wave is created, if the wavelength is say lambda, then if the depth of the water, let's say this is the water level, and let's say the depth of the water is d. If the depth of the water is less than half of the wavelength, then the wave breaks. The wave will break. There will be no energy because depth of the water is only less. If depth of the water is so less, then definitely the wave will break. Okay. Therefore, if the wind increases, the energy will increase, and if the energy increases, the wave moment will also increase. And also, as the wind strength increases, the height of the wave will also increase if the wind strength increases. Of course, right? These are the little facts that you need to know. The size and shape of the wave will determine the origin. So you can find the origin based upon the size and shape of the wind. For example, if you are seeing a steep wind, that means it is a young local wind. For example, if you are seeing a slow and a steady wind, that means it is coming from a far away place. That is why it is able to be. That is why it is very stable right now, and it is moving slowly because it came from a far place. That's why it is very slow right now, and it also has a pace. It is very steady. So that's how you can identify the origin based upon the size and shape of the wind. And now let us see the characteristics of a wave. See, now I am drawing this as a wave. I will tell you each one. For example, wave crest and trough. This is called wave crest. The upper portion, the highest point of the wave, and the lowest point of the wave is called trough. These are the crest and trough. Okay. Wave height is the vertical distance between the bottom of the trough to top of the crest, and wave amplitude, it is one half of the wave height. This is wave height, and amplitude, it is one half of the wave height. This is the information that you need to know. And what is wave period? Wave period, it is merely the time interval between two successive wave crest or wave trough. For example, this is wave crest, and next again you need to go. You are getting another wave crest. So that time interval is called time period. Okay, or else let's say this is trough, and you are going and reaching the next trough. So the time interval between them is also called as t. Okay, or else see this wave, na? This wave, the entire time period, it is also called time period only. Okay, that is something you need to do. See, t by 2, t by 2, t by 2, t by 2. Did you not get t? And similarly, this portion also I can break into t by 2, t by 2, t by 2, t by 2, and t by 2. You got t. So anyways, as per NCRT, the definition is wave. Time period. It is the nothing but wave period. Wave period is nothing but time interval between two successive crest or trough. Okay. And next, what did we see? We saw wave speed. What is wave speed? It is the rate at which wave moves through the water. Rate at which wave moves through the water is called wave speed. And what is frequency? Number of waves passing a given point during 1 second time interval. if you see frequency, if you take a point, or if you take this point, number of waves passing through this point in a 1 second time interval is called frequency. That is nothing but 1 by t. Okay, frequency is nothing but 1 by t. Wave speed, again, wave speed is rate at which wave moves via water. That is represented in knots. Okay, wave speed is, it is measured in knots, and wave frequency, it is the number of waves passing through a point in a 1 second interval. That is denoted by 1 by t. Okay, now if you see speed, it is distance, that is wavelength divided by time period. Okay, 1 by t is nothing but frequency. Tides are the rise and fall of oceanic level. Basically, tides, they are the resultant of gravitational interaction between the sun, moon, and earth. Okay, you might hear the word surges also. Surges is different. Surges is caused by the meteorological effect due to wind and atmospheric changes, not because of gravitational interaction, but it is due to wind and atmospheric changes. Okay, they are irregular, unlike tides. Okay, tides are different. Tidal bulges are different. Tides are due to gravitational interactions, whereas surges are due to meteorological effects like wind and atmospheric changes. Tides are regular, whereas surges are irregular. Okay, let us see how gravitational force affects the tidal bulges. Okay, now Earth, it is surrounded by ocean, right? Earth has oceanic water. Now, when there is moon, of course, moon, there must be some gravitational attraction between moon and earth. In such scenario, the ocean water, it moves towards the moon, right? It gets attracted to the moon's gravitational pull. Therefore, you will see high tidal bulge this side, right? That is due to gravitational force. But what is the centrifugal force? See, tidal bulge may be on the opposite side if there is a gravitational pull from the moon, and the centrifugal force to counter this gravitational pull is so high. Then in such scenario, you can see tidal bulge in the other side. Okay, due to centrifugal force that is countering gravitational pull due to moon. In such scenario, the tidal bulge goes in the opposite direction. This is tidal bulge of the ocean in the opposite direction. There is a tide generating force. Okay, tide generating force. Tide generating force, it is the difference between the two forces, that is gravitational force minus centrifugal force, that will determine the direction of the oceanic tide, whether to be in this direction or this direction. That is tide generating force. So now if there is a question, where are the tidal bulges high? See, here onwards you are having ocean after the coast. So tidal bulges, they are usually high near the continental shelf. The tidal bulges rise to a greater height, okay, near the continental shelf. But if you go to the mid-oceanic islands, where there is a, due to a split of the oceanic crust, there might be some mid-oceanic islands, right? There the tidal bulges usually they tend to go low. Okay, the highest tidal bulges are noticed near continental shelf, and they become low near mid-oceanic islands. Shape of bays and estuaries along the coastlines, their shape also affects the magnitude of the tidal height. Okay, for example, funnel shaped bays, they greatly change the tidal magnitude. And when the tide is channelized between two islands or into bay and estuaries, such kind of tides are called tidal currents. Okay, that's all. So this part is mentioned in the NCERT. The highest tides they occur in the Bay of Fundy. Fundy, right? वहाँ पे बहुत fun है क्योंकि tides बहुत ऊपर जाएगी. That Bay of Fundy, it is in Canada. Okay. Now let us see the types of tides. You can classify the tides based upon the frequency. So basically here the tides may be grouped into various types based upon the frequency of occurrence in one day. Okay, for example, semi-diurnal implies they are the most common. First, semi-diurnal, they are the most common, and they feature two high tides or two low tides in one day. So in one day you are having like this, say, so there are two high tides and two low tides. There are two high tides and two low tides, right? That is semi-diurnal. In diurnal tide, there is one high tide and one low tide in one day. So in one day, if you are just seeing this much, that means there is one high tide and one low tide. Okay, that is diurnal. What is mixed tide? Mixed tides, they are having variations in height. Okay, and they can be mixed. These tides generally occur along the west coast of North America and many islands of Pacific Ocean. Okay, they are generally mixed. Now you have seen tides based upon the frequency in one day. If you are having two high tides and two low tides in one day, then they are called semi-diurnal and they are the most common. If you are having only one high tide and one low tide in one day, then it is diurnal. And if you are having mixed tides, I mean different variations of height, then they're mixed tide and they generally occur in the west coast of North America. Now we need to see tides, type of tides based upon the position of sun, moon and earth. Okay. So based upon the position of sun, moon and earth, for example, in the spring tides, you see that earth, basically earth, moon and sun, they are in the same straight line. If they are in the same straight line, what's going to happen? The height of the tide will be very high, right? Height of the tide, it will increase. But what happens in the neap tide? Neap, we can tell it as neap. Okay, what happens in the neap tide? The directions, they're perpendicular. Basically, see, in the neap tide, the sun and moon, they are at right angle to each other. Okay, so in such scenario, what happens? The tidal forces of sun and moon, they counteract with each other, and in such scenario, the height of a tide is usually low. Do you know one thing? Since moon is closer than earth, of course, moon's attraction will be two times stronger than sun's interaction. Let's say x. Okay, so moon's attraction will be two times stronger than sun's attraction. But even then, the tidal forces might diminish a little, and therefore the height of tides, they decrease in the neap. So neap tides are different from spring tides. It depends upon the position of sun, moon, and earth. Yes for yes, S for straight. So earth, moon, and sun, they are in the straight. Neap, that is perpendicular. Okay, this is how you need to remember. Spring tides, they occur 2 times a month. Okay. Also, the interval between spring tides and neap tide is 7 day interval. Okay. So when are the tidal ranges greater? Whenever earth is closer to the sun or moon. Okay, then in such scenario, tidal ranges can occur. You know, aphelion and perihelion. Perihelion is close to the sun. Similarly, perigee, it is close to the moon. Apogee, it is close apart from the moon. Okay. So the naming changes based on whether it is sun or moon. So when water is falling, If water is falling, then the time between high and low is called ebb. But when the water is rising, the time between the low and high, it is called flow or flood. Okay. But that neap tide and spring tides, they occur 2 times a month, both, because see, Earth, Moon, and Sun, they must be in the same line, right? So that same line, it can happen 2 times a month, right? One is full moon and other is new moon. So therefore, spring tides can occur 2 times a month, because 2 times they can be on the same line, and neap tides two times they can be on the perpendicular line, right? Therefore, spring tides occur 2 times a month, neap tides occur 2 times a month, and the gap between them is 7 days. Now let us see the importance of tides. See, you know the tidal forces, right? Navigators in the ocean, they can predict very easily. For example, fishermen and all, they can predict the navigation plan easily, because they know that okay, this is the full moon day. Now the tidal forces are going to be very high. So first thing is that it will be helpful in the navigation, and also they are helpful in removing polluted water. So they are helpful in removing polluted water from estuaries, and tides, they are used to generate electric power. So these are the 3 things that you need to know. Tides, they are helpful for navigation, they're helpful in removing polluted water from the estuaries, and they're helpful in generating the electric power. Okay, and there are many other uses also. See, if there are more tides, of course, electricity power will be generated, and if there are more tides, of course, polluted water, it will go away from the estuaries, and also it will help for the navigation. So these are the main 3 important uses that I can see. For example, in West Bengal, using in West Bengal, I think, in the Sundarbans, they built a dam using the tidal power project. 3 megawatt dam was built in the West Bengal. Okay. Now we have seen about waves. Also, we have studied about tides. Now let us see ocean currents. Ocean currents are like river flow in the oceans. They represent regular volume of water in a definite path and direction. That's all. So that is ocean current. Basically, they represent regular volume of water in a definite path and direction. And ocean currents are influenced by 2 type of forces, which are primary and secondary. So now we need to see what are the primary forces that are influencing the ocean currents and what are the secondary forces. Now first let us see primary forces. Okay, the primary forces that influence the currents are, I will tell you. So these are the 4 forces that are influencing ocean currents. What are these 3 primary forces which are influencing ocean currents? One is insolation, other is wind, third is gravity, and fourth is Coriolis. Wind, that is blowing like this on the surface of the ocean, pushes the water to move. Okay, the friction between the wind and the water surface, it affects the movement of the water body. That is all about wind, which you already know. Let us see how gravity affects the direction of ocean current. For example, you know, the gravitational force changes as you go from here to here. Where is the gravitational pull highest at? I know a formula. I think it's Gm by R or something, gravity ka formula. If radius increases, gravity will decrease. So therefore, at the equator, gravity will be low, and when you go to the poles, gravitational pull will be high. So this is what I know. Therefore, based upon what I'm thinking, if you go to the pole, the gravitational pull is high, and here the gravitational pull is low. Therefore, again, the ocean current will move in this direction due to gravitational gradient difference. So that is how gravity is affecting. Now let us see Coriolis. Okay, Coriolis, you know the Coriolis force in the northern hemisphere, the Coriolis acts in the rightward direction, and in the southern, it acts in the leftward direction. Now, what happens? The ocean currents in the northern hemisphere tend to go in the right side direction, tend to move in the right direction due to Coriolis force, and similarly, the ocean water, it tends to move in the left direction due to Coriolis force in the southern hemisphere. Okay, this is what you need to know. Do you know what gyre is? You might have heard this term. The large accumulation of water and the flow around them, it is called as gyre. Okay. Gyres, you will listen this term many times in the ocean currents. They are the one who produce large circular currents in the ocean basin. Gyre. Remember that ocean currents, they are also called as drift. So usually what happens, currents, they are strong near the surface, and they attend usually the speed up to 5 knots, and the speed of the current, it increases. I mean, at the surface level you will have more speed, and as you go into the water, the speed of the current, it will reduce. At the surface level, let's say it's 5 knots, then at depth you will be having some 0.5 knots. So that is how speed varies with depth, and we refer to the speed of the current as drift. Okay. Knot is used to represent speed of wave. If you want to represent the speed of current, it is represented with drift, and drift, it is measured in terms of knots. And when they are asking you the strength of the current, then you need to just mention the speed of the current. For example, a fast current, it is called strong current. That's all. Fast current is called strong current. Anyways, most of the currents, they have a speed less than or equal to 5 knots. Okay. Okay, now you have seen that there are primary forces due to which you are seeing current, oceanic current. But realize one thing, that primary forces, they are responsible for the genesis of ocean currents, but secondary forces, they are responsible for sustenance of ocean currents. Okay, that is difference between primary and secondary. Simply putting, insolation, wind, gravity, Coriolis, they are creating, or they are somehow creating the currents. But the secondary forces that now I'm going to tell you, they are helping the currents to be maintained. That is sustenance. So secondary forces, to understand this, you need to understand the differential density. So differential density, it will help maintain the sustenance. For example, temperature difference and also salinity difference. Shall we first see salinity difference? Because this is very easy. For example, if salinity increase, then water will be more dense. If water is more dense, then denser water will sink. Okay, and lighter water, it will rise. So that is how you get different densities. If salinity increase, density increase. Similarly, temperature. If temperature increase, then density will decrease. Density will decrease. So let us decrease the temperature. If temperature decreases, then density will increase. Okay. Now this is how it affects. And what happens when water becomes dense? Water becomes dense, it subsides down, and whatever water is there, lighter water, it moves up. Okay. This phenomenon I will explain you. For example, in the polar regions, when the cold water, it subsides, it will move in one direction, right? Then it will lead to cold oceanic current. तो ऐसा होगा कि cold oceanic water from the poles, it will move this side, and the warm oceanic water from the equator, it moves above. Okay, warm water. That is how oceanic currents are developed with a change in density. because now the water is warm, therefore this water will get a movement to go this way. And similarly, now the water is cold, so now it want to subside down, so it will move in this direction. Okay, so that's how the change in density, it will help in the sustenance of oceanic current. The density can change due to change in temperature or change in salinity. Now let us see the types of oceanic current. Oceanic currents, they can be divided based upon depth or based upon temperature. Based on depth, they can be surface level currents or deep warm current. Similarly, based on temperature, they can be cold or they can be warm. So basically, water surface currents, they constitute 10% of the water in ocean. Okay, 10% of water in ocean, it is surface current, and they are usually the upper 400 meters. The upper 400 meters, they are surface current, and deep warm current, they make up the other 90%. Okay, surface current, they are 10%, upper 400 meters, and deep water, the other 90%. Deep, okay, ये तो 10% ही है, नीचे का कितना 90% है. So deep water, they constitute up to 90% of the ocean water. Okay, now let us see based upon temperature. This is very easy. See, when you are calling a current as cold current, it means that it is bringing cold water to warm area. So cold currents are bringing cold current into warm area, and warm current, they are bringing warm water into cold area. That's all. The thing is, where do you observe this cold current? So this is the diagram that I try to memorize. Mm, or else this diagram is better, na? Cold. Cold implies, see, draw one S for cold, okay? And for warm, try to draw half W till here. Draw till here. That is for W, warm, and this for cold. So cold currents, you see them in the west coast of low and middle latitude. So west coast, this is west side, right? So in the low and middle latitudes, they are the low and middle latitudes. Here you are going to see the cold currents in the west side of low and middle latitudes. And if you go to higher latitudes, there you will see on the east coast. So cold currents are observed on the east coast of higher latitude and on the west coast of low and middle latitudes. Similarly, warm currents, they are observed on the east coast of the low and middle latitudes. That is here. They are in the lowest. They are lowest, right, in the diagram. So warm currents, they are observed on the east coast of low and middle latitudes and west coast of high latitudes. This diagram you need to remember. That's all. By just drawing this diagram, this is west side and this is east side. So in the high latitudes, they are observed on the eastern side, and in the low and middle latitudes, they are observed on the western side. Similarly, here warm currents in the low latitudes, they are observed on the eastern side, and warm currents are observed on the western side of high latitudes. Okay. This is true for both the hemispheres, both the north and south. Or you can also try to memorize like this. This is west and this is east, and let's say they are higher and higher latitudes. They are higher latitudes and they are lower and middle latitudes. Let's split them. Write CW classwork in the lower and middle latitude, and write invert this and write W and C. So in the higher latitudes, warm currents are observed on the west side, and cold currents, they are observed on the eastern side in the higher latitudes. See, this is higher latitude, and cold current, it is in the eastern side, and warm current, it is on the western side. Similarly, for the lower and middle latitude, it is reverse. But go with only one trick. I think this trick is good enough. Warm current and cold current. But if you holistically want to draw a diagram, just keep a plus symbol. West and east, it is very easy. Write lower and middle latitude and higher latitude here. Write CW down and invert it WC in the above. Let us discuss major oceanic currents. There is a trick to memorize. Warm currents, their name starts with A, and cold currents, their names sound very cool and stylish. Okay. And there's a question. Equators, they are called region of doldrums. Doldrums implies calmness. Then why currents are moving near equator? Because it's calm, right? It means that there must be no wind. There must be no wind there. Then why there are currents? The reason is Coriolis force. Okay. Due to Coriolis force, due to the rotation of Earth, there is a movement near equator. Let us discuss oceanic currents. There are two types of oceanic currents. One is warm oceanic current, another is cold oceanic current. See, Earth moves eastward and there is insulation near the equator. As Earth moves eastward, definitely currents are going to generate in the opposite direction, right? The water, it's going to move in the opposite direction. Therefore, the north equatorial current moves in this direction, and the south equatorial current also moves in this direction, opposite to the Earth current. This equatorial countercurrent, as the name suggests, it seems like as the Earth moves east, it will move in the west. No, the equatorial countercurrent, it is also moving in the same direction as Earth. But the currents above and below the equatorial countercurrent, they are north equatorial and south equatorial. They are moving in the opposite direction of the Earth direction. Okay, Earth is moving from west to east, but these currents above and below equator, they are moving in the west, from east to west. Okay. As the north equatorial current moves to the west direction, it drifts. So if it is drifting from Gulf of Mexico, they renamed it as Gulf Stream. Okay, and then it is going through North Atlantic Ocean. Therefore, it's called North Atlantic Drift. And then finally through Norway, it is called Norwegian Current. Therefore, you have seen 5 currents till now: equatorial countercurrent, North equatorial and South equatorial currents, Gulf Stream, North Atlantic Drift, and Norwegian Current. And all the names starting with A, they are warm currents. For example, near Alaska, there is this current, Alaska Current, which is warm. And then we have what in the northern hemisphere? I'm trying to figure out warm currents. In near the Japan, there is a Kuroshio Current, which is warm. So you have seen all the warm currents in the northern hemisphere. Now let us try to figure out warm currents in the southern hemisphere. Okay, you have south equatorial current and it goes through Brazil. Therefore, Brazilian current, it is also warm. So 2 currents, south equatorial current and Brazilian current, they are warm. And next, you have south equatorial current even in the Indian Ocean, right? Yes. Even not only in the Atlantic Ocean, now you need to see in the Indian Ocean. In the Indian Ocean, the south equatorial current moved through Madagascar, right? So they are called August current and Mozambique current. August, anyhow, the name suggests it is starting with A, therefore it's warm current, and Mozambique current, it is also warm. So therefore, you are having 2 currents, 2 new currents. One is Brazilian current, and the other is August current and Mozambique current, which is warm. And there is also one more current, which is East Australian current. This is in the east side of Australia, right? Therefore, East Australian current, that is also warm. Why I'm saying east and why not west? See, remember one thing. You have studied this, right? Lower and middle latitudes in the west coast and east coast, and warm currents, they happen where? Near the east coast. Therefore, East Australian currents, they are warm. Okay. Once again revising: North Equatorial Current, Gulf Stream, North Atlantic Drift, Norwegian Current, Alaskan Current, Kuroshio Current, and then from the South Equatorial Current you're having Brazil Current, and in the Indian Ocean, August Current and Mozambique Current, and in the Pacific Ocean, East Australian Current. Okay, these are the warm currents. And now we need to discuss cold currents. Cold currents, first let us discuss in the North Hemisphere. Okay, from the polar, Arctic polar, we are having two currents surrounding the Greenland. One is Labrador Current and the other is East Greenland Current. And then there are Canary Islands of Spain beside Africa. So cold currents are even flowing through them. They are called Canary currents. Okay, Canary, the name looks stylish, similar to California Current, which is cold. Okay, Canary Current and California Current, they are cold currents. C for C. Okay, cold. C for cold. California Canary Current and California Current, they are cold currents. Now next, there is one more cold current in the North Hemisphere, which is Oashio Current. Oashio Current, that is also cold current. So Labrador Current, East Greenland Current, Canary Current, California Current, Oashio Current, they are cold currents. And there is west wind drift in the southern hemisphere, which is bringing cold current in the Humboldt, and Benguela Current in the uh, near the Africa, and you have West Australian Current. Okay, so west wind drift, they are cold drifts, and there is a Humboldt Peru Current near South America, Benguela Current near South Africa, and you have West Australian Current near Australia. So Australia, west side it is West Australian Current, and east side it is East Australian Current, and east side it is warm and west side it is cold. And easily you can remember it by drawing this map, classwork, and since it belongs to lower and middle latitude, therefore you will use CW, and see it is cold in the western coast and warm in the eastern coast. Therefore, East Australian Current is warm and West Australian Current it is cold. And similarly, Benguela Current, it is on the western side, it's cool. And Humboldt Current, it is near Peru, it is also cool. Okay, these are the major oceanic currents. Now, direction also becomes important. I think you are not confused with these directions till Norwegian Current, from starting from North Equator Current. And also Labrador Current and East Greenland Current, their directions are also clear. As I said, cold water, it is denser. Therefore, they try to subside down and they move towards down towards the equator. Similarly, warm currents, they are warm and they are lighter. Therefore, they move in the opposite direction. Why? See, as I said, as the equator heats, the warm water will rise 8 centimeter above or something like that. Therefore, then they need to drift downward. Therefore, they will move towards the pole. Warm currents, they move in this direction, and cold currents, they subside down and they move downward. Okay, that is how it will work. Similarly, Alaskan currents also, they are warm, therefore they need to move upward. And California current, they are cool, therefore they will move downward. Okay, and Canary current also, they are cool, therefore they will move downward. That is the logic in the North Hemisphere. Let us try to apply this logic here. Kuroshio current, they are warm, therefore they are moving upward. And Oyashio current, they are cool, and therefore they are moving down. Okay, cool currents, they are moving down, and warm currents, they are moving up. What is the logic? It is a simple logic. And then the logic is just the temperature difference. That's all. And then we are having a Brazilian current. It is warm current. Warm current, they must move towards cool region. Where is the cool region? It is in the Antarctic. Therefore, Brazilian current, they are moving downward. And Benguela current, they are cool, therefore they are moving towards equator. And Humboldt, they are cool, therefore they are moving towards equator. And West Australia, they are cool, therefore they are moving towards equator. And then you can easily plot whether they are clockwise or anti-clockwise by just doing a guesswork. To attempt some MCQs. Okay, upward and downward moment of ocean water is known as, it is known as tide. Everyone knows. If the question does not mention energy, don't tick mark wave, and if the question does not mention direction and path, don't tick mark current. Next question: spring tides are caused by, see, spring tides, they are caused when Earth, the moon, and sun, they are in the same direction. Remember, spring and neap, they are caused due to gravitation only, but spring, you are dragging it in the straight direction, therefore they must be in the straight. And neap, Earth, the moon, and sun, they are in the perpendicular direction. One more thing is that spring tides, as you have seen, they occur two times. As you saw, it occurs when there is full moon. When full moon occurs, when the sun and moon are on the same side, then the tidal bulge, it is at the max peak. Okay, but you also know one more thing: the straight line case is also possible when moon is on the other side. This other side, it's called new moon. That side, when moon was on that side near the sun, it is called full moon. During new moon, there will also be tidal bulge. Here also there will be tidal bulge, right? But comparative to the full moon, the new moon tidal bulge, it is less. So when sun and earth, they are pulling from the opposite direction, then the tidal bulge is there. That is also spring tide, but the bulge is comparatively less than the tidal bulge that you see when in case of a full moon, where the tidal bulge is at maximum. Sun and moon, they are dragging a lot, so the tidal bulge is maximum. Okay, now the first option, second option, spring tides are caused as a result of moon and sun pulling the earth gravitationally in the same direction, and the second it's saying opposite direction. Okay, both are spring tides, but geographically speaking, spring tides, they are called the maximum magnitude tides, maximum tidal bulges. Therefore, maximum tidal bulges happen when both are in the same direction. So if you want to tick only one option as correct, then you need to proceed with A. But I think when the MCQ is multiple options correct, then I will tick both of them. Okay, the distance between the earth and moon is minimum when the moon is in, as I said, epogee implies apart. Okay, gi is for moon and helion is for sun. Okay, gi, moon. Therefore, apogee implies apart. But they're asking minimum, that is perigee. Okay, perigee, it is minimum. Option B. Next, the earth reaches its perihelion in, I think I've said you that July is the month of flowers, and that's a breakup song. I said you. Okay, therefore, epilion, I will mark July, maybe 3rd July, and 4th January, perihelion. Okay, it's actually four. Okay, and this is a 3. Okay, the dates really doesn't matter. But anyways, think like four lovers are breaking apart in the month of July. Apart, okay, Aphelion. Okay, and then Perilion, it's 3 July. 3 January, 3 January, not July. Okay, 4th July and 3rd January. Now they're asking the Earth reaches its perihelion in perihelion, it's in the January. So option D. Water waves. First question. Waves are the movement of moment of energy across the water surface. Okay. Where do waves in the ocean get their energy from? Winds. Winds. What are tides? Tides are the rise and fall of oceanic levels. Rise and fall of oceanic levels. Next, how are tides caused? Tides are caused by moons and sun's gravitational pull, and also it can be due to centrifugal force. So this is how tides are caused in general. Now let us try some MCQs. Consider the following characteristics of cloud type. They are born through convection, only cloud type that can produce hail, thunder, and lightning. Okay, rain. Basically, they're rain-bearing clouds. Without even seeing the option, I can tell that it is cumulonimbus. Option B. Okay, next question. With reference to atmospheric pressure in the lower atmosphere, consider the following statement. Atmospheric pressure increases rapidly with height. See, as you go down, the pressure will increase. Why? Because there is a lot of air mass above. Therefore, the atmospheric pressure at the bottom will increase. But they're saying as you go above, it will increase. That's wrong. As you go above, atmospheric pressure will decrease. Therefore, option 1 is wrong. Option D is correct. The next question, in context of the composition of atmospheric gas in dry air, which among the following gases is the most abundant? See, there are permanent gases and variable gases. What are variable gases? Greenhouse gas. Why? Because see, greenhouse gas they might increase, decrease due to human activities and natural phenomena, etc. Therefore, greenhouse gases are called variable gas. Example: carbon dioxide, methane, nitrous oxide, ozone, chlorofluorocarbons. And what are the permanent gases? You have nitrogen, oxygen, argon, and etc. So nitrogen, it consists of 78%, and oxygen 21%, and argon 0.9%. Okay, these are the percentages that you need to definitely know. And the carbon dioxide percentage also is 0.04. Okay, now when they're asking me the most abundant, if the option has a nitrogen, everyone would take it right, but it's not there. If there is an option oxygen, everyone would take it right, but that is also not there. So the third option is of course argon, that is 0.9. So option D, argon. You know what does UPSC do? UPSC will mark the easy options in the last. Option D, argon. Okay. With reference to water vapor in the atmosphere, consider the following statements. In tropical region, water vapor constitutes about 25% of air by volume. See. This is our equator. Okay. Near the tropical areas, the water vapor is 4% of air by volume. Okay. And as you go towards the poles, the amount of water vapor in the atmosphere, it decreases to less than 1%. Okay, that is the logic. So when they are saying that in the tropical region, water vapor constitutes 25% of the air by volume, that will be wrong. Okay, 25% बहुत ज़्यादा होता है. Okay, and the total water vapor content in the atmosphere generally decreases from equator towards the poles. That is correct. Option 2 is correct, and 1 is wrong. The infrared waves are absorbed by the water vapor present in the lower atmosphere. See, do you remember carbon dioxide ka scene kya hai? It is a greenhouse gas, and whenever there is incoming, it was transparent, and whenever there is this outgoing ray, carbon dioxide behaved opaque, and it absorbed all the outgoing terrestrial radiation. Okay, but this was for what? This was for IR. Why? Because IR का wavelength बहुत ज़्यादा है. क्या होता है कि IR का wavelength बहुत ज़्यादा है, so that will trap the wavelength. IR waves, they will be trapped easily. They'll be easily trapped by the greenhouse gas. But if you see UV rays which have comparatively lesser wavelength than IR, then what is going to happen is that let's say it is carbon dioxide, even for the outgoing, it is not that opaque. It will only absorb some amount of light, I mean some amount of UV ray, and the rest will be released into the atmosphere only. So it will allow transmission, क्योंकि UV का wavelength comparatively कम है. Okay, therefore they can easily go. बट IR का वेवलेंथ बहुत ज़्यादा है, तो वो लोग नहीं जा पाएंगे, यहाँ पे अटक के रहेंगे. दैट्स द डिफरेंस. ओके, इफ यू वांट टू रिकॉल द order of a wavelength, see, this is TV, so I will take it as a radio. And from radio you're getting some microwaves, and after that you have seen some red IR, and after red you have seen visible, I mean TV became visible, so it's a visible, and that XYZ इसको गामा से डिनोट करेंगे. So that is how it works. So basically radio waves, wavelength of radio greater than radio, micro, and then IR, visible के बाद क्या, UX, gamma. Okay, this is the length. U implies UV. So wavelength of IR is greater than wavelength of UV. That one you need to know. Now they are saying the infrared are absorbed by water vapor. See, no matter which greenhouse gas it is, whether carbon dioxide or water vapor, the phenomenon is the same. IR waves are absorbed by the water vapor present in the lower atmosphere. Now IR waves का wavelength ज़्यादा है, तो wavelength ज़्यादा है तो क्या होगा? Terrestrial radiation. This greenhouse gas, it is going to absorb that terrestrial radiation. Okay, that's all. Okay, if it is UV, then of course a certain wavelength might be absorbed, but the other it is transmitted. Okay, so greenhouse gases, they are transparent to incoming radiation, transparent to incoming IR, but opaque to outgoing IR. Okay. What? Okay, I'll ask you one question. The incoming rays, are they short wave or long wave? See, incoming rays, they are short wave. Incoming waves are short wave, outgoing or long wave. See, for coming, you can come with a force. You are coming with a force. Therefore, you are easily transparent. Think it like that. You are coming with a force, so you are easily transparent. But when you are going out, you became opaque. You can't go easily. So that's a long wave. That's very long for you. Okay, incoming and outgoing. Okay. Remember it like this. Therefore incoming waves are short waves and outgoing terrestrial radiation is a long wave. बहुत लंबा रास्ता जाना पड़ेगा, क्योंकि लंबा रास्ता क्यों? क्योंकि ग्रीन हाउस गैसेस ओपेक है, बाहर जाने के लिए बहुत लंबा रास्ता है. That's why it's long wave. Okay, incoming it's short wave. Now infrared waves are absorbed by the water vapor present in the lower atmosphere. This is correct. Terrestrial radiation is absorbed by the lower atmosphere. So option A is wrong. 2 and 3 are correct. Therefore option C is the correct match. They are asking about occluded fronts. See, you know there are different types of front, right? When cold moving air, when it meets warm air, what is going to happen? A cold front will be created, right? Similarly, when warm moving air, it meets cold air, a warm front will be created. And the next phenomenon is something different. Okay, when cold air meets warm air, a cold front will be created. And similarly, there is warm air. This air is also trying to meet this cold air. So a warm front will be created. तो इन दोनों के बीच में झगड़ा हो गया, कौन ज़्यादा बड़ा है, कौन ज़्यादा बड़ा है, ठीक है? In the end, what is going to happen? This cold air, it is denser. So therefore, it will push this warm air. It will push, and since it is denser, it should go down. And since this is warm, it should go up. Therefore, cold air will push so hard that this warm moist air will be moved away from the ground. Okay, this warm moist air will be lifted away from the ground, lifted above the land surface. So that is called occluded front. Okay, now we have seen three fronts. When cold moving air meets warm air, that is cold front, and you have seen warm front. That is when warm moving air meets cold air. And the third is when cold air meets warm front, warm air, and warm air meets a cold air. Finally, what's going to happen? That warm air, it will be lifted above, right? That is called occluded front that you have seen. And the fourth one is stationary front. That is the front which is not even moving but is stationary. Now let us see the next question. With reference to the structure of atmosphere, consider the following statements about ionosphere. Now do you remember where ionosphere stay? It stays in somewhere in thermosphere and mesosphere, right? It stays somewhere in thermosphere and mesosphere. See, what is the structure? Troposphere. Do you remember the numbers? Numbers are very important. I think it's 10, 50, 80, 400. Okay, these are the numbers you need to memorize. Okay, troposphere, stratosphere, mesosphere, thermosphere, and exosphere. Okay, just remember 10, 50, and then 80, 400. Just multiply with 5 always, na? ट्राई टू 10 को 5 से मल्टीप्लाई करना, क्या हो जाएगा? 50 बन जाएगा. रिमेंबर 80 नेक्स्ट. 80 को 5 से मल्टीप्लाई करना, क्या बन जाएगा? 400 बन जाएगा, राइट? सो ट्राई टू मेमोराइज 10 एंड 80 एंड जस्ट मल्टीप्लाई विद 5 5, तो मिल जाएगा 50 एंड 400. ओके, दिस इज अ गुड वे ऑफ मेमोराइजिंग. नाउ लेट्स सी ट्रोपोस्फियर. ट्रोपोस्फियर, as height increases, the temperature will decrease, general. But what happened in the stratosphere? As height increases, the temperature will decrease. Why? Due to temperature will increase. The opposite works. That is called temperature inversion. Right? There is temperature inversion in the stratosphere because there is a ozone layer. And what happened in the mesosphere? As height increases, the temperature, it will decrease, general. But what happened in the thermosphere? Lot of the ions, majority of the ions, they are in the thermosphere. Therefore, as height increases, again it works in an alternative phenomenon. For example, decrease, increase, decrease, increase, decrease. So that is like normal. Okay, now the temperature will increase due to presence of ionosphere. Lot of ions are there. That is why the temperature will increase. And when you go to the exosphere, as height increases, the temperature will decrease. So this general phenomenon keep on happening. Okay, the only thing that you need to remember is that see, they work on alternative basis, and in the stratosphere it is because of ozone, and in the thermosphere it is because of ions. That is ionosphere. Now they're asking questions with respect to ionosphere. The radio waves transmitted from the earth are reflected back to the earth by this layer. That is absolutely correct. Why? See, ionosphere, there are a lot of radio stations, if you remember. So they are using this ionosphere, and they are transmitting. How do you think the signal will go from one radio tower to another radio tower? So they are using this ionosphere very effectively. Like the radio waves will be transmitted to the ionosphere, and that ionosphere, it will reflect to this another radio tower. So that is how communication happens. So the radio waves transmitted from the earth are reflected back to the earth by this layer. That is correct. The lowest temperature in the earth's atmosphere are recorded by the ionosphere. अब इसके बारे में तो मैं नहीं बात कर पाऊंगी. But one thing I know, ionosphere में temperature बढ़ेगी ions की वजह से. But they're saying lowest temperatures are recorded. That will be wrong, right? Ions की वजह से temperature बढ़ेगी और ozone की वजह से temperature बढ़ेगी. यही दो layers है जिसमें हमने ये देखा है कि temperature बढ़ेगी with increasing height. So that will be wrong. As first option will be correct, second option will be wrong. Third option, the interaction between the charged particles from the sun and the molecules of air present in the ions lead to the creation of auroras on earth. See, I know one thing for sure is that auroras are created by the magnetic field of earth and sun rays. Charged particles तो होगा ही, and maybe the charged particles that earth magnetic field it might have created due to ions in the ionosphere, that can also be there. So I cannot really ignore this option. The interaction between the charged particles of the sun and the molecules of the air present in the ionosphere leads to the creation of auroras on earth. That's correct. When they actually interact, see, this is the earth magnetic field which was created due to ionosphere only, and they are the charged particles, and whenever they are the sun rays, whenever they are reacting with the magnetic field, they are creating auroras. Okay, so option 3 will be see, 1 is correct, 2 is wrong, 3 is correct. Option 1 and 3 B. Even if you eliminate 2 now, I think you will reach option B. With reference to temperature inversion, consider the following statement. It refers to phenomenon where the air temperature decreases with increasing altitude. Instead of increasing, see. This is a normal phenomenon, okay? And they are saying that it refers to this phenomenon. There only first option goes wrong. Option A is wrong. Next, a shorter winter night with overcast skies and strong surface winds provide ideal condition for temperature inversion. See, I know that it's long winter night, not short winter night. And next, therefore, there only this option will go wrong again. And strong surface winds. See, you must have calm air. They are the ideal conditions for temperature inversion that you have already studied. Therefore, this is also wrong. Therefore, option B will go wrong. Over the polar regions, temperature inversion is normal throughout the year. See, polar areas we have already studied. It is cool near ground. That there you will see ice. And as you go above, the temperature will increase. Okay, therefore this is actually correct. That also you have studied that in the polar region you will see temperature inversion throughout the year. Okay, option 3 is correct. Option C. With reference to tornado, consider the following statements. They generally occur in the middle latitudes. I remember only one thing about tornado. See, I know that when I know thunderstorm first. So thunderstorms, they are caused by intense convection. Convection is a vertical transfer of heat, right? So when there is intense convection on moist hot days, then thunderstorms will be created. That I know. If the thunderstorm reach Earth, then it is called as tornado. Okay, and that is called tornado. That's all I remember. And that tornado, if it is on the sea, if it is over the sea, then that tornado is called as water spout. This is what I know about thunderstorm, tornado, and water spout. Now they're asking me a question. Okay, they generally occur in the middle latitudes. Yeah, that is very true. They are characterized by violent spiraling column of air with very low pressure at the center. See, that's also true. That is what we studied about the tornado, right? This is low pressure. So when there is low pressure, all the winds they gather from high pressure area, and so that is how the concentration will maintain here, and you will see the spiral wind here. Okay, so the a truck of storm, it is like a truck of elephant with great force that hit the earth at very low pressure in the center. So that truck, it is choosing the areas of low pressure where it is very hot, and this light storm, it is getting attracted to it and hitting it. Okay, that is thunderstorm. That thunderstorm which hit the earth is called tornado. Basically, tornadoes are from severe thunderstorms, sometimes spiraling wind descending like a trunk of elephant with a great force, which is hitting the low pressure areas and creating massive destruction. Okay, so they are characterized by violent spiraling column of air with very low pressure at the center. So option C. Tornado की definition में ही है low pressure at center. Okay, now see the definition of tornado. A tornado is a violent localized atmospheric phenomenon that develops when severe thunderstorms, particularly cumulonimbus clouds, they hit Earth. Okay, it appears as rapidly rotating funnel-shaped column of air extending from the cloud base to the Earth's surface with extreme low pressure at its core. Okay, यहाँ पे extreme low pressure है, thunderstorm है ना, तो clouds को connect करके यहाँ पृथ्वी तक connect होती है. Okay, tornadoes are short-lived but very highly destructive. That you need to know. Why are we saying tornadoes are short-lived? क्योंकि इसका speed बहुत ज़्यादा है. अगर speed ज़्यादा है तो जल्दी मरेगी. याद रखना. Okay. अगर स्पीड ज़्यादा है तो जल्दी क्यों मरेगी? क्योंकि ना एनर्जी पूरा वहीं पे खत्म हो जाएगा. दैट्स व्हाई यू नो व्हेन रेनफॉल इज वेरी हेवी, it lasts for shorter period of time, and when rainfall is very low, when it's drizzling, it will continue for a longer period of time. So that's how it's different. With reference to dust particles, they're asking certain things. The concentration of dust particles in the atmosphere is generally higher in subtropical and temperate regions than in the equatorial regions. Do you remember what we studied about dust particles? We have taken Earth and we have split it, if you remember. 0 degrees equatorial low pressure belt, and next 30 degrees subtropical high pressure belt, 30 degrees, 60 degree, what is that? Temperate low pressure belt, and 90 degrees, it is a polar high pressure belt. Now, what did we notice? We noticed that the dust particles are high in the middle areas, in that subtropical high pressure belt and temperate low pressure belt, and there are no dust particles in polar high pressure belt and equatorial low pressure belt. This is what we studied. Okay. Now the question is saying that the concentration of dust particles in the atmosphere is generally higher in the subtropical and temperate regions than in the equatorial regions. Okay. This is correct. They act as hygroscopic nuclei around which water vapor condenses to produce clouds. That is also correct. Dust particles around this water vapor condense and produce clouds. So option C. Suppose there are two cities in India. If the humidity in city A is at 52%, while in city B it's 84%, assuming the air temperature is same in both the cities, in this context, consider the following statements. So basically, they have taken two cities and they said that city B is having higher humidity, but still the city A and city B, they are having the same temperature. Now the options are saying that people in city B will experience more sweating than city A. That's true because the humidity is high in city B. And next, the perceived temperature in city B is relatively higher. See, because there is a lot of humidity, definitely the perceived temperature in city B will be higher than A. So option C. The next question is about isotherms. See, isotherms I explained you very clearly. This is the month of January and this is the month of July. And what did we see? We have seen this North America, South America map, Europe map, and Africa map, etc. And this is the equator that we have seen. And what did we notice? We noticed that northern hemisphere, it is having more landmass compared to southern hemisphere. And next we have seen that during winter, the land cools faster. See, during winter or summer, whatever it is, the land, it takes the effect more compared to oceans. Why? Oceans are having higher specific heat, so they will heat slowly. So for example, in the January, it is very cool. Therefore, land becomes more cooler. It cools very quickly compared to oceans. So therefore, lands, they are very cool compared to oceans, which are warm. Now, in the month of January, since the land is cool, let's say isotherm, we are drawing it here. But since the water is very warm here, they need to go to polar areas. They need to deflect towards poles to maintain that isotherm, same equal temperature. So the isotherm will go like this in the ocean areas, and when it reaches landmass again, it will become cool. So it will go down. So that is how this isotherm work. Okay. So they deflect towards north in the oceans, and they deflect towards south in the landmass in the northern hemisphere. What happens in the southern hemisphere? In the southern hemisphere, what is there in the month of January? In the month of January in southern hemisphere, it is summer. Therefore, land is hot. What about the oceans? Oceans, they are cool. Then okay, this landmass is hot. Now, what is going to happen? Do they need to deflect below or above? Since the landmass is hot, it needs to maintain hot temperature. And which side is hot? Below or above? Above. Near the equator, it is hot. Therefore, they will again deflect towards the north. So therefore, whether it is northern hemisphere or southern hemisphere, in the end, the isotherms are going to shift towards the north. Okay, towards the north in the ocean and towards the south in the land mass. This is the concept that you need to know in the month of January. And what happens in the month of July? Since the land mass, since the oceans take longer time to go back to its original position, so even in the month of July, they are still maintaining that warm temperature because July is anyhow warm, right? So they might be cool, but again, see, they are maintaining a relatively normal temperature in the month of July, etc., June, July, and then the land mass, it is becoming hot. So that temperature and this temperature, they are being matched. Summer की time है तो तब तक तो वो गर्म ही है, and then ऐसा situation है कि this temperature, it is becoming equal to land mass, and land mass, it is becoming hot. Initially it was cool in the month of January, but as soon as it reached July, it became hot. The isotherms are almost parallel. Okay, in the month of July, the isotherms are almost parallel. So that is how it works. So they don't ask for July, they will always ask for January. So in January, northern hemisphere, the isotherms bent equatorward. Isotherms bent equatorward while crossing landmass. See, that's correct, because in the northern hemisphere, isotherms bend equatorward. That means southern. And as they go poleward, they go poleward as they move through the ocean. Okay, southern. This is how it works. When they are on the landmass, they go southward. Equatorward, and when they are in the ocean, they go poleward. That is not. Option A is correct. In January, the air over the oceans is warmer than over the landmass in the northern hemisphere. That is correct. Oceans are warmer than land masses. Option 2 is also correct, and 2 is explaining 1. Option A. The difference between extratropical cyclone and tropical cyclone. You know what happens in the tropical cyclone? The water molecules over the sea, they go from high pressure area to low pressure area, and they concentrate somewhere in the low pressure area, and that warm air that raises above, and it leads to formation of cyclone. That is tropical cyclone. And there might also be formation of cumulonimbus clouds, and sometimes it precipitate also. That is tropical cyclones. But extratropical cyclone, it is due to clear frontal formation. Let's say there is a cool air, and you can see the cool front here, and there is also warm moist air. When cool air reacts with the warm moist air, the warm air, it raises above, and after a time, what's going to happen? This is a cool front, okay? This is warm air. So somewhere here, low pressure point is going to form, and that low pressure, the warm air at the low pressure, it will raise above, and it will lead to the formation of cumulonimbus clouds. Okay, that is about extratropical cyclone. And if you see the zone below the low pressure point, that looks like an inverted V shape. That's why we are calling extratropical cyclone look like inverted V, whereas tropical cyclone look like a V shape. Okay, as you see the low pressure and the warm air raised above, that is a V shape. But extratropical, since there is a frontal system below, the low pressure raises to a certain point, and from there the warm air raises above. Okay, that is how extratropical cyclones look like. Okay, therefore, as you can see, they can originate both over land and sea. See, the cool air can meet warm air. It can happen either above the land or either above the sea. Anything can be there. So they can happen either above land or sea. But tropical cyclones, they happen only over the sea. Okay. Over the sea, you will have warm water molecules, right? Which are moving towards the low pressure area, right? That must be over the sea only. And what is the direction? See, if you draw the diagram, you know, right? This is a equatorial low pressure belt. This is equatorial low pressure belt. This is subtropical high pressure belt, and you are having a temperate low pressure belt, and polar high pressure belt, right? So you know where are easterlies? This is easterlies, right? Why they are easterlies? Because they are originating from east, and you know the above zone. You know the direction, right? They are westerlies because they are originating from west. Okay. What about the above? They are again easterlies, but they are called polar easterlies. Therefore, the westerlies, they happen in between subtropical and temperate low pressure. Somewhere here there is westerlies. Therefore, when a question arises, what about extratropical? They are going to originate in this middle latitude zone. Therefore, they are westerlies. They originate from west and go towards east. Okay. What about the tropical cyclones? They originate in the east, move towards the west. They are tropical cyclones. Okay. Now you understood about tropical and extratropical. Let us see the question. With reference to extratropical cyclone, consider the following statement. Unlike the tropical cyclone, they can originate both over the land and sea. This is correct. And they derive their energy from horizontal temperature differences in the atmosphere. That is true, because cool air and warm air, there is a frontal system, and this frontal system is having horizontal temperature differences, right? That is how they are deriving their energy. So this statement also looks correct. The third statement is saying that the wind velocity in the extratropical cyclone is much higher than the tropical cyclone. This question is very tricky because people will think that extratropical यहाँ पे है तो speed ज़्यादा होगा कुछ भी. See, tropical cyclone, they are originating over the ocean, and they are mainly guided by the high temperature, right? That is how it created, right? And the tropical cyclones, they are more regular in nature. Regular in the sense कि they are usually formed during late summer. Okay, late summer. Why? Summer season तक heat करने में ही चला जाएगा. जब late summer होगा उस टाइम पे बहुत गर्म हो चुका होगा कि पानी अब raise हो जाएगी ऊपर. So they occur in the late summer. Okay, and extratropical, they are irregular in nature. कब आएगा कब चला जाएगा किसी को पता नहीं. So their wind speed, it is very high. The tropical cyclones, their wind speed is very high. Since they are fueled by higher latent heat, higher temperature and higher latent heat, therefore their wind speed is very high. Okay, so therefore option 1, option 2, and option 3, all 3 are correct, right? No, what is option C saying? Wind velocity in extratropical is much higher. No, that will become wrong. So option B. The next question, if the earth was without any atmosphere, which one of the following consequences would most likely be observed? Okay, the sky would appear dark even during daytime. See, the first option is saying that the sky would appear dark even during daytime. So, you know this Rayleigh scattering of light. So, what he said is that the sky, you are able to see it blue now. Why? The sky is black actually, right? It's dark. If you see over the moon, you will see, even if there is sunlight, you will see that sky is actually black because there is no atmosphere on the moon. That is why you are seeing it as dark. But on the earth, there is atmosphere. Therefore, due to the scattering of the light and all, the black sky, you are actually seeing it as blue sky, sky blue, right? That is due to Rayleigh scattering of light. Yeah, the sky would appear dark even during daytime. That's actually correct. Just like how it is on the sun, how it is on the moon, just like it, you will experience a similar pattern on the earth also. The next question is saying Earth would receive uniform solar radiation across all latitudes throughout the year. Uniform solar radiation is wrong. See, Earth is tilted, right? Earth is tilted actually. Therefore, of course, this subtropical, whatever it is there, this point is going to have higher insolation, and the insolation depends upon the tilt. So you cannot really say that there will be uniform solar radiation. Next, the propagation of sound waves will be extremely difficult. Propagation of sound waves. Does it require atmosphere? I think yes. See, I studied about sound waves. I know that they need a medium to transfer. So without medium, sound waves cannot transfer. So if there is no atmosphere, then how can sound waves transfer? It is not possible. Sound waves cannot travel in a vacuum. Therefore, option 3 is correct, and option 1 is correct. 1 and 3, option C. With reference to spatial distribution of insolation, consider the following. The maximum amount of insolation received at the Earth's surface is observed over the subtropical desert region rather than over the equatorial belt. This is what you actually studied, okay? That what did you study? You studied that Earth has a tilt, therefore a subtropical belt, it will usually receive more insolation. Therefore, the desert regions of the subtropical mainly they are receiving the maximum insolation. That is what this option is saying. The maximum amount of insolation received on Earth's surface is observed over subtropical desert region rather than over the equatorial belt. First option is correct. Second option, at the same latitude, the amount of insolation received over continents is generally higher than that received over the oceans. That is also correct because water has more specific heat. Therefore, land heats faster. Since water specific heat is high, it heats slower. So the maximum amount of insolation received over continents is generally higher than over the oceans. So option C. Okay, next. So the next question, Hadley cell. See, from the low pressure belt, warm air rises. It moves, it falls, and then it diverges, and again it rises, and again, what is going to happen? Yeah, this split, and this is polar high pressure belt. I think low pressure belt say this is polar high pressure belt, ना? तो वहाँ पे क्या होगा? High pressure. Okay, that is how it works, right? What is this cell? This is Farrell cell. Hadley, Farrell. Which one is Hadley and which one is Farrell? Just remember this trick that hot water rises near equator. Na? Hot for H for Hadley. So this is Hadley. And next, the other would be Farrell, obviously. And the other cell would be polar. Okay. Hot water. Remember the trick, hot water rises. Now let us see the question. The question is asking in the Hadley cell thermal circulation, air rises up and finally descends. Finally descends where? So finally it descends in the subtropic. What are the options? Intertropical convergence, no. Doldrums, no. Subtropic high pressure cells, that's correct. Option C. Okay. With reference to heat budget, so heat budget, right, just whenever you see heat budget, draw this diagram. Between 40° north and 40° south, you will have heat surplus. That is, there will be a lot of insolation rather than outgoing radiation, and whereas above 40° north and 40° south, you get to see heat deficit. So what's going to happen? The nature, it is going to transfer this surplus heat by warming up, and it will transfer this heat to low pressure high pressure belt. Okay, low pressure to high pressure belt, right, subtropical high pressure belt and equatorial low pressure belt. So that is the natural phenomenon. Anyways, if they're asking you the heat budget, of course the budget, the surplus is highest in between the 40° north and 40° south. Let us see the question. Over a long period of time, the amount of heat received by the earth in the form of insolation equals the amount of heat lost by the earth through terrestrial radiation. That's correct. Over a long period of time, if you take that budget will be same. So amount received by the earth in the form of insolation must be equal to the heat lost through terrestrial radiation. A long period में तो सही है. And then more than 1/4 of the incoming solar radiation reflected by the clouds before it reaches the earth's surface. Okay. Is this correct? Might be there, but this 1/4. Okay, I don't know about this 1/4. Whether it's more than 1/4 or less than 1/4. But the focus area is definitely this, but this is a very broad statement. Okay, what is the opposite statement of this? Less than 1/4 of the incoming solar radiation is reflected back. इसका एक्सट्रीम देखेंगे, अगर 1/4 से ज़्यादा इतना भी है तो ये स्टेटमेंट गलत हो जाएगा. नो, देयर इज इनकमिंग सोलर रेडिएशन 100%. तो 100% में ये बोल रहे कि 25% रिफ्लेक्ट हो जाएगा. अगर ये 1% 26 भी आएगा तो ये स्टेटमेंट गलत हो जाएगा. तो लग रहा है ना कि दिस ऑप्शन इज करेक्ट बिकॉज मोर देन 1/4. दैट लुक्स very correct. More than 20, 1/4 implies 20. It can be 25 or 26 because cloud formations we are not sure. There are many clouds. There can be even more clouds. So the statements look naturally correct. Therefore, I will take it correct. There is generally net radiation surplus near the polar regions of the earth. They are saying there is a surplus in the polar region, but I said there is deficit. Okay. Yeah, polar regions, of course, outward radiation is greater than insolation. Therefore, there is heat deficit here because a lot of days they are going back. And when they are asking net radiation surplus, they are using this word net. So they are saying that outgoing. I think what is net radiation surplus? This is what you need to know. See, one thing you need to know, when they're using this net radiation surplus, now you're not sure what is this. Is it outgoing minus incoming or incoming minus outgoing? But whenever you're talking about heat budget, radiation, it can be incoming radiation minus outgoing radiation, right? That is the heat. So when they're saying net radiation, don't take it as outgoing minus incoming. That will create confusion. Take it as incoming minus outgoing. That will be the heat budget, and that is how you plotted this diagram. Therefore, they are saying this net radiation, it will be high. Implies they're saying incoming radiation is greater than outgoing. That means they're saying it will be surplus. Net radiation is nothing but heat surplus. But it is not heat surplus, it is heat deficit. Therefore, statement 3 is wrong. Option A, 1 and 2. With reference to the variation of temperature over the land and sea, what is the primary reason that large water bodies heat up and cool down more slowly than land surfaces? See, the easier options are always kept at the end. The reason that you already know, because water has high specific heat. right? That is the main reason why land heats faster than water. Okay, see the fourth option. Water has higher specific heat capacity compared to land surface. With reference to tropical wet climate, consider the following. It is characterized by high temperature throughout the year with low annual range of temperature. Low annual seems to be wrong because they're saying tropical wet climate, high temperature say here, but low annual range. That is why when you go in a generalistic sense, you will always attempt wrong. So remember the world climate and climate change topic where you studied about Köppen scheme of climate classification. So do you remember the Köppen scheme of climate classification? For that, you will write it from A, B, C, D, E. You will not write capital F and you will directly write H, okay? And A is tropical humid, B is subtropical dry, C is warm temperate, and D is cold temperate, E is cold polar, and H is highland. Can you try? Tropical humid, subtropical dry, warm temperate, cold polar, and highland. So this is A, B, C, D, E, H, okay? And then you have seen what you saw S, W, etc. Etc. alphabets or letter code. S stands for summer and dry. W stands for winter, dry. Okay, M stands for monsoon, right? M stands for monsoon. That is a seasonal reversal of wind. And F stands for rainfall. This is what you can guess. Small f stands for rainfall or wet condition. Capital F, it stands for frost, and T stands for tundra. Okay, that is SWMFFT. These alphabets you can easily guess. Summer dry, winter dry, monsoon, rainfall throughout the year, also called as wet. F implies frost or frigid, and T implies tundra climate. And next, tundra implies cold, polar. Okay, and next we have capital S and capital W. So they are different from summer dry and winter dry. They are small s and small w. If they are capital S and capital W, then it will be semi-arid. Capital S stands for semi-arid or steppe. Do you know how this semi-arid or steppe look like? This diagram, can you see? So this is semi-arid, okay? Here you can see little bit of grassland, but this grassland can be slowly converted into complete desert, okay? Semi-arids are basically the transition zone which are getting converted into desert. And arid regions, they are desert, okay? Semi-arid, it is also called as steppe. So now semi-arid, capital S stands for semi-arid or steppe, and W, capital W stands for arid or desert, okay? And you have capital K and capital small, this can be capital K or small h. I think it's small k and small h. Yeah, this is small k and small h. Small k stands for middle latitudes and H stands for lower latitudes, okay? Middle latitudes and lower latitudes. FA stands for summer warm, and FB stands for summer, it can be warm and cool. A is warm, B is both warm and cool, okay? That is different from F. So if it is just F, it is rainfall, but if it is F combined with some alphabet A, it is summer warm. Okay, it will become summer warm, not rainfall, okay? It is summer warm, and if it is FB, it is summer warm and cool. Now you understood? A, tropical humid, B, subtropical dry, C, warm temperate, D, cold temperate, E, cold polar, H, highland. And next, you have these alphabets which are easy: summer dry, winter dry, monsoon, rainfall throughout the year or wet, frost or frigid, tundra, and capital S and small capital W, they are different from small s and small w. Capital S is semi-arid or steppe, capital W is arid or desert. And also this summer dry, it is different from summer warm. For summer warm, we are not using small s, we are going to use FA. Okay, summer dry, it is different from summer warm. For summer warm, we need to go with the alphabet F combined with A. And if you want both warm and cool, then it is FB. Okay, this is the Köppen classification, and we have seen a table. Okay, where did we see tropical wet? What is the alphabet code for tropical wet? Since it is tropical, you need to check this. Which code will it go with? See, since it is tropical, of course, it must go with alphabet code A. So I will write it as A first, and again it is saying wet. Wet implies this, right? F. Therefore, I will go with the alphabet F. What kind of climate tropical wet is? As you know, with the name only, you can guess certain things, right? Since it is tropical, therefore temperatures are very high. I mean, it is characterized by high temperature throughout the year and low annual range of temperature. So remember, they are talking about low annual range. Annual range implies, see, it is either 30 or 40. We are living in tropical areas. We know, right? The temperature, it is almost in the same range. So, low annual range of temperature. Option 1 is correct. Convectional rainfall is the most dominant form of precipitation in this year. See, there is F. F stands for rainfall. So, that is also correct. The third is climate experiences a pronounced dry season due to the seasonal reversal of wind. Again, for seasonal reversal of wind, we are having this monsoon. What is monsoon? Monsoon is nothing but seasonal reversal of wind. Okay, that is something you need to know. Seasonal reversal of wind is monsoon. Therefore, this alphabet, is it having M? No, it is not having. Tropical, wet. That's all. Therefore, this is for the alphabet code M. This option goes wrong, and option B, 1 and 2. The next question, the Earth's surface receives most of its energy from incoming solar radiations in short wave. As I said, short wave ठीक है, लेकिन बाहर जाने में बहुत लंबा रास्ता जाना पड़ेगा. That is why it is long wave. This is what I said, right? This is the code. The reason they are saying is that the surface temperature of sun is far higher than that of Earth. This statement is correct. Anyone can say that surface temperature of sun is higher than Earth, but no one knows whether this is the right explanation for this. But lot of people, they are very confused. Okay, how temperature can determine the wavelength? I mean, one is short wavelength, another is long wavelength. How can it? See, everyone knows, but no one thinks in depth. You know, Planck's law equal to hc by lambda. So sun, it is hot, so it is emitting higher energy. If it is emitting higher energy, as I said, the wavelength will be low. Implies what? Hotter bodies are emitting light with shorter wavelength, right? Therefore, sun will emit short wavelength. Sun will emit light which is having shorter wavelength compared to Earth. Earth will have longer wavelength. The waves, they will have longer wavelength when they go back. Okay. See, that is the wavelength, and this is the wavelength of incoming, and this is the wavelength of outgoing. And outgoing, they are blocked. They are blocked by greenhouse gases. This is the logic. So the surface temperature of sun is far higher than the earth is actually correct. That is the reason why your wavelength is small. Okay, that is why incoming insolation it is having shorter wavelength. Okay, therefore 1 and 2 are correct, and 2 is the correct explanation of 1, option A. The next question is really tricky because they are asking you on summer solstice in the northern hemisphere, which one of the following cities experience the longest duration of daylight? So to answer this, you need to know one little concept. समर सॉल्स्टिस के टाइम पे सबसे ज्यादा लॉन्गर ड्यूरेशन कहाँ पे होगा? ट्रॉपिक ऑफ कैंसर, राइट? ट्रॉपिक ऑफ कैंसर पे लाइट ज्यादा होगा, दैट इज ऑब्वियस. ट्रॉपिक ऑफ कैंसर पे तो लाइट ज्यादा होगा बिकॉज सी दिस इज द ट्रॉपिक ऑफ कैंसर, तो यहाँ पे लाइट ज्यादा होगा, आई एग्री. लेकिन ज्यादा देर तक कौन चलेगा? इट्स लाइक द रीजन्स विच आर हियर, राइट? These regions they are going to experience continuous daylight. So the northern pole areas, they are experiencing the daylight on the entire day. I mean, entire 24 hours mostly. Therefore, you need to check such areas. First, you need to check the areas which are close to northern hemisphere. क्योंकि ये tropic of cancer areas ना, they are going to have day and night due to rotation. But even after rotation, since the earth is tilted, they are always going to experience daylight. This is a fact. So now you need to identify which country. I mean, the location of the cities. First, Rome. Where is Rome located? See, they are basically the capital cities, and you need to have minimum knowledge of the capital cities of all the countries of the world. So, Italy, capital Rome; Norway, Oslo; Lisbon. I mean, Portugal, capital Lisbon; Portugal, Lisbon; Norway, Oslo; Italy, Rome. Okay. Now, if I remember the Europe map, Italy is somewhere here, and Portugal, Spain, France ऐसे start होगी. तो Portugal नीचे है, Italy भी नीचे है ना? अब ज़्यादा सिंगापुर तो southern hemisphere में है. Now बचा हुआ Norway. So Norway is little bit in the north area. Okay. Therefore, I will mark Norway B as correct. This next question is very, very tricky. See, the soil in the tropical rainforest is rich in nutrients. This is very, very wrong. People will really think that okay, वहाँ पे ज़्यादा बारिश हो रही है तो nutrients ज़्यादा होगा. नहीं, it is not rich in nutrients. In fact, due to excessive rainfalls, वहाँ पे जो भी nutrients होना चाहिए soil पे, वो सब चला जाएगा. So there will be nutrients runoff. Tropical rainforest soil is very poor in nutrients. Okay, this is what you need to know. The main reason that they say is it is due to acidic nature of soil and incessant rains. What I remember is like ज़्यादा बारिश होगा, so nutrients का runoff हो जाएगा. This is how I try to remember. Nutrients like potassium, calcium, etc. They are run away due to leaching. Okay. First option is wrong, so option will be D. And the second statement is saying high temperature and moisture of tropical rainforest cause dead organic matter in the soil to decompose quickly. Basically, if temperature is high, metabolic activity will be high. So the activity is high if temperature is high. Therefore, the decomposition rate it will be faster. Okay, they will be decomposed quickly. It will cause dead organic matter in the soil to decompose quickly. Decomposition rate is high. Whatever dead organic matter is there, you are having organic matter which is dead. Okay, that will be decomposed quickly. Why? Because the temperature is very high, and also there is moisture which is supporting the decomposition rate. Therefore, it will be decomposed quickly. This statement 2 is correct. With reference to structure of atmosphere, consider the following statement: the thickness of troposphere is greater at the equator. This one you need to attempt for sure. Do you remember the layers? Troposphere, stratosphere, mesosphere, thermosphere, exosphere. I said you to remember 10 and 80, and I said to multiply with 5, right? Okay. ये 50 बन जाएगा, इसको 5 से मल्टीप्लाई करने से 400. So this is measured in kilometers. Okay. And next, this 10 kilometers is the average. The atmosphere height as you go towards the pole, it decreases. When you see the earth, the atmosphere height near the poles, it decreases. As you go towards the equator, the height will increase. Okay. What is the height near equator? The atmosphere, I think it's around 18 kilometers, and around pole, at the pole it is 8 kilometers. Okay. Somewhere I'm taking it as average, in average 10 kilometers, that's all. I'm multiplying with 5, it will become 50, and with 80 it is 400. So this is how I memorized. Okay. Now they are saying that the thickness of troposphere is greatest at the equator, which is correct. The atmospheric pressure is highest at the equator and lowest at the pole. Okay, see, there are actually 3 statements. That means first statement is definitely correct, and you need to see whether this, whether 2 and 3 are they explaining this or wrong. Okay, the atmospheric pressure is highest at the equator and lowest at the pole. This seems to be correct, according to me. Why? Wait, how can this be right? I know, see, why I thought it's right, because equatorial के ऊपर atmosphere बहुत ऊपर तक है. So I thought कि if the height is high, definitely यहाँ तक pressure measure करने में, what will be the pressure here? Weight of the column is high, therefore I thought pressure at the equator will be high and the pressure at the pole will be low, which seemed to be correct actually. That is the trap. Okay, just remember the fact that equator is called equatorial low pressure belt and poles they are called polar high pressure belt. ये नाम देने के लिए कोई तो reason हुआ होगा ना. This is low pressure, so equators they are having low pressure and poles they are having high pressure. You don't know the reason, but you know that statement 2 is wrong. Okay, next let us see statement 3. At the equator there is intense solar heating, and the heat is transported to great heights by strong convectional current. Okay, they are saying that equator is having intense solar heat and the heat is transported to great heights by strong convectional currents. Till here you know that it is correct. I mean it is having strong solar heat. This whether they are transported to great heights. Yes, of course they are low pressure and they are transported to great height. That is also something by strong convectional currents. ये ऊपर जा रही है लो प्रेशर से वार्म वाटर ऊपर जा रही है. अब ये बताना कि अगर कन्वेक्शनल करंट नहीं है तो और कौन से करंट हो सकती है जो इस वाटर को ऊपर लेके जा रही है ना? So that is also correct. So this is correct. So that is why they are saying this statement 3 can explain statement 1. The thickness of the troposphere is greater at the equator because at the equator there is intense solar heating and the heat is transported to greater heights by strong convectional current. So this is explaining statement 1. Okay. Therefore, only one of the statement 2 and 3 is correct, and that explains statement 1. So they're asking the phenomenon of air damage. You don't know this. That is why I'm telling you. For example, you have studied this cold during night time. What happens? You have studied in the temperature inversion. This cold dense air, it moves downward, and the valleys they will experience a severe winter. I mean severe coldness. Okay. So downward movement of cold dense air into the valleys during the night time under the influence of gravity is called phenomenon of air drainage. This is not damage. It's air drainage. Drainage. The air is draining downward. All the options seems to be very correct, like vertical raising of warm air इसको मैं drainage क्यों नहीं बोलूंगी, और high pressure to low pressure जाना इसको मैं क्यों नहीं बोलूंगी, outward spiraling of air from high pressure center accompanied by subsidence in the lower atmosphere. Okay. Anyways, you understood, right? The phenomenon of air drainage, this is called the phenomenon of air drainage. This actually it is there in the NCRT, air drainage. I already said you before. The temperature in the stratosphere generally increases with increasing altitude. Again, you need to draw the diagram. This is 10, this is 40. 10 को multiply करूंगा तो 50. Sorry, this is not 40, this is 80. 10, 80. 10 को 5 से multiply करूंगा 50 और 8 को 5 से करूंगा 400. Okay, troposphere, stratosphere, mesosphere, thermosphere and exosphere, right? So the question is asking about something. What is that? The temperature in the stratosphere generally increases with increasing altitude. This is stratosphere. Okay, they are telling that the temperature of the stratosphere, it increases with increasing altitude. With increasing altitude, temperature must decrease, but in the stratosphere and thermosphere, they will increase. Usually it must decrease, but here they will increase because in stratosphere we have ozone and in thermosphere we are having ionosphere, ions. Okay, now this option is correct. In stratosphere it will increase. This is correct. And the ozone layer, which absorbs the UV radiation from the sun, is present in the stratosphere. You are doubtful about whether it absorbs UV or not, but identify the focus area of statement 2. Their focus area is present or not. Okay, the answer is yes, it is present. So this explains this. Some people will think a lot ki are incoming ozone is transparent, greenhouse gases are transparent to incoming and opaque to outgoing, what and all. See, the statement, it is very clear. There is a ozone hole. Why there is ozone hole? Because ozone started absorbing lot of UV radiation and finally there is a hole. Okay, that is the function of ozone layer. It is preventing harmful UV radiations. I already explained you in the atmosphere topic what are the harmful effects of UV radiation and why there is ozone hole, right? So ozone layer is protecting us. If ozone layer don't protect us, then UV radiation, it will cause skin cancer, it can cause cataracts, it can decrease the crop yield. You studied all of them, right? It can damage the marine ecosystem, all of them. Okay. So option A. Following factors primarily influence the planetary winds. Pattern of planetary winds. What are the planetary winds? Trade winds. That is easterlies, and we have westerlies, and we also have polar easterlies. Okay, so they're asking the factors which are influencing the pattern of planetary winds. That is distribution of continents and ocean, rotation of Earth, latitudinal variation of atmospheric heating. Yes, all three of them they are affecting, right? See, latitudinal variation of atmospheric heating. That is why you are having pressure belts. Rotation of Earth, Coriolis force, it affects the direction, and distribution of continents and oceans obviously correct. So option D. Which of the following is the source region for the formation of air mass? Which of the following is the source region for the formation of air mass? See, I know that subtropical is the source region for the formation of air mass because this is equatorial low pressure belt, subtropical high pressure belt, and temperate low pressure belt, and we'll have polar high pressure belt now. So whenever I draw a diagram, I will see easterlies. So easterlies, they originate in the east. That means in this direction, and they are westerlies. So what is this? This is the origin point now. So subtropical, they are basically the origin point for the formation of air masses. And the Siberian plains, they are very famous for the formation of air mass, which is already in the NCRT that we studied. With reference to atmospheric motions, why are the strong vertical winds generally not experienced in the Earth's atmosphere? Why there are no strong vertical wind force? Because I already said they are counterbalanced by gravity G. So option B is correct. Do you remember I said that horizontal distribution of pressure, it is studied by drawing isobars. Okay, if you want to study horizontal distribution of pressure, you need to draw isobars. And vertical, I said it is almost negligible, so you need not even study about them because they are counterbalanced by gravitational force. And do you remember the geostrophic wind that I said? So I already explained you about the geostrophic wind, right? When isobars, they are free from the friction of the earth, and that usually happens around 2 to 3 kilometers. And when isobars, they are free from friction, the pressure gradient force. What is pressure gradient force? That is distance between isobars. That is pressure gradient force. As you move from one isobar, let's say it's 148 millibar, and let's say it's 104 millibar. So as you move from one isobar to other, there will be a pressure gradient force. Okay. So usually, when there is no friction and when the isobars are straight, the pressure gradient force, it is balanced by Coriolis force. And in such direction, the wind will move in this direction. Such wind is called geostrophic wind. Okay. The wind, which direction is the wind moving? The wind is moving in the direction parallel to isobars. Okay. Because see, basically the vertical forces, they are balancing out each other. I mean, the pressure gradient force, as the wind moves from one isobar to the other, the pressure gradient force, it is being balanced by the Coriolis force. In such a scenario, when that happens, the wind must go parallel to the isobars. Then that wind is called geostrophic wind. This is what I have explained. Okay. वर्टिकल विंड्स, यस, वर्टिकल विंड्स का कोई लेना देना नहीं है क्योंकि वो ना ग्रेविटी के साथ काउंटर बैलेंस हो जाती है. द वर्टिकल विंड्स आर काउंटर बैलेंस बाय ग्रेविटी एंड द हॉरिजॉन्टल विंड्स usually when you go from one isobar to other, you will get a different horizontal wind. It depends upon the gradient of one isobar with respect to the other. And the next one we have geostrophic wind. Geostrophic wind happens when this horizontal wind, as it crosses from one isobar to other, when it is counterbalanced by Coriolis force, that wind will go parallel to isobars, and such a wind is called geostrophic wind. In coastal region, sea breeze occurs during daytime. Okay, in coastal region, sea breeze occurs during daytime. Okay, see, you know what, do you know difference between land breeze and sea breeze? I already said you, right? Land breeze is you are getting land, I mean breeze from the land to the sea. Okay, that is land breeze. This is land and this is sea. What is sea breeze? That sea breeze is something like this. Okay, that's all. And when does sea breeze happen and when does land breeze happen? Sea breeze, it happens during daytime. Sea breeze happens during daytime and land breeze, it happens during night time. Why am I saying like that? Now let us see during daytime. During daytime, land, will it be in low pressure or high pressure? It will be in low pressure. What happens if it is in low pressure? Warm air moist, it will move over the land and it will go to the sea. And sea, it will send it to land back. Okay, that I mean, of course, now sea is at high pressure, right? This high pressure, it will go to low pressure area. That is during daytime. Okay, and during night time, what is land? How is land behaving? It is behaving like high pressure. Therefore, from high pressure to low pressure, this wind travels in this direction only, and then there will be circulation like this. Okay, this is what you know. In the coastal region, sea breeze occurs during the daytime. Okay, does sea breeze occur during the daytime? That is true. Sea breeze, it is occurring in the daytime only, right? This is sea breeze. So option 1 is correct. Now next statement. In contrast to land, sun rays do not penetrate deep into the sea water. See, this statement is wrong because sun rays, they penetrate into sea water, but the absorbing ability is very large that no matter how much it absorbs, still it will not become heat. It will not become hot very easily. Therefore, this statement is wrong. I mean, in contrast, sunlight do not penetrate deep into seawater. See, when usually you know about the sea, right? The photic zone occurs only up to certain extent, and there sunlight will not reach into deep water. If they have given it as a generic statement, then I would have tick marked this correct. But they are telling in contrast to land. Okay, that is why I had to tick mark it wrong. Why? See, when you observe water and land, land, it will be heated only till here. Only up to certain extent land will be heated, right? But what about water? Compared to land, the heat will transfer, it will penetrate even more compared to land. So with respect to penetration, if you are comparing with land, then of course water, it is more depth. So therefore the statement will go wrong. But if they're asking me sun rays do not penetrate deep into seawater, if you're not comparing with anything, then the statement will go right. Okay, so option C. What are isolines? Isolines are lines on maps that connect points of equal value. That's all. So they are asking to connect. See, general isoline can also be an isotherm. You are connecting equal values of temperature. That's all. So different isolines. Okay, this is a generalistic question. Anyways, ISO-NIF. NIF will connect snowfalls. Okay, N snow, NO. Son, it is nothing but snow. Remember it like that. Okay, ISO-NIF. Okay, fine. ISO is the same, common among all. So you need to know this NIF. NIF implies snowfall में F है तो NIF में F है. चलो, and ISO shine में H है तो यहाँ पे H है. Haline, halinity, you know, it's related to salinity. And hypse, they connect actually equal elevation. Okay, this is not cloudiness, it is equal elevation. And if you're talking about cloudiness, then it is iso nef. Nef is different from nif. Okay, so remember iso nif, it's for snowfall. Iso hell, it's for sunshine. Iso haline, it's for salinity. Iso hypes, hype implies height implies elevation. Okay, iso hypes implies elevation. Iso nef implies cloudiness. Okay, iso nef is cloudiness. Therefore option 1 2 3 are correct. For the next question, you need to know the difference between aphelion and perihelion. How did you remember aphelion and perihelion? See, aphelion, na, I remember it as apart. So somehow I remember that it is farthest. And perihelion, that is the opposite. So it is nearest. Okay, this is for sure. And aphelion, when does this occur? It occurs during July. That is 4th July. And when does perihelion occur? It occurs on 3rd July. Okay. Now they are saying that the amount of annual solar insolation received by Earth on 4th July is more than the amount received on 3rd July. On 4th July, Earth is going far away from the sun. Then can the insolation be larger on 4th July compared to 3rd July? No, right? Therefore, first option is wrong. With respect to Earth's revolution around the sun, the Earth around 4th July is aphelion, whereas the 3rd July it is at perihelion. This statement is correct. So option D. So whenever you see this 4th July and 3rd January, sorry, this is January. Whenever you see this 4th July and 3rd January, immediately you need to recall this aphelion and perihelion. Okay. One more thing, how can you recall that July is apart aphelion? See, July, I remember a famous song on it where two lovers, they are going apart from each other in the month of July. That song, there is this famous Telugu song or Tamil song, Telugu song. Yeah, there the lovers, they are breaking up and going apart. So that one I can remember easily. So July, it is apart, aphelion. Okay, and January, it is perihelion, near to the sun. With reference to climatology, consider the following statement about thunderstorm. Okay, during thunderstorm, cumulonimbus clouds are developed along with thunder and lightning. Correct. Thunderstorms form primarily due to intense convection of heat. That is also correct. So this intense convection of heat, this is the explanation for this. Is that the explanation? They are saying that due to intense convection of heat, the cumulonimbus are formed along with thundering and lightning. Doesn't feel wrong. That is the reason why clouds are formed, right? So option A. Asking which part of the cyclone is having the maximum velocity. See, if you observe the cyclone diagram very carefully, from high pressure to low pressure, wind is moving. This I, it is having low pressure, okay? And after this low pressure area, after all the water molecules or wind particles which are gathered in this low pressure area, they rise upward in the eye wall. So this is eye wall where warm air raises upward and it will go outward, okay? So this rapid movement of warm air in the eye wall creates a cyclone, okay? It creates a storm, okay? People are afraid not because of the eye, because of this eye wall, which is very drastic. See how the wind is moving in this eye wall, okay? Yes, if anyone asks you a question, where is the maximum speed? It is definitely it is in the eye wall. People always ask one question ki warm air is rising above. This logic is perfect because there is low pressure area in the eye. That is why in the eye wall, warm water is rising above and the speed of the warm water is very high in the eye wall. Then what is this subsiding warm air? Why is it subsiding downward? See, for every action there is an opposite reaction. Since this air is rising upward in the opposite direction, this warm air, it is forced to go downward. That's all. Just like just to counterbalance. This is a subsiding warm air to counterbalance this rapidly moving outward air. Okay, now the question is asking, in tropical cyclone, wind reaches maximum velocity in which one of the following regions? The answer is eye wall. Eye wall surrounding the eye of cyclone. Okay. This you can study when you are studying environment. Basically, podzolization, it is a soil formation process in the coastal regions in the lower latitudes. Okay, that is podzolization. The next question is about noctilucent cloud. Knocked. इस word सुन के ही हमें पता चलता है कि this is related to night. Knocked night. Okay, nighttime clouds. Okay, this you can see in the polar regions mainly. They are also called as polar mesospheric clouds. When there are ions, na, these ionic layer, ionosphere, there are some clouds nearby there. They are noctilucent clouds. Which one of the following layers? See, noctilucent clouds का meaning ही है polar mesospheric. सीधी बात है, ये तो मेसोफियर में ही फॉर्म होगा बिकॉज द नॉक्टिल्यूसेंट का डेफिनेशन ही है, दे आर पोलर मेसोफेरिक क्लाउड्स. They are the night shining clouds. As you can see in this diagram, they are shining in the night time. Okay, and do you know mesosphere, it is the coldest atmospheric layer, and little bit of ions whatever they are there in the mesosphere, they are creating this NLC, noctilucent cloud. Lucent implies shine, noct implies nighttime shining clouds. The next question, between the latitudes of 45 degrees and 65 degrees in both the northern and southern hemisphere, rainfall is generally received first on the western margins and gradually decreases towards the east. The explanation says that between the latitudes of 45 and 65 degrees in both the hemisphere, the atmospheric circulation is dominated by prevailing westerlies. Okay, see, westerlies, they travel from west to east, right? If they're traveling from west, then of course rainfall will be more in the offshore. I mean, rainfall will be more this side, right? And rainfall will gradually decrease as it move towards east. So the explanation is also correct. Similarly, even in the southern hemisphere, there are westerlies here, and the rainfall is more in the western coast, and it decreases as you move towards eastern coast. Therefore, statement to explain, statement 1, option A is correct. This is also called as onshore, west, offshore, east. Similarly, this is also called onshore, west, and offshore, east. Same. Okay, this is what we have studied. They're asking the favorable condition for formation of dew. Okay, clear, calm wind. I mean, clear sky, calm wind. Dew point remaining above the freezing point. See, freezing point, let's say 0 degree Celsius is the freezing point. If it is above 0 degree Celsius, then what do you call it? Above freezing point. If dew point is above freezing point, then it is called, then dew will be formed, right? Basically, if that goes below 0 degree Celsius, then frost will be formed. So, for formation of dew, the dew point must be above 0 degree Celsius. If dew point is below 0 degree Celsius, there will be frost formation. Okay, now they are saying dew point temperature must remain above the freezing for the formation of dew. This statement is also correct. Low relative humidity near the surface. See, you must have warm, there must be high relative humidity. When there is high humidity, then only cold air will react with warm air for the formation of dew, right? So low will become wrong. Okay, long winter nights is also correct. Therefore, I would mark A, 1, 2, and 4. Only 3 as correct. Option C. Tropical cyclones originate and intensify over warm tropical oceans. That's correct. This is what we have studied till now. Warm waters are necessary to fuel the heat engine of the tropical cyclone. Yeah, of course, you require warm water. Then only low pressure will be formed. Then only tropical cyclone will be formed. If it is not warm, how can low pressure be formed? That is the heat engine. Warm water are necessary fuel for the heat engine of the tropical cyclone. So 2 is explaining 1. Option A is correct. Question is asking about marine west coast climate. Okay, marine. It is very difficult to mark A, B, C, D, E, H. But as we have already studied, C stands for marine. I mean, C stands for temperate, right? And D stands for cold temperate. And we have seen marine west coast. It belongs to warm temperate. And moreover, British is also the clue here. British type climate. Why it is clue? Because British it lies in the temperate zone, right? Therefore, I am putting C. And next, I need to know the letter code that I need to put after the C. Since it is west coast, there will be summer both warm and cool. So summer warm and cool, that is FB. Basically, marine west coast climate, it is located poleward from the Mediterranean Sea, and the main areas are, if you see Europe, it is the northwest Europe and the west coast of the North America, which are part of marine west coast. Okay, let us think this as our world map. So I will highlight areas. Now I said, what did I say? I said northwest Europe. That means that area will be somewhere here, northwest Europe, and we also have west coast of North America. That is somewhere here. So they are the main areas which suffer from marine west coast climate. And we also have north of California, southern Chile, southeast Australia, and New Zealand also. They also are part of marine west coast climate. Okay. Now the options are saying southern Chile and southeastern Australia. So yes, these are correct. Western Africa, no, we did not study about Western Africa. Therefore, only two options are correct. You can eliminate Western Africa very easily because they are mostly associated with savanna and desert climate. So marine west coast का chance नहीं है. With respect to fog, fog is simply a cloud that forms close to the ground. Correct. Radiation fog is associated with radiation cooling of the land at night. That's also correct. Advection fog forms when moisture is blown over a cold surface and is chilled by contact. Yes, that is advection. Na? I already discussed advection with you. This is cold surface, and when air is moving, that air in contact, it will get warmed up and it will form fog. Okay, advection fog forms when moisture is blown over a cold surface and is chilled by contact. Option 1, 2, 3. Option D. Local winds over a region develop due to certain climatic condition and can be classified as hot and cold winds. See, they are asking the cold local winds. I read some of the cold local winds for you. Exact questions are being asked from NCRT. Okay, see, I said you to just remember the cold. The rest of them are hot. What are the cold winds that I said to remember? Mistress. That is Mistral, Bora, Blizzard. Okay, Mistral, Mr. Bora, and Blizzard. Remember like that. Mistral, Bora, Blizzard. They are in Mr. Bora and Blizzard. They are in the cold areas. Remember like that. Okay, cold winds, Mistral, Bora, and Blizzard. They are the local cold winds. And we have hot winds. What are the hot winds? See, you don't need to remember because whatever are not cold, they will become hot. Okay, for example, you have Lu, Foyen, Chinook, Sirocco, Harmattan. All of them we have studied, but this is difficult to remember. I can at most for mains, I can remember Lu and Fohin. The rest of them, they are difficult for me also. Okay, now they are asking me the cold winds. So cold winds, I know Mistral, Bora, Blizzard. So the Mistral and Bora, I can mark only 2, but option is 3. Some other wind that we don't know. Okay. So Pampero is also a cold wind. I just remember these 4. Okay. Mistral, Mr. Bora, Blizzard, and Pampero. Okay, they are cold winds. There are some other cold winds like Baise, which is in France, Freyagem, that is in Amazon Valley, and you have Laventer, that is cold wind in Spain, and Punas, western side of Andes Mountain, and Purga, they are in Russia. But no one is going to ask Punas, Purga, Laventer, Freyagem, Bais. See, Freyagem, it looks like fridge is cool, and Bais, Laventer, cool lavender, you are drinking a cool lavender, and Punas, Pune is cool, Purga, Puri is also cool. This is the way of memorizing whatever way you want. Just try to memorize, okay? They're asking me the increasing order of albedo. Snow, fresh snow, it is always the highest. So obviously, ये तो first option में नहीं होगा because they're asking increasing order. So smallest one will be in the first box, and then you need to keep on connecting. Okay. What about ocean? Ocean should be the least according to me because ocean is a good absorber of sunlight, right? Therefore, I will mark ocean in the first. I mean last. Okay. Ocean will be marked last. Great. Albedo of snow is the highest and albedo of ocean is the least. So 2 and 1. There are 2 options with 2 and 1. Now you need to compare dry land and wet savanna. अब देखना ड्राई लैंड में अब्जॉर्ब करने के लिए बचा क्या है, वो तो ड्राई हो चुका है ना, तो वो रिफ्लेक्ट ही करेगी. देयरफॉर आई विल मार्क 4 एज हियर एंड वेट सावन्ना इट माइट अब्जॉर्ब सनलाइट. देयरफॉर आई एम मार्किंग इट हियर. सो एज पर माय गेस, इफ आई नीड टू डू इट इन द एग्जाम, आई विल डू ऑप्शन ए. Consider the following statement regarding the Mediterranean climate. See, Mediterranean climate, you need to know the climate code for this question. See, if you have studied that chapter, you already know that C, it belongs to temperate, warm temperate. Okay. And next, the next code that you have given for Mediterranean climate is yes. Okay, yes is semi-arid or steppe. That is almost becoming transitioning into a desert. That is what you wrote about Mediterranean climate. See, yes. Now, the question is asking this. The area under this climate receives its maximum rainfall during the summer month. ये देखना कि ये तो डेजर्ट बन रही है and they are telling they are receiving maximum rainfall during summer months. So whoever don't know about this climate classification and all, they might think, okay, Mediterranean climate, yeah, it is true that it is located near Mediterranean Sea only, but that doesn't mean that there is a heavy rainfall from Mediterranean Sea. Okay, Mediterranean climate, as the name suggests, it is the climate around Mediterranean Sea along the west coast of continents in the 30 to 40 degree latitude. Okay, but that doesn't mean that there will be rainfall from the Mediterranean Sea. Okay, as I said, yes is the code for Mediterranean climate. Therefore, it is transitioning into desert, and there is no rainfall there. It is almost hot and dry. Therefore, option one is definitely wrong. And next, it remain under the influence of the westerly winds throughout the year. It is not throughout the year. It is mainly in the summer and winter. If you remember, I said you that westerlies, they are tropical high in summer. Whenever there is a summer season, Mediterranean climate, they are tropical high in summer, and in winter they are westerlies, dominated by westerlies. Okay, this is what I said you about Mediterranean climate. Option 2 also goes wrong because they are saying throughout the year. But I said na, in the summer they are mostly dominated by subtropic high, and in winter they are dominated by westerlies. Since in the winter they are dominated by westerlies, they receive maximum rainfall during the winter months. Okay, and summers they are very hot because the region it comes under the dominance of subtropic high. That is about Mediterranean climate. If option 2 also goes wrong, then the only option left is option 3. They are characterized by annual moderate temperature. This seems correct. The average temperature might be the same because they are located somewhere near the sea, right? Therefore, option 3, option C. This question is about clouds. Two major forms of clouds are stratiform and cumuliform. Okay, I don't know that they are major forms, so I cannot tell. According to the altitude, clouds are classified as high, middle, and low. This is correct. Strato, nimbostratus, and stratocumulus are type of high clouds. If you remember high clouds, I said that they are high, and cirrus are high. Therefore, all these clouds they start with cirrus. It can be cirrus, cirrostratus, and cirrocumulus. And middle clouds, what did we see? We saw alto. We saw them starting with alto, alto stratus, and alto cumulus. Okay. Mm, they are starting with alto, and you wrote them as alto stratus and alto cumulus. Similarly, high they are starting with cirrus, and you wrote them cirrostratus, stratocumulus, and the other is just normal cirrus. Okay. Uh, and what about low clouds? Low clouds they can be stratus and nimbus, right? This is the regular knowledge. They can be stratus and they can be nimbus. Therefore, it can be stratocumulus or nimbostratus. That can also be there. So this is what we have studied about the classifications, and they're saying that stratus, nimbostratus, and stratocumulus. This is wrong. Okay, they are not high clouds. They are in fact low clouds. Clouds having so when you eliminate option 3, option D goes wrong. And next, clouds having nimbus attached to their name produce precipitation. That is correct. 4 is also correct. So you definitely know that 2 and 4 are correct. Option B and C both have 2 and 4. So you need to check option 1. Two major forms of clouds are stratiform and cumuliform. Most of the clouds, high, middle, and low, I'm always seeing this from word stratus, cumulus. Here also stratus, and even in stratus we are seeing again cumulus and stratus. So yes, I can say that stratiform and cumuliform, they are the major forms. Without even knowing the concept, I can say that. So option 1 goes correct, and we have option B as correct. El Nino, consider the following. So you know about El Nino, right? La Nina is La Raha hai Barish, El Nina is Le Raha hai Barish. Simply meaning that if it is Asia and if it is Australia, El Nina will create a drought condition here and rainfall condition in the North America and Peruvian South America. Okay, now this side there will be rainfall and this side there will be drought during El Nino. That means the water circulation it is diminishing during El Nino. Even first statement is correct, and the second statement it may lead to drought conditions in the Australian South Africa. See, South Africa you may be confused because here it is Australia and here it is Asia. Where is South Africa coming from? But if you do SOP analysis, you analyze that there will be only one focus area in any statement. The focus area is definitely drought condition or not. Yes, there is a drought condition, which is correct. It increases plankton growth and fish production in the Eastern Pacific Ocean. Okay, see, this is Western Pacific Ocean and this is Eastern Pacific Ocean. And Eastern Pacific Ocean, there is rainfall. So people usually think that if there is a rainfall, definitely there will be plankton production and fish production. That is utter wrong. Okay, see, this is a low pressure zone. That means water is warming up here. Water is warming up. That means cold water, it must subside. Not only cold water, the nutrient rich water, dense water, everything it will be subsided down. Why? The lighter warm water, it will go more. The depth of the warm water, it will also increase because this area, it entirely became a low pressure zone. Okay. And therefore, the plankton growth and fish production it will decrease because they subsided down in the Eastern Pacific Ocean. It increases, it becomes wrong. Okay, option A. Only 1 and 2 are correct. With reference to Coriolis force, okay, it arises due to rotation of Earth. It is correct. The deflection, it deflects the winds to the left in the northern hemisphere and to the right in the southern hemisphere. See, you know this symbol, right? Easy to memorize. So Earth moves eastward from west to east, but that is not sufficient for you to answer this question. See, even if you know Earth moves eastward, you cannot really plot Earth eastward जाएगी, चलो ठीक है, उससे तुम क्या conclude करोगे, यहाँ पे left है या right कैसे? That's why you need to memorize this symbol you need to memorize. Okay, it will be right in the northern hemisphere and left in the southern hemisphere. It deflects the wind to the left in the north. Left in the north is wrong, right in the north will be correct. So statement 2 is wrong. Statement 3. The magnitude of deflection of wind caused by the Coriolis force increases when the wind velocity is high. Okay, see, Coriolis force acts on the moving air. Okay, when the wind speed is low, the deflection is small, right? Because wind is only moving slow, the deflection will be very small. But if the wind speed is high, okay, by the time it thought of reaching here, it will reach somewhere here. Okay, so Coriolis force increases when the wind velocity is high. That is correct. Basically, Coriolis force it do not add on gentle local breezes. आपने कहीं पे सुना है कि gentle local breeze को Coriolis force affect करते हुए? नहीं. So Coriolis force it do not act on gentle local breezes. It acts on moving winds, especially on winds whose velocity is very high. Statement 3 is correct. Some people might just think that if wind velocity is high, they are going to easily reach their destination. Therefore, the Coriolis effect will be zero. They will think like that. But you know, that's not how it works. Let's say this is the destination. See, if you know the Coriolis formula, na, Coriolis force, it is something 2 mv omega sine phi kuch hai. So V is the wind velocity. So Coriolis force it is directly proportional to wind velocity. If wind velocity increase, Coriolis force effect will also increase. So that is how Coriolis force happens. So there is a lot of physics behind it. So therefore, option This option is technically correct. Increases implies high, right? So this option is technically correct. The fourth option, it is directly proportional to the angle of latitude. So the equation that I just wrote, it's actually correct. It is directly proportional to angle of latitude. So 1, 3 and 4, option C. You need not know formula for it. Why? See, latitude के depend का कोई formula की requirement नहीं है. I already said you that near the equator the Coriolis effect is less. As you move towards the pole, the Coriolis effect is more. So it is directly proportional to latitude. But still, it's better to write the formula. Okay. Omega, phi, and all, they represent what? Here omega, it represents angular velocity of Earth, I think, and phi, it represents latitude, and V, it represents the velocity of wind, and F is the Coriolis force that acts on that wind. Okay. And of course, rate of change of momentum is force. I think you did a rate of change of momentum only. That is why you got this formula, P equal to mv. Okay, fine. Anyways, no need to look behind the physics 1, 3, and 4. Consider the following about advection. Okay, advection. It refers to the process of vertical heating of atmosphere. Vertical heating नहीं है, वो horizontal heating है ना? So this is wrong. Vertical heating is convection. The hot and dry local winds are known as Lu. Okay, the hot and dry local winds known as Lu experienced in North India during the summer season are an outcome of advection. Might be. Advection is just the horizontal heating of atmosphere, and Lu can also be one of the outcome. See, if I take the opposite meaning of it, opposite statement of it, then that opposite statement feels wrong. That means this statement feels more correct. So option 2 is correct, and option B will be the right answer. Oh, come on, this is our favorite question, okay? The pattern of wind direction in anticyclone is. Do you remember the diagram? High pressure, low pressure. High pressure, low pressure. And what are the directions? Okay, this is clockwise. Now they're asking anticyclone ka direction. Now, anticyclones form around high pressure zones, right? Good. Now, in the northern hemisphere, which direction is it? Anticyclone? Anticyclone in the northern hemisphere, it is in clockwise direction. And in the southern hemisphere, so I will immediately write clockwise here. And in the southern hemisphere, anticyclone, it is in the southern hemisphere, it is in the anti-clockwise direction, right? Therefore, which option will be correct? Option C will be correct. Clockwise in the northern hemisphere and anti-clockwise in the southern hemisphere. With reference to air masses, consider the following statement. Air mass is large body of air having little horizontal variation in temperature and moisture. It looks correct. If there is any statement opposite to it, it must be wrong. Let me make a opposite statement to it. Air mass is a small body of air having no horizontal variation in temperature and moisture. That opposite statement is feeling wrong. Okay, so this is feeling more correct. Therefore, I will take it as correct. Next, they do not form over oceans and can be formed over the land only. Utter wrong. Okay, therefore option A. Let us discuss about the biomes of the world. See, if you see the biome pyramid, at each level, at each latitude, we are having different type of climate. For example, in the tropical latitude, we have rainforest where the moisture content is very high. And as you move towards the right, the biome pyramid, the moisture content is decreasing in the biome pyramid. And also, the highest temperature and moisture, it is observed in the rainforest. Basically, rainforest, they are hot and wet. Okay. So in the tropical level, we get to see 5 types of climates mainly. One is rainforest, the other is a seasonal forest, next scrub forest, savanna forest, and desert forest. Remember that seasonal forest is also called as deciduous forest or monsoon forest. Okay, tropical seasonal or tropical decidual or tropical monsoon, whatever they are calling, it is the same. So these are the 5 types of climate in the tropical region: rainforest, seasonal forest, scrub, savanna, desert. And next in the temperate, remember this code DD, temperate DD. You can elongate it D. CGD. Okay, that is deciduous forest. So there is no rainforest in the temperate. We only have deciduous. Okay, starting with deciduous, we have chaparral and grass, and then desert. As you go to the subpolar, there is only one climate which can be called by 3 names. All three refer to the same thing: coniferous, boreal, or taiga. They are all referring to subpolar forest, which is coniferous forest. Here you get to find Christmas trees: coniferous forest, boreal forest, and taiga forest. And then in the polar regions, we have tundra forest. If we see this mountain region, we find 3 types of climate: subtropical, temperate, and alpine. Okay, in the mountain areas, again there are 3 types of climates. One is subtropical mountain, temperate mountain, and alpine. There might be many forests, but for India we notice only these 3. That's why I mentioned these 3. For example, subtropical mountain, it is there in India, especially in the northwestern Himalayas, Himachal Pradesh, etc. We find subtropical mountain, and then temperate mixed with wet conditions. So wet temperate can also be found, and we have alpine forest. Remember that alpine, it is different from taiga. Alpine implies altitude. So here you are checking the height, implies mountain peak. There only you get to see at greater elevations or greater height. Okay, alpine implies altitude, but taiga, latitude, T. Since latitude is having 2 T's, remember that taiga is talking about latitude, implies at the subpolar latitude you get to find taiga forest. Alpine forest you get to find at the higher altitude, okay, at a greater elevation. So don't get confused between alpine and taiga. And the last climate we have is the tundra climate. One more climate we have is littoral and swamp forest. These forests, they usually grow in the fresh water or in the brackish water. That is littoral and swamp forest. For example, I think mangrove forest, they are littoral and swamp. Maybe in the Andaman and Nicobar area also you get to find these littoral and swamp forest. Somewhere where you find deltas, that areas you might find littoral and swamp forest. See, whenever they are mentioning the word evergreen, that also means that it is rainforest, evergreen, always green. That is rainforest, okay? Tropical rainforest or tropical evergreen forest. This is the first climate that we need to know. It happens only in the equator. Why? Because we studied about temperate. Did you find rainforest there? No, right? Therefore, tropical rainforest, it happens only near the equator. That is why it is also called as equatorial type of climate. I mean, in the equator, it is one type of climate. Okay, tropical rainforest. See, the tropical rainforest, they occur somewhere between 0 to 10 degree north or south of equator. For example, this is our equator, 10 degree or above or below, north or south, you get to find tropical rainforest. For example, this is Western Colombia. So there in the Colombia, we have Columbia River. That in that basin, in the Columbia basin, which is closer to equator, there you get to see tropical rainforest. And similarly, Amazon River basin, Columbia River basin. Still, what do we have? Which river is this? Congo. Congo River basin and Asia. I mean, this can be, I mean, Southeast Asia, right? Malaysia, Singapore, all these Southeast Asian. Here also you get to see tropical rainforest. Okay, Congo River. So River Congo, it is the second largest river in Africa. I think Amazon River, it is largest by volume, and I think Nile, it is longest by length, and Congo, it is longest by length in the Africa, second longest in Africa, and Nile, it is longest in length all over the world, I guess. And this is Amazon River, it is the largest by volume. Okay, anyways, so these are the basins. We have Columbia Basin and Amazon Basin, Congo River Basin. Here you also get to see Guinea. So these countries and Southeast Asian like Malaysia, Indonesia, Papua New Guinea of the Pacific Ocean. So all of them, they have tropical rainforest or evergreen forest. Okay, and what is the kind of vegetation that you get to find here? Merged. Remember the trick, merged. Merged implies mahogany, ebony, rosewood, green heart, D for dyewood, etc. Okay, you get to see many mahogany, ebony, green heart. It is merged, na? Mahogany, ebony, rosewood, green heart, and then dyewood. We also have cabinet wood, but you can't remember many, right? But these are the main example. Whenever you see mahogany and ebony, they are only grown in the tropical evergreen. Therefore, definitely eliminate when you find them somewhere else. Okay, in the only evergreen, you get to see mahogany and ebony. So remember, mahogany, ebony, rosewood, green heart, and then dyewood. Dyewood or and we also have cabinet wood. So all of them, they are grown in the tropical evergreen, and there are also climber trees which grow in the tropical evergreen. For example, climbers such as vines, liana, epiphyte, etc. They are also found in this tropical evergreen biome. And tropical evergreen, it is famous for species diversity. 12% of Earth land surface, and it covers 12% of Earth land surface and 50% of 50% of Earth biodiversity. Also, do you know the difference between a hardwood and softwood? For example, hardwood, it is used for furniture, and softwood, it is used for paper and pulp. And this is the difference between hardwood and softwood. Also, you need to know that climber trees, they are not parasitic. Parasitic implies positive, negative. For example, if one species is benefiting from other species, then it is called parasitic. Okay, for example, leeches, ticks. What do they do? They suck. They suck blood from animals. Therefore, they are parasitic. And that is about parasitic. Now, if you see cascata plant, what is it doing? Cascata plant, it will steal nutrients. It will steal nutrients from host plants. Okay, that is why cascata plant. I mean, I think it is something cascata. So cascata, it will steal nutrients from the original host plants. Therefore, that is also parasitic. But climber trees, they are not parasitic. In fact, they are commensalism. They show commensalism. Commensalism implies one species, it is benefiting, but the other species, it is not going in a negative or positive way. For example, climber trees, what they are doing, they are just growing on one species to reach sunlight. So there is no problem for this tree. Tree has no problem. Therefore, climber trees, they are treated as commensalism relation, commensalism type of biological interaction. Okay. One more example for commensalism that I can think of is remora fish. What does remora fish do? Remora fish, for example, it rides on a big whale. I mean, उसको फिशिंग आई मीन स्विमिंग करने की जरूरत नहीं है क्योंकि ये बड़े whale के ऊपर चिपकती है and then it rides. Also that remora fish riding on sharks, that is also treated as commensalism because the sharks, they are not even negatively getting affected. Okay, therefore that is also an example for commensalism. Anyways, just need to know that climber, they are not parasitic. Now let us try to attempt an MCQ. There is an MCQ. The soil in the tropical rainforest is rich in nutrients. The second statement says that the high temperature and moisture of tropical rainforest cause dead organic matter in the soil to decompose quickly. That's correct. Whenever these two are low, whenever these two are high, metabolic activity definitely increase. Temperature is high, metabolic activity will increase, and it will lead to faster decomposition. But the first statement is saying that tropical rainforest is rich in nutrients. See, this is the trick. People will think that since there is a lot of rain, they are rich in nutrients, but no. The nutrients, they run away with the surface water. Okay, that is why tropical rainforest, they are less in nutrients. Therefore, option 1 is wrong. Option 2 is correct. Statement D. Okay, we got diverted a lot. Now let us discuss about a temperate. Now, when we are looking at tropical decidual forest, they are also called as tropical monsoonal type of climate. See, in the tropical evergreen, what did you do? From the equator, you just went 10 degree north and 10 degree south. Okay, that was your belt. Now, if you increase the range, let's say from 10, you are going to somewhere 25 to 30. Okay, so basically what you are doing from this equatorial belt, you are just moving 25 to 30 degree north and 25 to 30 degree south. Okay, that belt, that is a tropical decidual forest. That is the area where you get to notice tropical deciduous forest. Okay, that is also in the tropic only, but it is tropical deciduous where you get to see monsoonal or seasonal type of climate. For example, let's take Indian subcontinent. There you see seasonal forest. Indian subcontinent. Next, India, Myanmar. I mean, not the entire India. Yeah, but India, mainly India. In India, you get to see tropical deciduous. India, Myanmar, Thailand, Cambodia, Laos, Vietnam. Okay, and then these are the areas, and then you get to also find this North Australian continent, Northern Australia, and little bit of China also, South China. Okay, India, Myanmar, Thailand, Cambodia, Laos, Vietnam, South China, Northern Australia, Central America. This is Central America, and eastern part of Brazil. That is also in this zone only, right? Eastern part of Brazil and eastern part of Africa, Madagascar, etc. So basically, wherever there are monsoonal winds, there only you get to see. For example, in the temperate, you get to find westerlies. But what happens in the tropical? In tropical, you find easterlies, right? So easterlies, they are blowing the oceanic water to the eastern coast. Therefore, you get to find in the eastern part of continental margins. For example, in the Brazil and near the Madagascar and eastern part of Africa, and there you are able to find temperate tropical decidual, not temperate. Remember, eastern. I'm telling eastern. Eastern occurs only in the tropical. In if you are talking about westerlies, then they occur in the temperate. Okay. Now, since I'm telling easterlies, therefore they are occurring in the tropical. So tropical deciduous, eastern Southern America, eastern Africa. There you find a tropical deciduous forest, and also in the Central Asia, and Indian subcontinent, South China, Myanmar, Thailand, Cambodia, Laos, Vietnam, and so on, and northern part of Australia. So these are the continents where you find tropical deciduous forest. So tropical deciduous, they shed their leaves during summer to withstand that I mean dry summer. See, जैसे कि हम समर में गर्मी में लाइट कपड़े पहनना पसंद करते हैं ना, उसी तरह ट्रीज भी उसकी लीव्स को शेड करने लग जाते हैं. That's their nature. So they shed their leaves to withstand a dry summer. The deciduous forest, they usually shed their leaves to withstand a dry summer. And the type of vegetation that you get to see are teak, sal, sesam, neem, mahua, bamboo, and eucalyptus. See, teak and sal is must. Whenever they mention this teak and sal, na, I will only write it in the monsoon. Okay, teak and sal, only monsoon. Just like how I said merged. The first two that I said, na, mahogany and ebony, they are only for the tropical evergreen. Teak and sal, they are only for the monsoon. Okay, whenever they are mentioning teak and sal, just tick mark only monsoon or deciduous. Okay, that is helpful for option elimination. Okay, teak, sal, sesam, just remember teak, sal, sesam, neem, mahua, bamboo, and eucalyptus. So that is about tropical deciduous vegetation. Sometimes what happens, even in the tropical deciduous, if the rainfall is very, I mean, very lesser, in that situation, the forests, they are replaced with scrubland. Okay, you have seen different forests, right? Okay, this is scrubland and savanna. Oh, savanna is more drier. Okay, savanna is more drier, and they are just saying that in case if there is lesser rainfall, of course, the deciduous forest, they are replaced with scrublands. Just write here that if less rainfall, they get converted into scrublands. Why did I tell you that? Because they have directly skipped to tropical grassland or savannas. Okay, savannas, they are grassland. So scrubland to scrubs होगी, scrub से और छोटा क्या हो सकते हैं? Grassland. So tropical grassland or savannas. So basically tropical evergreen, they are rainforests. And next, deciduous. After deciduous, they might be converted into scrublands. And as the wetness decreases, they become dry. And the next type of climate is savanna climate. Savanna climate is also called grassland. Looking at tropical savanna, which is also called grassland. Now let us focus on Africa. We have seen that this forest, it is a tropical rainforest, which is Congo River Basin. You also get to see Guinea here. So that is belonging to tropical rainforest. And as you move towards east coast of Africa, there are easterlies, and therefore there are tropical deciduous forest here. Okay, this is what you have seen. Now, apart from these two, whatever continents that I mean, whatever countries that you are fighting between 10 to 20 degree north or south of equator, they are tropical grasslands or tropical savanna. Here you can find Senegal, Mali, Niger, Chad, Ghana. So all of them, they belong to tropical grassland. Even if you notice, I think Kenya, it is also in the tropical grassland. So all of them between 10 to 20 degree north or south of equator of Africa. Similarly, in the South America, if you notice, see, what did we discuss for tropical rainforest? We have seen Amazon River Basin for tropical rainforest, and for tropical deciduous, we have seen eastern coast of Brazil, right? So other than these two, what can we find? We can find Venezuela, which comes under tropical grassland, and then Brazilian highlands, not Brazilian east coast, Brazilian highland. Brazilian highland, it belongs to tropical savanna, and then some part of Argentina also, some part of Colombia also, Paraguay, Bolivia, all of them, they belong to South America. So they belong to tropical savanna. And we also find northern part of Australia as in the tropical grassland, also called savanna. So there you get to find some grass. Okay. Just do one thing in the exam. Eliminate eliminate just this Amazon rainforest, Brazilian East Coast, and whatever you can imagine between 10 to 20 degree north of South America, mark them. And also eliminate this Congo River Basin and tick mark whatever you can find between 10 to 20 degree north or south of South America. And similarly, northern part of Australia, it also is part of tropical grassland or tropical savanna. Okay. And the famous vegetation that you can find in tropical grassland is ABB: acacia, baobab, and bottle tree. Acacia, baobab, and bottle tree. See, bottle trees, they are famous because they store huge chunk of water during the rainy season, and they use this water in the summer season. So that is how the bottle tree work. See, one important thing is that fire. So in the savanna biome, fire is an important factor. They help in annual regeneration of grasses. How? I'll tell you. The firing, what happens after firing? Fire, it will stimulate the tree regeneration. How will it stimulate regeneration? By removing the dead organic matter. The fire is going to stimulate the tree regeneration. क्योंकि वो तो dead है. That is why tree will think to regenerate it again. So that is how fire will help tropical savanna. Because the dead organic matter, what's going to happen? It is going to be ignited, and the dead organic, they again go back to the soil, and they again help in the regeneration process for the trees. Therefore, it is often said that savanna trees, they are fire tolerant. Okay. But this is okay for normal trees. If there are young trees that are growing, and if you are firing them, do you think that they have that capacity to take it, and then they have the capacity to regenerate? No, it is only good for some plants, not for all the savanna plants. Anyways, it is usually said that savannas, they are fire tolerant. Now let us say tropical desert. You are finding deserts in the tropic. So where is it possible? So whatever deserts that you know, they are all almost part of tropical desert only. For example, in Africa, you know, Sahara Desert, Kalahari, Namib, they are all tropical deserts. And then in Asia, for example, Arabian Desert, Iranian Desert, Thar Desert, they are all tropical desert. Again, we have the Great Australian Desert, that is also tropical desert. And in the North America and South America, we have different deserts. Like for example, we have Mojave Desert. It is called by different names in America. For example, it's called Mexican Desert in the Mexico, and maybe in the California, it's called Californian Desert, and Sonoran Desert, and whatever. The Mojave, it is also a tropical desert. And then we have Atacama Desert, and there is Peru also, Peruvian Desert. Atacama Desert and Peruvian Desert, they are also South American deserts. So these are all the deserts. These are all the hot latitude deserts. We have Turkmenistan Desert, Gobi Desert, and also Patagonian Desert. Are they tropical desert? No, they are not tropical desert. They are temperate deserts. I mean, this 30-degree line, whatever I'm drawing, maybe I will down it down a bit. Okay, and they are temperate desert or mid latitude desert. So other than these three, the rest of them, they are all tropical deserts, because I think these deserts, they are cold, temperate cold deserts. Okay, Turkmenistan, Gobi, and Patagonia, they are not tropical deserts. And what is the kind of vegetation that we see in the tropical? We get to see xerophytes here. Xerophytes. I mean, xerophytes are basically the plants who are adapted to xeric or arid condition. Okay, xeric, arid. Okay, xerophytes are plants that are adapted to xeric or arid condition. Example: cactus tree and prickly pear. See, I will underline here: cactus, prickly pear, dwarf acacia, and some thorny bushes. Whatever you see, they are all examples for xerophytes. I remember this with this trick: cactus, pricks, dwarf acacia. Cactus, pricks, dwarf acacia. So cactus, thorny bushes, prickly pear, dwarf acacia, they are examples for xerophytes. Basically, what's happening? Why are these areas behaving like deserts? Because these areas, they are witnessing high evaporation, because they're tropical and there is also a lot of sunlight, right? Therefore, they're witnessing high evaporation, and that is increasing the salinity. That is also increasing the salinity, and ultimately they're becoming deserts. So since the evaporation is high and the salinity is also high, you also get to find hard pans here. Hard pans, okay? Salinity pans, also called hard pans. Okay, hard pans are what are hard pans? Hard pans are nothing but dissolved salts which are accumulating on the surfaces. Are deserts having humus? No, there is no humus. Deserts are humus deficient because the organic matter in the desert is very less, and since there is a large amount of sunlight, there is high rate of decomposition. Since there is high rate of decomposition, of course, there is no organic matter left, and therefore the humus in the soil is also poor in the deserts. Okay, that is about tropical desert. Also, since the moisture in the desert is less, trees, they do some leaf adaptation. For example, aloe vera, they tend to prefer leathery leaves, so that there will be less rate of evaporation. And stomata, they are deep seated in the leathery leaves. If a stomata is deep seated in the leathery leaf, that means the rate of transpiration is low. Okay, so these are the examples of xerophytes: cacti, thorny, prickly pear, dwarf acacia. Cactus, pricks, dwarf acacia. So basically, these are the four type of tropical climates that we have studied till now: rainforest or evergreen, deciduous or monsoonal. Okay, they are monsoonal. And next we have seen savanna, and then desert. So what is the trick for remembering the vegetation in the rainforest or evergreen? Merged. Okay, mahogany, ebony, they are must and should you need to remember because they are only grown in the rainforest and evergreen. Okay, mahogany, evergreen, redwood, green heart, and then this is a dyewood. Okay, that is a tropical rainforest or evergreen. These are the vegetations that I remember. And next we have deciduous or monsoonal. Okay, what did you remember? DD. No. DD is for temperate. Okay, I'm getting confused. DD are the type of climates in the temperate that we have seen. Okay, now I'm telling in the deciduous. Deciduous, what are the kind of vegetation that we have seen? Talk, not talk, it's a teak. Teak, sal. These are the two things that I remember, and the rest I can remember very easily. Teak, sal, sisham. Teak, sal, sisham, neem, mahua. Teak, sal, sisham, neem, mahua, bamboo and eucalyptus. Bamboo and eucalyptus. Okay, they are tropical deciduous. And then there are savanna tropical forests. What is tropical savanna? What are the examples of tropical savanna? They are basically grass. I said you to remember upgrass. Upgrass. What is upgrass? Acacia, baobab, and next these are bottle trees. Okay, bottle trees, they store water in the trunk. Okay, so these are about the tropical savanna. Now, what are the vegetations in the desert? It is very easy. Cactus pricks whom? Dwarf acacia. Cactus pricks dwarf acacia. So cactus, prickly pear, dwarf acacia, they are examples for desert vegetation. We shall first discuss Mediterranean biome. So Mediterranean biome, it occurs somewhere between 30 degree to 45 degree latitude. For example, see, you know the tropical climate, the maximum extent up to which tropical extent is 30 degree north or south, right? So if you go beyond it, then it is temperate. From example, if you take a climate somewhere between 30 degree to 45 degree north, or else if you take some climate somewhere between 30 degree south to 45 degree south, that will become temperate climate. See, the first region that you can recall, I mean, that you can try guessing is a region around Mediterranean Sea. Okay, so this is Mediterranean Sea, and the region around it, they belong to Mediterranean biome or Mediterranean type of climate. So you just need to remember the countries around Mediterranean Sea. And then we have this Northern America. For example, there is California around San Francisco. That area belongs to Mediterranean biome, and some part, majorly this part only. Some other part also is also similar to Mediterranean climate. For example, this whichever western coast that are suffering from westerly winds. For example, North American western coast, San Francisco, that area, and then the South America. What is this? Central Chile, and then we have this. Cape Town in the South Africa, Cape Town of South Africa. That also belongs to temperate belt, right? So western coast of temperate belt, whatever it's there, they are also similar to Mediterranean biome because they are getting rainfall from westerly winds. Okay, that is Mediterranean biome, and you have Cape Town and also some southern Australia region. This, I think, this is called Adelaide. So whatever it is there, they all are part of Mediterranean biome, mainly around Mediterranean Sea. I just want to go through this mapping once. Mediterranean Sea. What are the countries surrounding it? Do you know what are these countries? They are risk Matle countries. So Matle. Okay, what is risk Matle? So the countries surrounding Mediterranean Sea, first from the Africa, you have Matle countries, Morocco, Algeria, Tunisia, and here, if you go further down, you find Libya and Egypt. So they are Matle, Morocco, Algeria, Tunisia, Libya, and Egypt. Actually, they are from Africa, right? But if you see Europe, there are still many countries. For example, Spain, France, Italy. They are also surrounding Mediterranean Sea. Okay, maybe even I can try adding Greece also. But you know one thing, mainly what I would like to add is Matle only. Why? The reason being because they have some other seas in between. For example, Spain is covered with Alboran and Balearic, and then you have Ligurian Sea, etc. There are many other seas in between, but these Matle countries, they are mainly bordered with Mediterranean Sea. Okay, anyways, if they are asking in general, of course, in general, the Google says that there are 21 countries which are surrounding Mediterranean. Therefore, I cannot really be sure. But anyways, just think that these are the countries that are surrounding Mediterranean Sea. Do you know the countries that are surrounding Adriatic Sea? The trick that I remember is BSc MA. So first you are going to do BSc and then Masters in Arts. So BSc MA, we have Bosnia and Herzegovina, Slovenia, Croatia, BSc, Bosnia and Herzegovina, Slovenia, Croatia, and then MA is Montenegro and Albania. That is BSc MA. You know, I said about Mediterranean biome, right? Mediterranean biome is nothing but chaparral biome, okay? There are three types of biomes. One is deciduous, other is chaparral, grassland, and four types of biomes in the temperate. So there are four types of biomes in temperate. One is deciduous, second is chaparral, and third is grassland, and fourth is desert. So Mediterranean biome is almost similar to chaparral. Here you get to see mostly bushes and shrubs in the Mediterranean biome. Now in the desert you have seen that is something xerophilic or something like that. Here in the Mediterranean biome, you get to see sclerophilic. Sclero implies hard. Sclero implies hard, and philic implies leaf. So hard leaves, they are basically very good at moisture consumption. Okay, they consume moisture easily. Hard leaves consume moisture easily. Okay, that is sclerophilic vegetation. So the vegetation type of plants that I remembered is with this trick: olive and oak, love, mystery, lovely roses. Okay, olive, cork oak. This oak also called cork oak. Olive, cork oak. It is L'Oreal. This one refers to myrtle. Myrtle. Can you recall myrtle? myrtle similar to turtle, myrtle, and then this is lavender, lavender. Rose implies rosemary, rosemary. Okay, olive and oak, laurel, myrtle, lavender, rosemary. So these are the vegetations. These are the vegetations of Mediterranean biome. As you can see, laurel. I mean, where is this olive? So olive, cork oak, laurel, myrtle, lavender, rosemary, and maybe eucalyptus in the Australia. So they are all part of xerophilic vegetation, hard leaves. Since they are much chaparral or Mediterranean biome, now we need to see grassland, temperate grassland. We finished this. Now we need to see grassland. So the temperate grasslands, they are also called as wheat basket of the world. Okay, they are known with different names. For example, they are known as steppes of Russia and Ukraine. They are known as steppes of Russia and Ukraine, pustas of Hungary, prairies of North America, pampas of Australia and Uruguay, high weald of South Africa, downs of Murray, Darling Basin of Australia, Canterbury grasslands of New Zealand. Steppes are dry, prairies are wet. Steppes of Russia and Ukraine, pustas of Hungary, prairies of North America, pampas of Australia and Uruguay, high weald of South Africa, downs of Murray, Darling Basin of Australia, Canterbury of grassland. Canterbury grassland of New Zealand. So they are known with different names. For example, steppes, they refer to dry grasslands, and prairie, they refer to wet grasslands. Okay, it is also called as pampa. Temperate grasslands are also called as pampas. And the vegetations that we can find are a few vegetations like alfalfa and lucrine. I remember it with aloo. Okay, because they are known as wheat basket of world, and we eat them with aloo. So I remember aloo, alfalfa, and lucrine. Alfalfa and lucrine, they are the temperate grassland. Okay, so try to memorize. If you cannot memorize, it's fine. They are called with different names. That's all you need to know. They can be called steppes or prairies or pampas. They are the three famous names that you need to memorize. And most of the names, they are starting with P only. For example, pustas, prairie, pampa, and pretoria. They are all tropical grasslands, not tropical, temperate grasslands. The vegetations of a temperate grasslands are alfalfa and lucrine. We have seen Mediterranean and grasslands. Mediterranean, they are chaparral, and we have seen grassland. Okay, Mediterranean vegetations: olive, cork oak, laurel, myrtle, lavender, rosemary. And grasslands, they are known as wheat basket of the world. And with wheat, what do we eat? Wheat aloo. So alfalfa and lucrine. So they are the temperate grasslands. Now we need to see temperate deciduous. We finished grassland. We first studied Mediterranean biome. Okay, and then now we later studied grassland biome. Now we need to see deciduous forest. So deciduous, they receive seasonal or monsoonal rainfall. So temperate deciduous, they are also called as British type of climate. Temperate deciduous also called as British type of climate. They are found somewhere between 45 degree to 60 degree latitudes, north or south. Okay, mainly in the north they are found. That is why they are called British type of climate. And here, what are the countries? For example, British type I'm saying. So therefore, Britain and northern and western France, Belgium, Netherlands, Denmark. So they are all here, right? They are all here. And also we have Chile. Chile also experiences deciduous type of forest. Okay, Chile and North America also, because they are suffering from western winds. No? So they are experiencing deciduous forest. Deciduous implies monsoonal, right? So temperate deciduous, it is experienced in the British type of climate, or in the northern America, or in the southern part of Chile, or even in some parts of New Zealand, Tasmania. There also you get to see temperate deciduous forest. Okay, what is the trick that I used to remember? I remember it with poplar oak birch. A poplar oak birch named elm is in the Maple Beach. So this is how I remember. There is a poplar oak birch. Her name is M. She's in the Maple Beach. Okay, poplar, oak, birch, elm, Maple Beach. Okay, since it is made, since they are westerlies, and that is why you are getting monsoonal type of climate. That is why I remember it. There is a beach here. That is Maple Beach. Maple, and there is also beech tree. Okay, beech tree, that I think it is really a tree on the beach. Okay, poplar, oak, birch, elm, maple, beech. So these are the famous trees that grow in the temperate deciduous forest. Let us try to recall all the types of vegetation. First, we have seen tropicals. Okay, tropical, there is rainforest or evergreen forest. So there is always rain. Here we remembered it with merged. So rainforest or evergreen, it's merged. What are the forest? Mahogany, ebony. They are only grown in tropical rainforest. Okay, mahogany, ebony, rosewood, green heart, and then dyewood. What is this? Mahogany, mahogany, ebony, rosewood, green heart, and dyewood. So these are the rainforest, tropical rainforest or evergreen forest vegetation. Next, we have seen deciduous forest vegetation. What is deciduous? It is monsoonal. So monsoon teak hai. So teak sal. So teak sal, they are only in the tropical deciduous. Now, what are the vegetations that are grown in the tropical deciduous? Teak, sal, sesam, neem, mahua, plus BE. What is BE? Bamboo and eucalyptus. Teak, sal, sesam, neem, mahua, bamboo, and eucalyptus. They are grown in deciduous. tropical deciduous. Okay, now next we have seen tropical savanna. Okay, now what's going to happen? Some deciduous forests, they might also be converted into scrubs. Okay, then they're called tropical scrub forest. That's all. They are basically deciduous only, but they can be converted into scrub. So these some of these plants can also be grown there. Okay, they're tropical scrubs. Now later we have seen savanna, tropical savanna, ab grasslands देखेंगे, ab grass. Therefore savanna ab. What is A? Acacia. A is acacia, and baobab, and this stands for bottle tree. Okay, basically they are storing water because when summer comes, they need to use this water, right? That is why these bottles are storing. So savanna, acacia, baobab, and bottle tree. Okay, that is for savanna. And next we have seen desert. Desert is easy to remember because cactus sprix, dwarf acacia, cactus sprix, dwarf acacia. This is cactus tree. This is sprix pear. I think this is prickly pear. Then dwarf acacia. So these are tropical forests. They lie somewhere between equator and 30-degree north or south. Later we have seen temperate forests. They lie somewhere between 30-degree to 60-degree latitude. Okay, we have different temperate. What are they? We have deciduous. Here we experience monsoonal. And next we saw what will be the next? It will be chaparral. Chaparral, it is also called Mediterranean type of climate. And then there is a grassland or savanna, later desert. Desert we have not discussed. We initially first discussed that chaparral and grass, and later we have seen the deciduous also. Okay, deciduous, they are popular because they are monsoon. That's why remember it with poplar. Okay, poplar, oak birch. Her name is M. She's in the Maple Beach. So deciduous, they are with beaches, right? Because they are caused due to western winds. So therefore they are near the beaches. Therefore beach, poplar, oak, birk, elm, maple, and beech tree. They are with the vegetation in the temperate residual forest. Now we need to see what after deciduous, chaparral, that is Mediterranean. So deciduous, it is also called British type of climate. Right, Mediterranean, it's not British type, it is Mediterranean climate. It is chaparral. Okay, there you need to remember. Okay, olive and oak, they love mystery lovely roses. Okay, olive tree, cork oak, and this is laurel, myrtle, lavender, and rosemary, they all belong to temperate Mediterranean climate. Okay, temperate Mediterranean climate, olive and oak, laurel, myrtle, lavender, and rosemary. Next in the grassland we have seen alu. Okay, because temperate grasslands, they are the wheat basket of the world. Therefore we eat wheat basket with alu, right? In the grass only, you are finding alu, right? So alu, temperate grassland or savanna. Okay, there what is A? Alfalfa. A stands for alfalfa. Lu stands for look green. Okay, I forgot to tell you one thing, that there is this tree called kauri, and it is a very very important tree in the New Zealand, and it grows in the deciduous forest. You know what is resin? Resin is nothing but kauri gum. Okay, kauri gum is also called resin, and it's very famous. And kauri, it is very highly priced for its timber. Okay, इसका timber खरीदने के लिए बहुत ज़्यादा पैसा देना पड़ेगा. So temperate grasslands, you remember this alu, right? Therefore the temperate grasslands, they are humus rich. They are called wheat basket of the world. They are very humus rich and very fertile. For example, we have Chernozems and molly salts. So they are also called regions of Chernozems or molly salts because they are very humus rich. See, taiga biome, now you need to study this colder areas. Okay, taiga biome, where is it observed? It is observed somewhere between 60 to 70-degree northern equator, above the equator only, somewhere between 60-degree north and 70-degree north. That's all. So whatever you see the regions in the Russia or Europe or the regions of North America, they're all covered with taiga biome. Taiga biome implies there you can find Christmas trees. In the Europe, you can find even in the Churchill or America. Okay, there you can find. So what are the types of vegetation that you can find in a taiga biome? You can find pine, fir. For this I remember with a trick. So pine I remember with fine. Fine for what? Fine for three things. One is spruce, cedar, larch. Okay, or else remember like pine for larch, cedar, spruce. Larch, cedar, spruce. Pine for larch, cedar, spruce. Okay, that's all. Pine for large cedar spruce. 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 Okay, if I had it 10 times, then you will remember. That is taiga biome. Okay, taiga biome, it's also called coniferous or boreal forest. So it is area wise, it's the largest forest, and also taiga biome, it is the only forest which is having softwood. Okay, that is about taiga biome. And tundra biome, it lies beyond the Arctic Circle. Do you know the meaning of thawing? Thawing is process of melting of ice. Okay, as it warms up, the process of melting of ice, it's called thawing. You need to first understand permafrost. Okay, see, basically now there is sunlight, so as the ice melts, the permafrost, what is permafrost? It's a frozen soil, and this permafrost, it's also having some organic matter. So as the ice melts, the permafrost, it turns into mud. Turns into mud, and it exposes organic matter, and the organic matter, it starts to decompose. So why it will start to decompose? Because till now it is frozen, but now the organic matter, it is exposed to sun. Therefore the organic matter, it will start to decompose as it thaws. Thaws implies melts. So as it decomposes carbon dioxide and methane, it releases to atmosphere, and that will lead to greenhouse effect also. Okay, greenhouse gases will increase. So basically, whenever this permafrost happens, that results in the formation of spongy swamp and bogs. So there will be some spongy swamps and bogs, right? Spongy swamps and bog. So basically, they are found in the areas of Greenland, Alaska, etc., Eurasia also. There you get to find tundra. Okay, tundra is found in the spongy swamp and bogs. And the vegetation that you get to see is cryophytic. Cryo means frozen, and phytic implies plant. Example for cryophytic vegetation is moss, lichen, sedges, rhododendron. Okay, rhododendron is very famous. There is also UPSC TYQ on that. Remember rhododendron, that is for tundra only. And then you get to see moss, lichen, and sedge. So tundra, automatically you will be doing some skiing, sedge. So sedges I can remember. Moss and liches also need to remember. Moss, lichen, sedges, rhododendron. Just try to memorize. So now let us try to quickly revise taiga. Taiga, it is fine for what? Fine for three things: larch, cedar, and spruce. Right? Fine for larch, cedar, and spruce. That is taiga. And tundra we have moss, lichen, sedges plus rhododendron. Quickly revising rainforest and evergreen. It's merged. What is merged? This is mahogany, ebony, rosewood, greenheart, and dyewood. And tropic. This is tropical rainforest or evergreen. Next, tropical deciduous. Deciduous or monsoon. I just remember monsoon teak hai is sal. Monsoon teak hai is sal. Implies teak, sal, sesam, neem, mahua, bamboo, and eucalyptus. Next we have savanna. Tropical savanna. अब grasslands देखेंगे. अब what is अब? Acacia, baobab, and bottle tree. Okay. And next we have seen desert. Desert is easy. What is that? Cactus, pricks, dwarf acacia. Pricks is prickly pear and dwarf acacia. So that is for desert. A desert tropical forest. They lie somewhere between. All the tropical forests lie between equator to 30 degrees north or south. And next we have seen temperate. Temperate lies somewhere between 30 degree to 60 degree. 30 degree to 60 degree latitude. We have Mediterranean temperate. That is also called chaparral forest. Okay. Mediterranean biome. Grassland biome and deciduous biome. So Mediterranean I remember with OO, and then grassland I remember it like there is an aloo in the grass. They're also known as wheat basket of India. And then deciduous. Deciduous is British. It is very popular. There is a popular birch. Her name is and she's in the Maple Beach. Because deciduous forest they are monsoonal, and of course if it is monsoonal there are westerlies. In temperate why there is going to be monsoon? It is because of westerlies only, right? So there are those westerlies they're going to carry rain to the beach. That is Maple Beach. So so these are the tricks that I memorized. And there is also kauri. There is a in the Maple Beach there is this elm, and there is also kauri. Okay, kauri is in New Zealand. Okay, that's all. Now let us try to remember all the vegetations. Olive, cork oak. Now first Mediterranean. Oh, okay. Olive, cork oak, and what is it? It is laurel. Okay, olive, cork oak, laurel. Turtle, I remember myrtle. Okay, myrtle, and this is lavender, and it is rosemary, and aloo, alfalfa, something alfalfa, and lu is laurine. Okay. And aloo, they are very rich, humus rich, and that's why they are called mollies also, or chernozems. And next we have deciduous, temperate deciduous. They're British type of climate and they're popular. So there is a poplar oak, a poplar oak bark. Bark, I call her as bitch. Okay, poplar oak, bitch, bark. You can also spell it as bark. Her name is elm. So poplar, oak, bark, elm, maple tree, beech tree. Okay, there is also a name called kauri. She's in New Zealand. Okay, that is a deciduous. And next we have seen that kauri gum. It is also called resin, and it's very highly priced. Kauri is very highly priced. And next there are two types of climate in the Arctic region. One is tundra, taiga, another is tundra. Taiga, they are a bit. There are still trees available there. So taiga, therefore, still as there are trees available there, we need to pay fine. Okay, that fine I'm calling it as pine. Pine for what? Pine for three things: large. Pine for larch, cedar, spruce. Pine for larch, cedar, and spruce. Tundra climate, we get to see rhododendrons plus three things. What are they? Moss, lichen, sedges. Okay, so this is the revision of what? Vegetation.